Check. A very good morning, everyone, and a warm welcome to the third day of our science show conclave, happening as a 3 day occasion. For the first event of the day, we have Dr. Vaishnavi Sridhar from NCBS. She will be uh, she will be having a session on engaging audiences through science stories. To introduce Dr. Vaishnavi Sridhar, she is a scientific writer and communicator who brings both academic excellence and a love for sharing science with diverse audience. Dr. Vaishnavi holds a PhD in cell and developmental biology from the University of British Columbia, Canada, where her research focused on how proteins help different parts of a cell communicate, a work with important implications for understanding cellular function and disease. Before her PhD, she has completed an integrated BSMS in biology from ISER Mohali. Currently, she serves as a manager for academic collaborations and events at National Center for Biological Sciences, that is NCBS in Bengaluru, playing a key role in connecting scientific minds and organizing impactful academic events. Alongside her management roles, she is also a science communicator and a science writer dedicated to making science engaging and accessible across audiences. Let's welcome Dr. Vaishnavi for her session. Welcome, ma'am.
Can start now. Oh, it's on. Hi, everyone. Hi. How was everything? How has all the sessions been? Sorry, this is going to be very interactive session. So as you see, there's no PowerPoint. I like people talking to me. And it's all about stories. So thank you so much, Jyoti, Shaju sir, the entire team at VITM for having me here for the session as part of the Science Show Conclave. And I'm going to share my experiences of telling science stories and engaging audiences. My audiences have usually been children. And a little bit about me, well, there's a lot being said about me. But my name Vaishnavi, my parents gave it because they went to the pilgrimage at Vaishno Devi. That's where it comes from. And Sridhar coincidentally used to be, of course, it's my father's name, but coincidentally used to be a great devotee of Vaishno Devi. So it's a coincidence. Katra, yes, Jammu, Katra, yes. So, and why am I telling you this? I mean, some people might be, sorry, can we reduce the volume a little? Yeah, thanks. Thoda sa. I mean, why do you need this? Is it too much information? Well, maybe possibly you'll remember my name because I told you a little bit of a story, right? And the session is about stories, and stories help us remember concepts. How many of you like stories or telling stories, reading stories? Very few people. I thought I'll see all hands up. Everyone. Okay, and from childhood, of course. No, if you have books, you can tell stories. So it's about science stories, but I just brought this Karadi Tales, which I think I was 9 years old when I got this. And you have Panchatantra classics, Hitopadesha, Jataka. We've all grown up reading these stories, right? And this is the blue jackal. So how many of you know the story of the blue jackal? So there used to be the jackal which falls into this blue tub. And all these stories have morals. So if I were to just tell you, or as a child, if somebody told you, oh, be true to yourself, don't pretend. I mean, do you think you would remember that more, or the story of the blue jackal you would recall? Some story maybe which people know more is the hare and the tortoise. That I think everybody knows, right? And it's become so synonymous with slow and steady wins the race. No, so you actually slow and steady wins the race, and you remember it as, oh, the hare and the tortoise. So today what all we'll be talking about is basically different kinds of stories. I'll touch upon a little bit because I'm not a literature major or a PhD in literature or something, so those parts I'll just be touching on mainly. And then the kinds of stories, the structure to stories, like how they're structured, what all you can combine it with, and how you can use it with your science shows in your different centers, and share a few examples of my thought process, how I go about it, and finally maybe hear from some of you how you think you can use this in your centers. So to start off, I gave you this example. So do jackals really talk? Do they talk the way we do? No, right? So this is a fictional story, right? And the fiction, non-fiction, these are primarily the main genres. And then there's fantasy, so Harry Potter, witches, and all those Cinderella, those kind of things, your fables. Um, and then this is another one. This is a biography about this person called Gunther Blobel. He's, I don't know how many of you might have heard of him. So I'm a cell biologist, and Gunther Blobel basically studied how proteins which are made in one part of a cell, they're transported to other parts. So all of you must have taken cars or buses or different modes of transport to get here. Gunther Blobel studied how different proteins get to different parts of a cell. He got a Nobel Prize, I think this was 1999, it says here. And so this is a biography about the scientist. Then there's autobiographies which people write. So now I want to ask the audience, if I say science stories, what really do you think am I presenting? So like, what is the science story I'm talking about? Who thinks it's autobiographies? I'm using autobiographies to talk about science. Just to raise, there's no right or wrong answer, I'm just asking. Yes, autobiographies. How many of you think I'm using biographies? How many of you think I'm using characters like animals and birds or children or those kind of things? Yeah, so yes, combination of all of them. And for any story, what all you think is important? We need to have a structure for the story, right? There needs to be a start, your body, and your end, right? So in the starting, how do you think, what draws you to any story? Can somebody just put up their hands and share what will draw you to a story? Yeah. So some connection, childhood period. Anyone else? Flow of the story, yes, that's yes, we need a flow, we need a structure. Suspense, yes, so a lot of different things. So incident, so something you can relate to, right? Something you should be able to relate to. And also stories are really important for understanding, for concepts, and for, yes? Commonly known elements. Yes, so there's suspense, which is one end of the spectrum, where it's something new you're being introduced to, something to relate to. That's the other end of the spectrum, right? And you need to have, how many of you think the start of a story is very important? Start of the story is important, otherwise why will you read? You'll get bored to begin with. So I'll just do, from both of them, I'll just read a little bit of the start eventually. So start, body, end. And what are the other important things? So if you look at these covers, what do you notice? Let's talk about this one. What do you notice on the cover? Colorful characters, yes. So characters. So characters are important. So this is Gunther Blobel. Here is Karadi, who's narrating the story, and the blue jackal. So characters. You need a plot for the story, a concept. And you need a setting where it's happening. So which can be inferred, doesn't need to be direct. So in this case, for example, and also how you're saying the story. So you can notice a difference and maybe just tell me which is more engaging for you. So for example, it is a full moon night. The jackals are howling again. It is the second time that I have been disturbed from the hibernating sleep. Versus, it is a full moon night. The jackals are howling again. It is the second time that I have been disturbed from my hibernating sleep. So which one is more likely to make you engaged? The second option, right? So how you're saying it. And you all are lucky because you also have your science shows to go along, which is already going to engage the people. And here, so this is the setting. It's in a forest. You have, I'll come to my stories also if you're wondering why I haven't gone there. And then you have the characters, Karadi, the jackal. And here, of course, now you may think that biographies might be a bit bland, but I would beg to differ because the way this has been written and how it starts is, on a Christmas day in 1974, Gunther Blobel, with characteristic energy and enthusiasm, rushed to his laboratory to see the results of an experiment he had been planning for years. So immediately you get glued to the fact, this is set in the US, so he was in Rockefeller. So you're thinking on Christmas Day, which is such an important festival, you have this person, and a holiday, of course, in the US. I think they give 2 weeks or 1 month holiday. And this person is rushing to his laboratory to do an experiment or look at the results which he has been planning for years. And this gets you engaged immediately that you want to read more about what he did, why he did, etc., right? And in this story, you start off with this, and then they talk about the history of cell biology, what Gunther Blobel did, and eventually what happened. So now let me, I have to read my notes, what I was planning next. So basically what is important is your plot, concept, and the characters and the setting. Now I'm going to do readings of 2 of my stories, parts of it. I won't tell you the title, nor will I show you a picture. You have to try to guess what the concept we are trying to. And it's all science. These are my stories. These 2 are definitely not mine, but these 2. Okay. Hover was a hoverfly who loved being around flowers. I wrote flowers just to match. That's something I'll come to later. As a larva, he had loved feasting on many things. Now nectar from flowers was his new favorite. He had yellow and black markings, a single pair of wings, a large head and large eyes. His relatives and he were often mistaken for wasps or bees. However, did not have a problem with this until a recent encounter changed his worldview. Ma, I don't want to look like this anymore. I don't want to look like wasps. There's hardly any difference between us. I don't want to be mistaken for them. So at this point, can somebody guess what the story is about? No, I'll read further. A human confused me with wasps. I don't want to look like wasps anymore. We mind our own business. So that's when Ma says, have you ever wondered why humans just shoo you away, Hover? Because they think you are a wasp. They think, just this part. Have you ever wondered why birds and humans avoid you and they don't hit you or eat you? Because you look like a wasp. So this is a hoverfly which looks like a wasp. So that is the concept. So this is mimicry. So you all have heard of camouflage, right? So mimicry is one way in which harmless insects or animals or organisms look like something which is harmful. So in this way, hoverflies which don't sting look like wasps which sting. And now, so this is the concept. So mimicry. So the story was when mimicry matters. And this was published in, I don't have the original Hindu copy because I don't subscribe to it, but so this was published in the Hindu. Then there's another story which, yeah, I don't want to show this. The molecules in water were a free and active bunch. They created quite a ruckus, unknown to the unsuspecting human. If a human could see these molecules through a microscope, the ruckus would be no less than a fish market. Whoa, look how I move. Ice, water, and water vapor each had a personality of their own. They were all forms of water and were made of molecules. Who knew that water molecules in a glass were having a party of their own? Unruly than the molecules in ice, more disciplined than those in water vapor. What do you think this story is about? States of matter, yes. And it was called the chaotic dance of water molecules. So this was a children CBT publication. So this is where it came out. So, and in both these stories, can somebody help me with the mimicry story? What is the setting of the story? Maybe someone from this side. We had people from this side answer. Setting of the story. Just where it is set. Could be a garden, right? Could be a garden, and your character is Hover and his mom and other insects. And in this case, the water story, where do you think it was set? Yes, in a glass of water or a lab, yes. And so basically this is the structure. So you need to have a concept for your story and the different characters. That's how you can engage, and the tone of your voice, different gestures. Maybe you can also dress up for the part. You know, children really like scientists wearing gloves and a lab coat and those kind of things. And I need more interaction, so I'll try to ask you a lot of questions. And you think in your science shows, so you all are more experienced in science education, communication on a daily basis than I am. So do you think that just narrating a story is enough? What else do you think we can do? Maybe you can raise your hands and tell. What else can we do? Certain props? Gestures? Cues? Yes. Stories to be connected. Anything else? Known to unknown. Yes. Magic. music, yes. And not just that, and I think through you've had amazing set of sessions these past 2 days. So stories you can combine with your hands-on activities, like fun with chemicals, liquid nitrogen. How do you think we could do that? Maybe you could have your chemicals set up and let's say like a rainbow. So I'm talking about the red cabbage indicator. So you have a rainbow, you have an array of things, and you can just say that, oh, today we had two siblings, Abhi and Idhi, they came to our museum. They set up, they love magic, they love different things, and they have this setup of colors. And they want us to solve the mystery how this rainbow came from this just one purple solution. I'm going to use my hands because I don't have the solution in front of me. So the red cabbage solution, red cabbage indicator, it is purple in color, you would know, and if you add acids, it will red, and bases, it is blue, so it will give you the rainbow. So you can start off with a story, and then you can go to your hands-on activities. So that's why stories alone in silos will not work. That's what we've found, and in the sessions we've had at VITM also, it has been with some hands-on activities where I've had the wonderful mediators. One of them is there, Vidya, who's helped me also. And then there's toys. So I know you're all waiting eagerly for Arvind sir's presentation. So toys, use toys along with stories, use props, use music, use gestures, use dance, or maybe you can get a real life figure. Let's say you're talking about science toys. I'm telling a story about science toys. How great it would be to have Arvind sir in person to join, for example, or a scientist. So I'm based at National Center for Biological Sciences, so maybe you get a scientist who works on some of these aspects. So there's, and I just saw, I've never noticed, I've come here so many times, outside Vishweshwaraya Museum. I've also been to the Lucknow Science Center, Delhi, because I'm from Noida, but it was years ago. I don't recall, I'm sorry. I don't know, is somebody there from North India over here? Yeah. Yeah, Delhi near Pragati Maidan. I had been as a child, exactly 20 years was the last time I went when I was in 5th grade. So then Lucknow I went when I was in 12th grade, both wonderful places. So here I just stepped, when I saw outside, when I got off my car, I saw these ants and moths and just a beautiful nature setup. So how cool would it be if you start off with some of these stories, ask children to identify insects, maybe get an expert along with it. Right? So those are different ways. Sorry, I don't have any props. I don't have slides. I don't like to work with slides unless it's a scientific presentation. And so these are the different things, and games. So for example, so I also used to work at the Science Center in Vancouver in Canada before coming here. And even here you have your different exhibits and galleries. So there is, I think in one of them there's like a path where like what, mirror maze, and in some, maybe that's another place. I think in a children's park I saw, huh? Mirror maze, yes. Mirror maze, and let's say you have, like a dotted line for children to do the hopscotch. You draw the boxes. Let's say you have that set up on the floor somewhere, and you want to talk about the digestive system. So you assume you're a food molecule and you start. So that's play. And you start with your mouth or whatever, you jump and then you go. This is all for younger children. So what are the audiences that you all get? Like maybe you can just share. Because do you think these kind of stories will work for all audiences if I were just to read it? How many of you think yes? Yes. And what all kinds of audience do you get? Students, school students? General public? All ages, families, and are they all from your upper middle class, English educated families? Wide range? Yes. So you have to also, like I think one of you said, we have to be able to relate. So now if I was to talk about something which is not relatable to someone, or even parts of India, if I were to do something which I can see commonly in Bangalore and talk about it in Delhi, that's not going to work. So you have to modify your stories, modify how it's going to go. And let us say we had children or members of the community who had hearing disabilities. How do you think we could, what do you think we should do? We have to get somebody who's an expert in sign language, or maybe it would be great actually, for the museums. I don't know if this happens, maybe some sign language training would be helpful for children with hearing disabilities. If somebody is visually impaired, you might need braille, you might need things tactile, you might need things to touch. or if somebody has the physical disabilities, maybe the play thing I talked about, you won't be able to do. So there has to be a way we can engage them. So I think we talk about these concepts of EDIA and museums and science centers being the centers which are the most public facing. Like, let's be honest, science, labs, we do a lot of things, but we are more public facing than we are. So these concepts of EDI, we can, and you can do it through your story. So for example, I don't know if you notice, so here this Hover is talking to his mother. He's sharing his feelings, so the empathy. So you can share your feelings. In one story, I talk about a seahorse which goes on a paternity leave, right? For example, of course, maternity leave, all of the people know about, but paternity leave. Seahorse, and do you know why seahorse is going on a paternity leave? Yes, so he's going on a paternity leave. And in another one, it is, I don't know if I pulled that out, it's in my folder. It's about a mango tree and a snake who are friends. I mean, this doesn't happen in real world, obviously. That's why it's a fictional story. And they both share points about each other. The mango shares why it's important for visitors to visit its tree. Why is it important for birds and insects to visit mango trees? And seed dispersal, for both of them. And the snake is very protective about his friend. So he's just hissing at whoever is coming at the tree. And then the mango tree asks the snake why it's particularly not fond of human beings. So it talks about how it's a non-venomous snake, but humans confuse it with a cobra and try to hit it. So it's trying to be very protective of itself and just hiss at them to turn them away. And worst case scenario, it will bite them. So it's a rat snake. So this story was called Havu and Mavu. So whoever knows Kannada knows Havu means snake and Mavu is referring to the mango tree. So that's the other thing, local languages. Hindi, Kannada. So all my stories are in English, even though I can speak in Kannada and Hindi very fluently. Hindi, I have to revise. It's been forever that I have written in. And Kannada, I can't read and write in. So you might also need to get language experts, depending on if you have children from let's say, government schools or members of the public, right? Or if there's from different underrepresented, underprivileged, I don't like that word, underrepresented or underserved communities which we have not served properly. So it could be from tribal communities. I think there's a lot of centers in eastern part of India where you might be getting a lot of people from tribal communities. And you also have the mobile science exhibitions where you take your exhibits into rural setups. So there and things they can relate to, because if I have to talk about something very high profile, again, that's the wrong use of terminology, but something which is more of an urban setup, they won't be able to relate. They won't appreciate what your story is about. So these are the different things. Sorry, I'm not watching the time, so the time is over there. Yes, I see the time over there. So basically, you need to have a structure, flow, and the characters. So are there any questions at this point? Are there any questions at this point? Because then I am going to actually have to see my notes, what I was planning, because in the flow of things, I have forgotten what I wanted to say. Yes, so now I want to talk about how my flow is, how I do these stories, why I got interested in it. And then I want to give a major chunk to hear from all of you, how you think you can use stories, science stories in your science shows or for science communication as such, right? So the first story that I wrote officially, so I've loved writing stories. I've done, most of my science communication has been science outreach ever since I was in undergrad, so for almost 10 to 12 years now. So just analogy, so the first activity I remember was under the microscope, we showed paramecium, and the children were like, I was like, what do you think this is? So you ask them. I think asking questions helps. And they're like, this looks like slippers. I was like, yeah, slippers. So if you see under the microscope, paramecium, they're shaped like slippers. So that's how it started. And I've done a lot of public outreach events, more like treasure hunts. And this writing as such, I started from 4 years back. Science stories from a year ago. And that too, there was a contest about DNA Day. So the day when the structure of DNA, no, rather, yes, that's what it was. Yes, so structure of DNA, and in US it's a national day. It's not in India anyway. So there, again, I started with these two characters because siblings, so I have a younger brother, so that's what motivated me, essentially. So Abhi and Iddi, and there's a story to this. So when he was 2 years old, Abhi he would call himself, for baby, he would say Abhi, he couldn't say baby. And Idi is Didi. So whoever knows Hindi or related languages knows Didi's older sister. So, and then they're celebrating. So this is a character, it's set up in the house. And to relate, so DNA structure you all know is like a spiral. So it starts off with Abhi eating noodles and wondering about spiral things. And then you go into the structure. So my thought process, I usually start by thinking of a concept, like some of you said, known to unknown. So either something that is unknown, something that I am interested in, and I draw from things around me. So for example, when Jyoti said one of the science shows you all do here is fun with chemicals. So off the top of my head, I thought of a story for actually like a magic show. So that's something I'm going to write about now. Something that you draw upon. And do you think I just open my computer and I start typing? What do you think is the thought process in my head? I want more people talking. Sorry, I don't want to be the only one who's talking. Otherwise, I'll just point to people and ask. I don't want to do that. What is the thought process? Do you think I know all these things? I am a cell biologist, but do you think I know how the DNA structure was discovered, what mimicry is, water molecules? Yes, I mean, we've all studied that. Or about invasive plants, or about rat snakes. Do you think I know all this? Yes. I need to study, I need to develop, because I think the onus is on all of us. There's so much misinformation. Onus is on all of us is to be accurate. And I'm trained as a scientist, so even if I have to write something fictional, my credibility will go if I write something which doesn't make sense, right? So you have to do a lot of research. And for research, you can turn to there's research articles. Some of them are freely available. And there's many people who are, and you don't need to read that whole 10-page article or something. There's a lot of science communicators, science writers who are modifying these for diverse audiences. So you could read those. And I think scientists will be more than happy to help experts. You can write to them. I know all the different centers, you must be connected to some scientific institution or the other wherever you are at. And even my stories, I actually, especially the ones on environment, I have run them by my friends who are wildlife biologists, wildlife ecologists. And I also ask them, can I take this creative liberty? Can I say this bird is talking to its mother? What if it's an organism where as soon as the bird is born, the mother is just gone? Then I can't bring in the mother, right? So those kind of things. So, and they tell me whether I can take the creative liberty or not. Cell and DNA, I'm not worried because that's my field. So I can do those things. But even then, a lot of research goes into these stories. So it takes me a lot of time. And then, of course, with your work, and it's not on you to write the stories. Maybe you can reach out to someone and you can just think. I don't think it's very hard to do. And it's writing and rewriting. I don't know how many times I'll write a big 1,000-word draft, bring it to 500, make it 600 again, just breaking it down. And these are for the paper. So Deccan Herald and Hindu, I have a word limit. And this is a comic which some of my friends, actually this is another resource you can look at. It's called the Comic Library. And my friends run this. I'm not saying it because they run it. They actually use science concepts and they make comics out of it. And it's freely available. And actually for underrepresented and for, I think for museums and all, they'll be happy to give free subscriptions also. So that's another source, the Comic Library. Of course, these newspapers have the stories and there's books. And there's picture books. I think it's more smaller. It's only 500 words. So you have to put the concept in the smallest part. And I have touched on, it's mainly science, right? So general like water cycle, ecology, DNA, cells, and there's a lot which are in the go. And also I used to write a lot of science poetry and poetry in general. So I work in rhymes, so havu and mavu, or something just randomly comes into my head. And I've also been trained slightly in theater, so that's why the gestures, the voice, modulation, those kind of things. And there was, so there's a lot I'm working on. Some are just random, not really science. One is called Slithery and Blue. I mean, I need to work on that one. What do you think it must be on? Slithery and Blue. How many of you think it's about snakes? Because slithery, okay. So it's very random. When I asked my mother this thing, oh, that's the other thing. You can make children, if you have children, you can make them read and, tell the story to them and see what the response is. Well, yeah, just to get an idea if your audience is actually getting it. Because if something is too much facts, then it may not work for a broad audience. Then maybe it's just for high school or university educated people and those kind of things. So even she thought it's about snakes. So this is so random, you might think how randomly my brain, scientists do think of random things. So Slithery is a soap, by the way. And Blue is his friend who's a detergent soap. So this is about history of soaps and the principle of soaps. And the idea I got is, soap, sometimes you're washing your hands, it just goes to the drain. So Slithery likes going to the goal post, the steel goal post with holes. It hates sitting in the box the human puts it in the cage. So, and if you go into deeper meanings of it, it's more like people don't like being caged, freedom. But so that's for an older audience. But I don't think we need to go because this is not a literature class. This is a science show. So let us not go over there. And while I think of what more things I want to tell you, does somebody want to tell me how they think they can use stories in their day-to-day? So what kind of activities do you all do? If we can get different people answering from this side, maybe, sir, what all are the different activities that are happening in your science center? Maybe you can just share. Okay. 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 And what kind of science shows are okay. So this is a Dhruva and for Dhruv Tara and all for very nice. Yes. Oh, that's very nice. Where else do you think you can use the stories apart from Taramandal? Taramandal you all are already doing. So which other? Ha ha ha. Okay, okay, okay. Okay, okay. Ha ha. Okay, okay. And where else do you think you can use stories? I mean, no, not as a question, like as a part of this, just to take away. Huh. Yes. Yes, yes. Yeah, yeah. Yes, 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 yes. Perfect. Yes, yes.
If it is a human biology gallery or
नहीं
a
सर अब
heritage
बैठिए
gallery,
बैठिए सर कोई बात
so it's required the story. If you are starting from the medieval India or ancient India, then the medieval India, the science is there, ancient India is science there in India, and after in the modern time, we have this is the achievement. So we have to basically decide whether we start, what's our body, and whether we have to conclude. So apart the situation, if we are doing the workshop, we are doing the public program, or we are doing the gallery demonstration, the story is required anywhere, everywhere, sorry. So this is my opinion.
Thank you, thank you. So sir is using stories already. Is anybody? I think there's sir over there.
Apart from Taramandal, we use stories even in our galleries sometimes. We have a section on heritage science and technology. There is an exhibit related to the atomic structure. So we relate it with the story of Kanada,
Yes,
the
yes,
person known since ancient time.
yes, yes.
We tell the story about Kanada and then we relate it to the Rutherford model and other models. And we try to tell them like that. In the same way, we have another exhibit like Pythagoras. We relate it with the Shulva Sutra. We again tell the stories about how our Havan Vedis were formed in the ancient times, and we tell the stories about that. Even in some other exhibits, we have a very large vegetable in our science center, which is recorded in the Limca Book of Records. we tell the story now to the even to the elder people and to the younger people also, instead of only students, that we should go for the organic farming. And not even museum, even in the hotel we are staying in the eco home hotel, the people arranged us very well. I saw there was a story on the notice board that some person who was leading in the organic farming in the Bangalore or in the Karnataka, different stories about his work was there. That is also a exhibit. So we can use stories for students and even younger person and elder person.
Thank you.
Good morning, madam.
Hello, sir.
So apart from my colleague person, generally we are doing on ecosystem biodiversity, nature game to conserve our biodiversity. We connect some game actually, nature game, involving student teacher and which the pyramid, that is the eco pyramid, with some toy and kit we develop, and with that we some participatory game also there, participatory system is there, so that easily can demonstrate, because on identification is one tough part of the biology, as you are biology background also, madam. So that thing also we are taking into easy way to with this demonstration, the storytelling, or by engaging some such type of prop.
Very nice. Thank you. So I think a lot of you are using stories already. So this is something. Did you learn something new before we go to sir? Sorry, I just want to. Did you get something new out of this? It looks like everybody is an expert here already. So did you all feel, before we go to sir, I just want to ask, is there something new you got out of what I shared today, or was it something you all already knew? You can be honest. I won't feel bad. No, can we get a show of hands? Maybe did you all get something new out of today's session? Yeah, because I also like feedback for, sorry sir to cut you off, I also like feedback because that's how I improve. And I think Jyoti mentioned in the very first session at the end, she said, as you all would have realized, it's all about improvisation and how you take, I think you said something on those lines. And toward, like how you learn as you, on the first day, I think you said at the end. I watched that YouTube. So yeah. So I remember, I just start and I saw, and then I quickly went all. And I think you've learned a lot. The pyramid, Adiga sir showed, there was so much information that how much you retain if you just read something, write versus you talk and then you apply. That's why I said stories won't work alone. And I think we have such beautiful examples, and we'll hear more of how people are using stories along with the show that they can retain. And one thing I wanted to share, but I thought that people think this way. That's why I didn't share this here, because in my society, I started a story club and other places, and very small. And one of the parents told me the same thing. They said, can you tell our children something about mythology and then add science to it? So I think beautiful examples. I didn't say it here because I thought as scientist, you may expect me to not to say. So I'm planning to, and I relate random things. So not really random. So I'm going to talk about, for example, next session, Kalinga Mardana story. You would know, like Krishna. And that's a venomous snake. And then I'm going to tell my story about Havu and Mavu, of how all snakes are not venomous. So that's my science, and there's science, and then there's your mythology added. So wonderful. And I think sir over there, sorry sir, sir, you had your hand raised before we go to sir. Yeah.
As you told that what we learned today, what we discussed, that what I think we mostly use the existing stories mostly in whether it is in the Tara Mandal or in our galleries. But what I learned that we can add some new stories also to the even suppose we have a butterfly park. We can add. I was thinking about some stories of that how I can enrich that for the kids, because mostly kids visit that, and even some other parts of our galleries. We must add some new stories, taking ideas from you.
Thank you so much. Thank you. And there's actually a guide of butterflies. I'm sorry, I had one copy, so I just didn't bring it. So there's a scientist at NCBS, actually, Dr. Krishna Megh, who has developed this booklet of butterflies. And I think he'll be happy to share it with educators. So maybe I can just share it with Jyoti, and then she can share, because you have a butterfly park, and he does a lot of outreach. So then it will be very nice to marry these things along. And all of these stories, except some which I have to scan and share, rest are available online or as PDFs. So I'll be happy to share. And Jyoti has most of the copies, but because her daughter loves reading them and I keep sharing. But I'll be happy to share. And if any assistance, I love interacting because I've been a beneficiary of the Science Museum, Science Center, because since the age of 3 or 4 years, so when we came back to India from the time I was 4 years old, my parents took me for nature walks to the Delhi Science Center and all the museums. Delhi has so many museums. You all know the National History Museum. And there used to be, no, natural history, and there was one which got burned down, unfortunately. Natural history, though IT, okay, and then Dolls Museum, of course. So all these different museums, from the age of 4, I and my brother, we've all gone. So we are a beneficiary of the system. So we'll be happy to contribute, however, and try to reach as many members of the public. I won't say children. Most of my thing is focused on children, of course, but members of the public, because I think there's so much potential which is untapped, and it's not important that we're talking about science only with scientists and with the people who know. Those who don't know, well, I won't say don't know, because they, let's say if you have tribal communities, what we call the indigenous knowledge, they may have so much knowledge, and maybe we can learn from them. So maybe some stories they can come and share, so that kind of dialogue can, I'm just suggesting because you all are in the position to implement some of these things. So the dialogue, because I watched a documentary where there was a lady from Orissa, she's a farmer, she's from the tribal community, and they grow indigenous varieties of crops, millets, rice, and she says, sorry, I'm going to say in Hindi because I translate what she said. She said, ये ऐसे मार्केट का ये वाला राइस, ये वाला वीट ये लोग हमको दे रहे हैं, हम तो कितने साल से ये उगा रहे हैं, बारिश होता है तो भी ये उगता है, धूप चाहे जैसी भी हो, because it's resistant varieties. It's not what we get our Sona Masuri and this and that. I think there's a variety of Sona Masuri which is developed to withstand also. So, you get from the indigenous knowledge, and they know, especially for the ecology and all, there's so much you can tap into to hear from them, because they also should be given an opportunity, a voice to talk. Okay, so after that, sir, sorry I cut you off so many times. Sir.
Actually, we are having a dinosaur park, prehistoric park in our center. There the
so which
storytelling...
center, sorry if I'm asked?
District Center, Tirunelveli, Tamil Nadu.
Tirunelveli, okay.
Yeah, we have a prehistoric park where the storytelling is a vital part in that, because all age group will enjoy,
Yes.
primary to the senior citizen,
Yes.
how the carnivorous dinosaur, herbivorous and the flying, with the whatever the fossils we are getting, from that is fully imaginable.
Yes.
And we can start with a very interesting story.
Yes. Yeah, it can just be somebody who's just walking in and they find a fossil and just you relate. And there's actually, I think this is happening in India in a, maybe we're not popularizing it a lot is what I feel, because outside I know people who I'm connected through on LinkedIn. So one of them is a chemist by training, very senior professor. She writes comic books, chemistry comic books, to teach about the periodic table. And then there's others who are talking about the same thing you said, like evolution and DNA, those kind of things. And also there are research papers which show that storytelling can help drive the understanding and concepts of certain things, especially evolution. I need to read more research papers, but there's researchers who found this. So that's the proof for the, sorry, is there something? Anyone else from this side who wanted to share about how they could maybe employ stories in their galleries or centers, or they're already employing? You can also bring in experts. Sir, which center are you from?
I'm from National Science Center.
Delhi. And sir? Kurukshetra. Guwahati, yes. The Kurukshetra also I think we went when we went to the temple. I don't remember. But we went to the temple, we must have gone. But sir, that was 15 years ago. Temple, because we had gone. So Kurukshetra, Delhi and Lucknow I've gone. We would have gone. I'll have to ask my parents, they'll know more.
So for the comment, I hope that we are having a very interactive storytelling session. And sorry to interrupt, but I would like to invite Mr. Manas Bagchi for some comments that he has something to share on the same theme, because he himself, I must say that he himself is a storyteller.
Yes.
So I invite Mr. Manas Bagchi, who is a consultant Science Museum Projects and former director CRTL, to just put up.
Namaste.
Thank you very much. I almost pushed in actually because I wanted to make a few comments on this. And when she says that I'm a storyteller by my surname because my surname, my full name is Manush Bagchi, and Bag means the voice, the talk, the sentence, the prose. And Chi are the people, Chi is a postscript added with it to mean that one who tells stories. So traditionally, actually, our family, long back, were the people who were doing a living on telling this story. And when I took charge of the Calicut Science Center, this became news as well, though unwillingly, because first day I met the press and the press asked me, what's your name and what does it mean? So I said, my name Manush means mind, and Bagchi is actually, as I explained, the storytellers. So next day the Hindu made a headline that Bagchi, the storyteller, takes over RSC Calicut. But anyway, that's a different story altogether.
No, I will remember your name, sir, now properly because you told the story. Thank you very much. I think all of you will
Yes,
now.
and that I told this story because what I mean by story is actually any story. And Kurosawa once said a very nice thing. He told that film is the art of cheating to tell the truth. So you mix cheating, you mix lying, you mix up any imaginary thing, and it's not that you have to talk about mythology, you have to talk about this, that jumping, that coming, that showing, that doing. Not required. Perhaps what is required has been defined by one book that I would suggest to everyone. It was written almost 3,000 years back. It was Poetics by Aristotle. Poetics by Aristotle is the definition of storytelling, what it should be. What he says, first, have a protagonist. Second, position it in time and space. Create the environment. Create a character cycle. A character begins with something, changes over, and comes to be something else. And that character may be a live character, that may be an object, that may be anything, that may be any shape, color, situation, everything. I give you a very small example from The Godfather. The Godfather, you have seen Sarkar perhaps, which is an Indianized version of Godfather, where the so-called mafia don, he rules over his domain, his so-called fiefdom, I'll say, and then his younger son doesn't like it at all. His younger son completely despises it, and he always decides that I will not be like my father, I'll be something else. And he becomes the protagonist, and his father is initially the antagonist, and his father gets killed by some scenario, and this boy has huge feeling for his father as father, not as the man, the king, the don, but as the father. So when his father gets killed, he feels a rush of blood. He feels that this is not done. I'm going to change it. And he becomes his father, and he becomes the don again. And that's the character cycle. Now this character cycle may be good, and we have a problem. I think we in science center communities, we have a problem that we have taken the burden of always telling people that this is good, and that is good, and that is good, and that you must do, otherwise you will die. And that's a nonsense. Because reality doesn't have any obligation to follow what is a moral narrative. The reality is reality. I'll tell you something else, which is a story which is told by a very, very famous science journalist who was very close friend of me for quite a long time. You know Abdus Salam, the Nobel Prize winner in physics from Pakistan, who came to India. And my friend, he said, I almost lost my job because of him. He said that I knew that Salam is coming to India for giving out some lectures in certain institutions. I followed it all through the day. I went to this place, I went to that place, and I always drafted what he has spoken about. And then I came back to office after the day because he had retired to his hotel. So I thought it is the end of the day, so I'll go back. And next day, my sleep broke with the phone call from my editor, and he said, "You idiot, come to me." And I just went through every newspaper, and I found that actually Salam came to this country to meet his mathematics teacher in Lahore University, who was in deathbed, and everybody printed a photograph that that man, his name is Anil Dhar, he was lying on the deathbed, he could not move, he could not identify people, and he's just lying, and Salam is on his chest like this. And he said, "I missed that story. I missed that human being. I thought he's going to talk about equations. I thought he's going to talk about phenomena. But I missed the man." So I was almost losing my job. Somehow I was saved because some other people said, okay, let him go by this chance and all. But the editor was very harsh. And then, flash forward 30 years. I was moving in a plane, and one person was sitting by me, and I was introduced earlier that this man is the head of the science journalism division of New York Times. So I introduced myself that I am such and such, and the person I'm talking about is Potik Guha, who was the science writer in Telegraph. So he said, "I'm such and such, and nice to meet you." And he was very angry, and he said, "Oh, you are that idiot." I said, "What is that, this?" He said, "You are the person who wrote that Salam piece." And he told, "Yes, I wrote this story about Salam." "Yes, you know what you did? You know what something wrong I did?" He said, "Yes, you made me wait 7,000 words to read the final line where you wrote Salam, Salam." Should have been the heading.
Yes.
So we used to call in science journalism community that you have a very difficult task. The research paper community is coming to you with a definite interest of certain problems. But you are people here who are actually willing to go to mall, but you are trying to drag them down to your place for some purpose. And hence, don't become them all, but give them some original alternative of the mall that is interesting and lucrative. So he said there must be some grease element that will allow the reader or the writer or the viewer or the spectator to slip into your story within first 5 lines. If you can't do that, then you have missed the bus. By that time, he has gone to Sophia Loren or to, I don't know whom. He had a favorite character. I'm not taking that. He used to call, then he has already moved to Sunny Leon. So don't worry about coming back to your pace once again. And there lies this story. You have to compete. You have to create something new. It doesn't need real characters. It doesn't need anything. I'll finally just bow out with one story, and that is, I went to Sundarbans. What she was talking about is very much relevant in this sense. In Sundarbans, we made people just after Aila. And in Aila, everything was devastated. So we made several farmers, and one of the farmers, he was lamenting that we have lost our land. It is all saline water now, and now we cannot cultivate paddy in it. So I just naively, I had no idea what is possible. Very naively and very stupidly, I had asked him, don't you have any other paddy which can grow in salt water as well? And he said, it was there. But in the lure of high-yielding varieties, we have lost them 40 years back. Now we don't have the seeds. Now we don't even know the technique how to grow them. मेरे बाप दादा जानते थे वो कैसे करते हैं, अभी हमको तो पता नहीं. We have lost our livelihood. This story of their lives, of our life. So this story has to include life in any form. may be fictitious, may be real. Use and adopt the art of cheating to tell the truth. Thank you very much.
Thank you, sir. Thank you so much. No, I don't know if I can top that because I think that was the perfect way, and I think sir summarized everything so beautifully. And just from Abdus Salam, I recall there's a play, The Trial of Abdus Salam in ISC. Actually, NCBS will be hosting it. We are trying to make it a public. So I've told my friend already I'll reach out to VITM or whoever's in Bangalore at that time. August end. August end we are planning. So they'll be the same troupe, they'll be doing it in NCBS also. And I had asked my friend, and also NCBS has I'm not promoting our organization because I'm from there, but we have a wonderful archives. So history of science. And I was just asking these people that we have Abdus Salam, we have even the same troupe has done on S. Chandrasekhar, Nobel laureate, C.V. Raman's nephew. And I asked why not women in science, why not other, and because S. Chandrasekhar also, by the way, was a US citizen. And Abdus Salam was, I think, a British, because you all know that, I don't know, this is going to be on YouTube, I don't want to say it, but people say it. Pakistan revoked his, or he was forced to give it away because of his community. Yeah, I'm going to say it, I'm not going to mince words about this. So anyway, and then she said that, these have good records, so maybe, like sir is saying, we need to have better records, better stories, putting them together and having them in one place so that maybe we can do science plays. And science plays is another way, and I think there was script writing session, right? So, yeah, and I think No problem. We were just ending, so yes, I think I would just end there because I think that was a perfect way to end with a perfect summary. And thank you so much, and I hope you all tell more new stories along with the old ones. Maybe you marry something you think of and you add. And the human aspect is very important because as scientists or people related to science, we just get into this fact, ye ho gaya, wo ho gaya, ye sahi hai, wo galat hai. We get into that. The human aspect is important, and now in the days of AI, and you see children who are just on their laptops and phones. Yeah, I have issues with that, I'm sorry. My phone is somewhere, I'm somewhere else, so that is the thing. We are losing the human touch. So I think more and more we need to get the real life stories in the stories that we are telling, the human aspect. So if you talk about scientists, talk about the person who Abdus Salam was, rather than along with his thing. If you talk about Kannad, talk about the person. I mean, of course, he was there years ago. I don't know what records exist. Or if you talk about Dhruva, maybe talk about Dhruva's story, like about his mothers, maybe, and all. Just, because children need to know these things. It's not something that they grow up and they're like, acha, empathy is a thing. No, from childhood you need to know these things. And I try to incorporate in most of all the stories that I have. And interaction is very important, communication. So that's where I'll end at. So tell stories, you all are telling, and this is a great audience. Thank you so much. Hope something new you all got. And thank you so much. And I hope you enjoy the rest of the sessions.
Thank you, Dr. Vaishnavi, for bringing in various aspects of storytelling in science. Now we will have a very short tea break for 10 minutes and we'll get back at 11:10 because our next session is starting at 11:15 exactly. Yeah.
Hello, hello.
Hello, sir. Hello. Sir, mute the rise. Sir, mute the. Hello, hello.
Can you hear me, sir?
Yes, sir. Now we can hear you. Yes.
Oh, good. Oh, that's very
Sir,
nice.
but
And you can see me.
sir, we can see you,
yes.
but your video is now. I think the internet is slow. There. Anyhow, now we can see you. We can hear you, sir.
Okay. All right. Oh,
Sir,
that's very nice.
Sir,
good.
Yeah. Sir, just one small information I just
Yes.
wanted to tell you. Sir, our session will
Yes.
start exactly at 11:15, sir.
Yes. I
Okay.
just logged in if there is
Yeah,
some
perfect, sir.
technical glitch.
We
Yes.
too wanted to test once before.
Oh, good.
Yeah.
So,
So-
I'll just leave it like that. 11:15, I'll be back.
Absolutely, sir. Thank you so
Oh,
much. Thank you for joining
thanks
us,
a
and
lot.
we'll
Bye.
get back. Yes, sir. Thank you.
Bye. अभी लोग का टेक्निकल अभी चाय का समय है चलो टेस्ट हो गया तो आवाज ही सुनाई दे रही थी अभी टेक्निकल ग्लिच
ते झाल्यावरती कपडे भाजून करून त्या घरी काम करून येते मग नंतर परत टाक मला काय म्हणायचं मी जेव्हा आगला आणायला जाईल कोणी आलं काहीतरी सामानच घेऊन आलं कोणीतरी पाहिजे ना है ना काय जेवण झाल्यावरती तयारी करू तिकडचं काम झालं हो झालं काय ग सुनीता तुझं नाही ग रोजच चालू आहे ग असं नाही तुला झेपत नाहीये का रोजच रोज काही ना काही प्रॉब्लेम आहे कधी संध्याकाळी आणि कधी येणार का तू येणार खूप भाव काय बोलते ते काकांचे इतकं घ्यायचे त्यांचं आता सुरू होते
Motion.
Check. Welcome back, everyone. For our next session, we have the most awaited Sri Arvind Gupta sir, who is a Padma Shri awardee and a social innovator. His workshop would be on science through activities. We all know the stalwart whose work has touched countless lives, yet it is both appropriate and inspiring to recall his journey as we begin this program. A man who turned the ordinary into extraordinary. Sri Arvind Gupta sir has shown us that science can be taught not just through textbooks but through the magic of play and power of imagination. Sir is a celebrated Indian innovator and an educator who pioneered the idea of making science accessible to every child through low cost, no cost toys crafted from everyday materials. His work has become a cornerstone of hands on learning in India and abroad, especially in under resourced schools. With over 1,200 toys, numerous books, and video lessons in more than 18 languages, he has revolutionized the way science is taught. Sir has been awarded the Padma Shri by the Government of India in 2018. Sir has also been awarded the National Award for Science Popularization. He has been recognized by UNESCO, NCRT, and numerous educational bodies. We are truly honored to have Arvind Gupta sir with us today for this online session. I request all of you to join me in warmly welcoming Sir as he takes us into the world where science comes alive through joyful, hands-on exploration. Welcome, Sir.
Well, thank you very much. Can you hear me, please? All right. It's my honor and deep privilege to be able to address the NCSM activists who have been working in all our science centers for years. This is the 60th year of the NCSM, and my deep pleasure to take you through my journey. I did a BTech from IIT Kanpur, 70 to 75, and I worked in Tata Motors for a couple of years. In between 1978, I took a year off from my job, took a study leave, and I went to the Hoshiarabad Science Teaching Program. This is probably the most revolutionary program in the country in terms of learning through activities. It was started by Dr. Anil Sadgopal. He did a PhD from Caltech, was a senior molecular biologist at the TIFR. He was 32, 33 when he quit his job and he went to this village. And at that time, they discovered 50 years down, in the early 70s, that no schools had a science lab. All science was learned by rote. Children mugged up formulae, mugged up definition, came exams, and they spit it off. So they said, this is a very bad way of teaching science. And the MP government gave them 16 schools where they experimented for 5 years to devise something which would be appropriate for our children. In 78, I spent a year over there. And I said there should be some local component in this. There should be a lot of, if the program has to be a success, we can't be dependent on big cities. We must start from what is available. You see, in the 70s, there was a political slogan: go to the people, live with them, love them. start from what they have, build on what they know. This was the kind of defining political slogan. So I said that there was a local bazaar at that time, a weekly bazaar called as Heart in Hindi. And I said, I will go there and buy one specimen of everything which was available, which was sold on the roadside. And there were bangles, there were little mirrors and matchboxes. I bought all those. And then I was getting my bicycle inflated and I saw this. Now this black tube, rubber tube, is a cycle valve tube. And at that time, this is 78, it's some 47 years back, I bought 10 feet of this. It was 10 paisa per foot at that time. And I was doing some, and I just discovered that if you take two matchsticks and you push them inside a piece of cycle valve tube, you make a very flexible joint. It's a very flexible joint too. And with this, we can start teaching angles to children. It's an acute angle, a right angle, a obtuse angle, a straight angle, and a reflex angle. It's like a universal coupling. You can transmit drive at any angle. This could be the motor, this could be the machine. You could connect them straight at 180 degrees. But you could also transmit drive at an angle like this. So this is the nice thing about this. If you had three of them together, you could, if you had three bits of cycle valve tube, three matchsticks, you could loop them together and make a triangle. And it's a very special kind of a triangle because matchsticks are mass produced in a factory. All these matchsticks are uniform length. So what you automatically make is an equilateral triangle. All these angles are 60 degrees. And similarly, you can make a square, a pentagon, a hexagon, all these two-dimensional shapes. And they have some very nice properties. If you look at this pentagon, for instance, just pull this out, this becomes a boat shape, becomes a trapezium. If you push this in, this becomes a kind of a house shape, a combination of a square and a triangle. And if you push it further, this becomes an isosceles triangle. But it's very, very shaky. If you inspect the hexagon, for instance, these are, if you just pull this out, this becomes a rectangle. If you push this in, this becomes a parallelogram. But this is like an amoeba, which is constantly changing its outer profile. Even if you look at the square may look very square and prim, all 90 degrees. Give it a push, it becomes a rhombus. A patang ban jata, it becomes like a kite, it becomes like a barfi. So children see that all these, whether you look at the hexagon, the pentagon, the square, they're all wobbly. But once they try the triangle, nothing happens to the triangle. The triangle remains a triangle. And that's the bedrock of all civil and mechanical engineering. If you wish to make any structure stable, you've got to divide this into triangles. The people in villages live in roofs, in small houses. And if you see all the roofs, the truss is always a triangle. They never make their roofs as square roofs because you put tiles on top, it's just going to collapse. So ordinary people have known the properties of the triangle for millennia, and they've used it for living a better life, right? Similarly, if you take the same joint of two, make a hole in this and push a third matchstick. And what do you make? You make a T joint or a joint of three. And if you look at this triangle, make holes in the three corners, three vertices of the triangle, and push all the three legs in the three vertices. And what you would make is a lovely tetrahedron. Tetra means four in Greek. Hedrons means triangles, made from four triangles. We just saw that the triangle was the only rigid polygon and has a three-dimensional shape, which is composed entirely of triangles. And it's just logical to assume that it must be a very fundamental structure. Now, the tetrahedron is like nature's own brick. All bonding is essentially tetrahedral. If you look at the structure of methane, CH4, it's a tetrahedron, and here is a molecular structure of methane. What we've done is we've just put four marbles And inside, in the center, is a small bead, which represents the carbon, and the four marbles represent the hydrogen. So school-going children could make very simple molecular structures with something very, very inexpensive. Because if something which is made inroads in our villages 50 years back, it was the bicycle. And if you don't have the matchbox, you can't light the chula. You can't light the home fire. Similarly, if you had two triangles and put four walls, you made a prism. With four, you make a, or you can also make a cube like this. And as you make the joint of four, you can also make a joint of six and a joint of four like this. This is the joint of six and this is the joint of four. Now with these, there are lots of possibilities. You look at this pyramid, the top of it is a joint of four. And this is the joint of four. Two bits of cycle valve tube pushed one inside the other. Now, once you make these basic structures, you could put the pyramid on top of the cube. And this looks like a house. Similarly, if you look at take the prism, for instance, put the tetrahedron on top, it looks like a temple kind of a structure. You could also make an icosahedron, all the five platonic solids. And similarly, if you make joints of six, as I showed you, but you only use five of them, not six, and you make this icosahedron. And the nice thing about this icosahedron is that you can flex it. Now this becomes like an igloo. And so this is in 1978. I was a very young engineer, 25 years old, and for the first time I thought that I was using my whatever little learning I had done in the IIT to good use. I wrote my first book in the early 80s, Mastic Models and Other Science Experiments, which came into 12 Indian languages. 10 years back, it was translated into Chinese. Since then, I have written 25 books, and I have sent a Google Drive link to Jyotiji, the curator of Vishweshwaraya Museum, and she would share them with you. And with a click, you can download all these books and you can share them with children and teachers. So this got me very, very excited. 1978. And then I thought it was much better than, much more fascinating and interesting than making trucks in a factory. So I quit my job after that. And since then, I've been traveling to schools, hundreds and thousands of schools. I've been to 3,000 schools, worked in 25 countries. And one major inflection point happened in 2003. I'd spent 11 years in Delhi teaching in small schools. And 2003 came back to Pune, my home base. And then I was invited by Professor Jayan Narlikar. He passed away last month. India's most decorated astrophysicist, Padma Bhushan at the age of 26, right? He worked with Hoyle so he had set up the Inter-University Center for Astronomy and Astrophysics in the Pune University, 17 acres in 1988. And Professor Narlikar had a great vision. He said that we must have a children's science center. In Ayuka, we offer a PhD in astronomy and astrophysics, but we must have a children's science center. Imbue children with the love of science. Catch them young. This was his dream. So he invited me to work in the Children's Science Center of Ayuka. And so that was a great privilege. We had a small team and a small room, 400 square feet, and two amazing colleagues. They're probably the best people on earth. Dr. Vidla Maheskar, she was an immunologist and was at Stanford for 4 years, came back after a postdoc and said, I want to work with children. And another person, his name was Ashok Rupne, who now heads the ISER Pune Science Center, the Indrani Balan Science Center. So the three of us, we worked there for 11, 12 years. And every day we would document a small toy. And we made small, we put them into books, we put them into photographs, and we made small videos, 2-minute videos. These are called as toys from trash, and just 2-minute videos. And we started a YouTube channel in 2007-06. Today we have 8,700 short videos, 2-minute videos in 15 languages. We have 350 videos in Spanish. There was a postdoc student who had come from the Dominican Republic, Dr. Bricio Canaflaca, and she came to our center and saw all those toys. And she said that I come from such a poor country. This is what my children need. Spanish was a mother tongue, so Breezy dubbed 350 videos into Spanish. And as you probably know, that the Spaniards were the first colonialists. And so Spanish is spoken in 26 countries. So billions of children across these countries have seen our videos. We have about 12 crore viewers of our videos without any advertisements. And you will see that in none of in those videos, you will see my face. Faces are boring, right? So we have the material, step 1, step 2, step 3, and once the toy and the model is made, there is a new child playing with them. These are our heroes and heroines, and we need to salute them. So that's what we did. In 2004, just the next year after joining the IUCA, I set up a website and I put all my books. Today we have about 21,000 books on my website, and books in many, many Indian languages. Every day, 10,000 books are downloaded. 2 crore books. In a country, I've been to 3,000 schools. You see libraries being locked. You see, if I go to any school, I say, I'd like to visit your science lab. And despite all the talk and hype, if you go to the lab, you will see all these shiny cupboards with burettes and pipettes and glass bottles lined up. But if you're perceptive, you will find there is a grime of dust on all this equipment. Because all that equipment is meant for the inspectors, it's not the children. So we said that in my preambulations, I found bad managements, bad principals, bad teachers, never a bad child. So we said that we must take it straight to the children. All children want to do things. They want to make things. They want to break things. So we put them all in the public domain. I'm going to show you some other things. Now this is, we have done about 50 experiments with plastic, with straws. Now this is an ordinary plastic straw, and we just flatten one end. So it becomes, this is, you can just see that this is slightly, this is not circular, this is circular, but this is slightly flattened. And with the scissors, I'm just going to cut a point. So you can see this becomes like it's like a crocodile's mouth, you can see, opening and closing. I'm going to put this in my mouth and blow my lungs out. It makes a very, very loud noise. You're not able to see how the sound is produced because this reed, R-E-E-D, which vibrates, was hidden in my mouth. I'm going to keep this out and suck in it. And now you see what's happening. What's happening on this end is opening and closing at very fast rate. It's vibrating. Now, children don't need to mug up that for production of sound we require vibrations. They could actually see them, experience them, enthrall the whole class. And, well, there are two fundamental principles of education. First is from the concrete to the abstract. Don't start with formulae, don't start with definitions. You're going to bore children to death. Start with simple toys, start with simple experiments, which will captivate their imagination. And the second is from the near to the far. Don't start with burettes and pipettes because they are alien to a child. Do you use a burette or a pipette in everyday life? No, you don't. So you start with everyday objects with which children are familiar with and show them possibilities in that. And then science becomes magic. It becomes a way with them. Now, we saw this. The other is, of course, we can make a couple of holes in this. And the other experiment, of course, is to keep blowing at it and keep cutting the straw. You can hear a whole range of notes. The longer the straw, the lower the pitch. The shorter it becomes, the higher becomes the pitch, and the shortest straw has a very high pitch. There are a few other experiments with straws. Now, this is a slightly fat straw, you can see. And what we've done over here is we've just cut 4 notches, V notches with a scissors. 4 notches like this. And then taken a thread, woven it through the straw, tie a knot over here, and I've just put a golden tape. Transparent tape would not be visible. And that's it. And now if I pull the string, what happens? Look at this. It's like a robotic finger. It's a 2-minute toy. Another very nice toy is this. You take a fat straw, seal both. Now, you apply tape, flatten both the ends and apply tape and seal them. Then with the scissors, cut the top right and the bottom left. So there are 2 diametrically opposite holes. Fold the straw into 2 and nip off these 2 corners, and you will see a diamond-shaped hole. This is the diamond-shaped hole. Over here, this is the diamond-shaped, right? And then you take a fat straw, and what we've done is, you can see in this straw that there is a hole over here. This is a small hole over here. Why? This hole, if I shut this end and I blow, air would come out at right angles to this hole. That's the purpose of this hole. So I put it inside this, shut the end of the straw, bring my spinner on top, and I blow. Notice the direction of rotation. If I reverse the straw, you will see that the direction of rotation also reverses. This establishes Newton's 3rd law of motion, that every action is equal and opposite reaction. And it's simple. If a child can see a science principle in a toy, then the child embraces it. It comes naturally to a child. So avoid these bombastic languages. Give them a rich experience, a very rich experiential base with different kinds of materials. And then with a rich experiential base, the theoretical concepts, the equations, the definitions will fall into place. Now, this is a it's a 100-year-old toy. And this is a darling of every physicist. Now, you take a pencil with a rubber on one end, because sometimes when children make a mistake, they want to erase it. They want to rub it. So this is the rubber. What we've done is we've made 3 or 4 notches. You can see these notches with a penknife, slightly deep V notches. Take a card sheet, rectangle, make a crisscross to locate the center, make a big hole in the card sheet, in the propeller. You push a pin in the red rubber of the pencil, and you can see this fan is a little bit loose over here. It should not be tight fit. And this white rubber piece is like a stopper to prevent the fan from flying away. And if I just rub on these notches, something very amazing happens. The propeller spins. Why does it spin? Now, this is non-trivial physics. There's 6 major research papers on this story. But every child can do it. You don't need the 6 billion Hadron Collider to do this. And I tell children that you must certainly make this toy if you want to survive school. Most of our schools are downright boring. There's much more fun outside the school than inside it. That's why most children don't like to go to school. They're pushed by their parents to go to school. And schools have a vested interest in making money. But as you make the story, when the teacher is giving notes, you should be seen writing and taking notes. And when the teacher turns her back towards you, every child should be doing this, because that's what God sent them for, to play and have fun on earth. Now, this is a very fascinating toy. As a child, I used to make it with a square piece of paper. My friend V.S.S. Shastri must have enthralled you with his creations. But when I was a small child, 4 or 5 years old, I learned how to make this. Take a square and make a big triangle out of it. Fold it again and make a small triangle. And this is like the letter V, V for van, V for victory. And the V, they also look like the ears of an animal. And what you do is just tear them and make 2 long and slightly rounded ears. Fold the front and fold the back. And in less than 10 seconds, you have Mr. Rabbit. Hold the legs just below the body. Grab the tail and move the tail backwards and forwards, and you have a flapping ear rabbit. A 10-second toy, just a scrap of paper, and it always, you'll find a smile on a child's face. You will see a gleam in their eye. That's the power of toys. That's the power of models. I'd also like to say, I've been to many NCSM centers. 2 years back, we did an experiment in Pimpri-Chinchwad, which is a suburb of Pune city. There is a science center, a kind of a NCSM science center. It's in 6 acres of land. And they found that the footfalls were falling because you have these huge exhibits everywhere. And many of the exhibits sometimes don't work. There is no one to explain to them. So the management was very worried about this. So ICER has a science center where my friend Ashok Rupner works. And they invited them. And what they did, in that big center, they gave them 1 room and called it as Kalpak Ghar. You know, kind of an innovative house of innovation. And over there, they had lots of paper, they had broomsticks, they had straws, very ordinary material. But children were not seeing there. They were actually making things there. It was an activity center, not just to see. You see, you forget. But once you do it, you remember it. And soon they found the children, all children were going to the small room, Kalpak. So I think that this should, so many, we have, I think every district has a science center today in our country. So there should be close to 600 science centers. I think we must have those large exhibits, they have a role. But much more important, have a small room where children can make things and break things, right? With simple material. And then they'll be very, very fascinating. Here you see that there is, if you take another square piece of paper, and this, of course, many people would be knowing, in 3 minutes, no glue, no scissors, and you make this flapping bird. The kids in Japan have been making this for the last 300 years, origami. It comes from there. And what we did was, we took the same thing. We made the Japanese crane, bird, and we put a small fan in the tail. It's a fan-tail bird. With this ball pin refill, and an ordinary ball pin rotates in the ball pin refill. So the ball pin refill is the push of the bearing, and the pin is the axle. And this is like a small helicopter fan. And if I spin it like this, you can see that. It's a very, very fascinating toy for children, right? It costs no money at all. Just an old refill, you can make 10 of these. This is Now, this is something called as a flex game. This was designed by a mathematician at Harvard, Arthur Stone, in 1928. In 3 years, this model will complete a century. And what do you see over here? There are 4 pictures. You see, what do you see? Butterflies, frogs, snakes, eagles. Butterflies, frogs, snakes, eagles. 4 pictures which come in a sequence one after the other. And this could be a food chain. Insects are eaten by the frogs, frogs are eaten by the snakes, snakes are eaten by the eagles. But if you take a A4 size paper like this, no glue, no scissors. You just need a scale and a pencil. In 3 minutes, you can fold this. It's amazing that paper can rotate like this. And once you've made this flexagon, the possibilities are endless. There are so many natural cycles. You have the cycle of the seasons. Now it's the monsoons. Monsoons will be followed by the winters, and then the spring, and then the hot summers. The life cycle of the frog, the life cycle of a butterfly. So many cycles. There's cycles and cycles and cycles. And this is such a nice way of depicting them. If you take a small piece of paper, you can make a small flexible. There are not too many models in science, in paper, which rotate like this. Now, this is a 14-page. This is a 14. Hello. This is a 14-page unending book. You need 2 squares, a little bit of glue, and this picture book can rotate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it restarts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Amazing. 2 minutes to make a picture book like this. Every child, I just saw the schedule. There was science through stories. Every child has a favorite story. And the child can take that story, divide this into 14 steps, and then illustrate every step. And then every child has a 14-page rotating dynamic picture book, and each child has a different picture book. How fascinating. It doesn't cost much money to do that. This is another fascinating. Now this is like a drummer. You can see it's like a drummer. This is the backside. You can see there is a broomstick over here which goes inside a straw. And fascinating. But this is if you have an A4 size paper like this, A4 size paper with a quarter, you can make 4 of these. And what is this toy? Now this toy is a fascinating toy. There is a natural spring in paper. And if you have 2 like this, well, you can become a sannyasi. Very nice toy. It's like rabbit's ears. And this is, of course, a gift from a girl from China. And the world is just discovering how clever the Chinese is. The Chinese invented paper. The greatest magnetic and optical toys come from China. And this is, you saw the rabbit? This is like a flapping butterfly. See this? And it's a 2-minute toy. See this? There is a small fruity straw. This is the one with the red lines, fruity straw, and which goes into a big straw, and you can see this like these are a crane fly. Because if a toy has a dynamic element, something moves, something spins, something makes sound, it is much more fascinating for children. You know, still toys are like sitting ducks. Children get bored with them pretty soon. Now look at this. This is the back side. Now first I'm just going to show you. You can see that this is a staple over here, a staple. one in the arm and one in the hand, right? And which similarly over here, you can see these are just staples over here. Now, if I just overturn this, you can make the small skeleton, and it can do all kinds of, I think this should have been a hit on Yoga Day, because even Baba Ramdev would be hard-pressed to do all these yoga exercises, right? It's splendid, absolutely. And you just need, what you need? A stapler for this. Huh? Nothing very fancy about it, right? Well, one of my most well, we make lots and lots of pumps. 31 pumps to be precise are there on my website, arvindguptatoys.com. I don't think anyone makes so many pumps in the world. I'll not be able to demonstrate to you all of them, but to just give you an idea of a couple of them. Now, this is a pump which you can see this black part is old cycle tube. And first, what does it do? It's a balloon pump. It inflates a balloon. So I'm just going to put a balloon over here and fire. If I keep doing this, well, the balloon would pump. It's a powerful pump, and it's a real pump. We have a slogan on our website that the best thing a child can do with a toy is to break it. Why do children break toys? Not because they are terrorists, because they are the only inquisitive cats. They're curious. They want to know what is inside the tummy of this toy. So a good toy is the one which you can pull apart. So you can take this. What is this? It's an old film can. Can you see the film can? We have made a hole in the center, and over here, if I blow, green light, that passes through. Can I suck in it? Red light. One way traffic. And that's what a valve is. This is my suction valve. And this is the lid. There is a hole over here. And there is a, this is the delivery valve. And there is a straw over here for the air to pass through. That's all. That's it. No glass parts, nothing to break. Children can pull it apart and satiate their curiosity, know what is inside it. So that makes it, and it's a workable pump. It's an ISO certified pump. You can actually inflate a balloon with air. That's the nice thing about this. There is a very nice book by my friend Sudarshan Khanna. It was published by the National Book Trust. Sudarshan studied at the National Institute of Design, and he taught there for 40 years. At some stage in his life, 30 years back, he was teaching design, properties of materials, composite materials, and it occurred to him that our traditional toys are the greatest deposit, greatest use of materials, recycled materials in our traditional toys. So he wrote a book called as The Joy of Making Indian Toys, which is published by the National Book Trust. You can find it on my website. And I was privileged to translate that into Hindi for the National Book Trust. And this toy comes from that. Now, what is this? You can see this is a capsule. And in this capsule, the nice thing about this capsule is that inside this, there is a steel ball. There is a steel ball bearing inside this. And what you can do is, I've got a small tray, just a kind of a V channel, and I'm going to just put my, so you can probably see this. Now you see what happened. Fascinating toy for children from old capsules. And there are 100 toys in Sudarshan's book. And of course, now, a few things about matchboxes. And you know, what this is the Vikram Sarabhai Community Science Center. You know that Vikram Sarabhai was the architect of India's space program, and he was a pioneer. He set up the Community Science Center in Ahmedabad, and in 1962, it was Sir C.V. Raman who inaugurated the center in Ahmedabad with the lecture, Why is the Sky Blue? And after his untimely death in 1970, the Community Science Center was renamed as Vikram Sarabhai Community Science Center. And what they did this nice experiment. Every child was given a matchbox, same size, and with a challenge thrown in that you have a week's time and you've got to fill small things in this matchbox, one specimen of each. And the child who's able to pack in the maximum number of different things in the matchbox will get a prize. Very simple to understand, nothing high-tech about this. So the children understood it well. They went back home and a child pulled out the matchbox, put an eraser, put a small rubber. Well, it almost got filled up. And then a girl went to the kitchen. Mother was cooking poha. She took a mustard seed. She took a cumin, jeera, one seed, one moong ki dal ka dana, ek chawal ki kani, one hair, a little strand of thread. So the whole week, children were looking at the micro world around them. What are the small things around us? And after a week, the children all came with the matchboxes packed to the school. They were all asked to stand up and they were asked to shake their matchboxes. Some matchboxes made sound. Was it a good thing or a bad thing? Not a good thing at all. Because of the sound, if the matchbox is making a sound, which means there are some voids, there's some empty spaces inside, so they were out. And each child was given a plate and they had to empty out their contents. And one child was able to pack in 150 things into a matchbox. Isn't this great science? With all our expensive equipment, we are doing bad science all the time. We can do most exciting science with the simplest, humblest materials around us. Because in the essence, science is not hardware. Science is the way how critically we look at things around us, right? And we must not forget that burette or that expensive apparatus which we have in labs and we put them into cupboards and lock them, they are cheap. The most expensive thing in a science lab is a child's mind. Nurture it, excite them, catch them young. So this is one. This is another one, a very nice experiment. Here is a matchbox, and you can see very clearly. On the outside drawer, I put two paper clips. The paper clips are starting, and there you are, out, so that I can weave a thread through them. If I the matchbox comes shimmering down. Very, very exciting for children. You can have another. Very nice. Just a thread and a matchbox. You can see this is how I weaved it together. And if I move my right hand, the matchbox travels on the thread trail. Exciting for children. They can put a picture of a picture of what? Picture of a rabbit going hop, 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 right? Put a picture of a lizard there. Look like a lizard climbing a wall, right? Many, many things, possibilities with that. Well, something which here is a very, very exciting model. Now, this is something which 1990, it's 35 years old. The American Association for the Advancement of Science brings out a magazine called as a Physics Teacher. And every issue of the Physics Teacher had an experimental column called a string and sticky tape experiments. What all you can do with very simple stuff, string and sticky tape experiments. And later on, the physics teacher collated 25 years of this column and put in a book called a string and sticky tape experiments. You won't find it anywhere but on my website because I digitized it. Now, the main idea of this is a small electric motor. The most expensive thing is the battery. Battery is 40 rupees. It's a new battery because if you want the motor to work, the battery should be, you can't chant any mantra and get the battery, and get the motor to work, right? There should be power inside the battery. So it's a new battery, no mumbo jumbo. Now this is old bicycle tube. Even in a city like Pune, if you go to the best stationery shop, which is Venus Traders, and you ask, I want broad rubber bands, they will say, so we don't have it. But India has given a word called as jugaad to the whole world. If you don't have a thing, think, apply your mind, think of an alternative. And the bicycle tube is amazing. It keeps both these safety pins in contact with the two terminals of the battery. So this 1.5 volts across this. These are two very cheap ferrite magnets, 1 rupee each. And because it's metal clad, they stick over here. Now I've made a coil and I'm just going to put the coil Now this is a simple electric motor. We made about 1 lakh motors with children in our science center. You see, 11 years, we did 2 free workshops every week with children. 3 hours, 50 children would come to a school, spend, in the course of 3 hours, they would make 10, 12 things with their own hands and take it with them. And I think that experience they'll never forget in their lives. We also saw that from the 4th, little children require much more personalized attention. We've not geared for that. But children from 4th to the 8th, this is this small window of 5 years which we have. Children from 9th, 10th, 11th, 12th, they don't come to the science center at all. They will not even come to the Vishweshwaraya Science Museum or to any of the NCSM because you have these Allen classes, you have these Chartes classes which eat them up, right? They never come there. So this is a small window. We thought that if we can give them enthralling experiences, they're never going to, we'll just put them on the right. Let them get a taste as to what good science is, right? Later on, when they grow up, they will realize the farceness of all these coaching centers, which means they don't teach you anything creative at all. You never done just some tricks to crack. You put a black mark on a multiple choice question, nothing very great about this. And this is the biggest industry today in this country. And the government has seceded to all these edtech companies, right? And this is a simple electric motor. Trust me, children just sit down in a corner. I can't describe you the gleam in their eye, how happy they are. And once they've got the motor working, Faraday's laws of induction, they stand so much clearer. The concept becomes absolutely clear to them. How does the motor work? First you make a motor and then you go to the theory. Then it makes much more sense that the theory falls into place. This is a small, which one has got of, this is a rubber. It could be a Hawaii slipper. This is a little rubber band to put the pencil so that both together. And these are 4 magnets, similar kind of magnets over here. Now, here's a pen over here. The front magnets attract. So they are opposite poles. I don't need to know which is north, which is south, but they're opposite poles. The rare ones are similar poles, so they repel. So the rare ones are pushing it, the front ones are pulling it. If I put my finger over here, you can see this pencil is just hanging in the air. It's levitating. And I can give it a 12, but there's a lot of friction. And I'm not chanting a mantra. These are magnetic forces. These are forces of nature. So I take a small bit of CD. Old CDs, glass you can't cut, but old CDs, DVDs you can cut. And there you are. It spins, it levitates, it writes. China has these maglev trains. If you land in Beijing airport, the airport is 70 kilometers from the city. In 10 minutes, on a maglev train zipping at 500 kilometers, you're in the city center. This is reality. Something costs less than 15 rupees, and our children can get a taste of what maglev is all about, right? This is another thing which I want to share with you. And now these are neodymium magnets. Of course, China today, neodymium magnets. The China has squeezed, tightened the screws across the world. They sit on the largest reserves of rare earths, and they're not supplying it to India. They're not supplying it to the world. So all the EV industry has come to a standstill. They're so powerful that I can't separate these two. And this is a 10 ml syringe, and the discovery was that they go very nicely. You can see that it is moving inside. So this is my magnetic circuit. I put a piece of rubber. So this moving magnet is my magnetic circuit. Now I take thin insulated copper wire. And how many turns? 36 gauge. Copper is expensive. 1,000 turns. Children take half an hour. They just wind it like this. And the start and the end of the wire, you scrape and you attach an LED to it. Now you see. I'm going to shake this syringe. The magnets are going to move back and forth, back and forth. It's like a moving magnetic field, very powerful moving magnetic field. Lines of forces are cut by the coil and an EMF is generated. You can see this LED. We have made a generator. We are generating electricity. Whether we have a 230 megawatt generator, the principle remains the same. Now, all of these, imagine a girl in a village, a Dalit girl in a village where there is 6 hours of power cut, makes a small syringe generator like this. It's truly empowering. She said that today I've lit up a small LED, tomorrow I'll light up my village. That's the kind of empowerment these small models have. And they can be owned by the children because they're extremely low cost. I'm going to show you a few more things with the Tetra Pak. The Tetra Pak this is the Tetra Pak. There is a book of mine called as Little Toys by the National Book Trust. I wrote it 35 years back. They're probably in the 20th edition now. The Tetra Paks had just come in as miracle material, which is today they've changed the face of packaging. But if you look at the Tetra Pak, this is an icosahedron made from an old fruit juice pack, right? Now, these Tetra Paks are terrible from the point of view of the environment. The silver part is aluminum foil. The 2 layers of plastic and card sheet. And for any kind of recycling, you should be able to separate the plastic and the aluminum and the card sheet, which you can't. So this is going to be lying in a landfill for the next 700 years. Terrible material. Now this is the lassi, the Amul lassi. If you measure the length, the width, and the height, multiply them, it's 200 ml. It's written over here, 200 ml. This is written over here, 200 ml, right over here. So it's a very nice measure for 200 ml. If we just took another Tetra Pak, cut this into half the height, and this becomes a very nice measure for 100, and this is 50. So you can make your own measures, measuring cylinders for measuring volume. And the nice thing about this is, suppose you take this 100 ml box, Tetra Pak, I fill this to the top with water, right? And it's full to the brim with water. How much water inside this? 100 ml. And I've drunk 100 ml of water, and then I take my cup, flatten it, and I keep it in my pocket. Every child should be doing this. And they'll get a very good feel about volume, right? Similarly, you can make a very nice, this is a fruit juice box, 1 liter box. You can make a very extremely nice purse with it. You can see there is a 10 rupee note over here, and and a very nice purse with this. There is 2 pockets over here, and there's a little Velcro, so it's totally waterproof. It's an ideal purse, and it's a designer purse, if I may call it. And on a rainy day, it will keep your money safe, right? There are many puzzles, and this is something called as an inside-outside cube, and this is the network for this puzzle. 6 squares, right? And now this is the puzzle. Now I'm just going to make a cube out of it. And you can see that this cube is silver, all sides are silver. Then I flatten it, give it 2-3 twists, and it's colored all over. This is the inside-outside puzzle. Now the Tetra Pak with 2 layers of plastic and aluminum is an ideal. So Little Toys has 40 toys. I said, the beginning says, don't drink from a Tetra Pak. Pick up a Tetra Pak, and I'll show you how to make 40 toys out of it. Now, this is another one from Sudarshan Khanna's book. This is The Joy of Making Indian Toys. This is the broomstick. Jhadu, karata jhadu. A long one and a short one. You tie them very tightly, and you can just put an eraser inside. So this is, and you perch it on your index finger. There's a big side, and you spin it towards a big side, and this becomes like the Sudarshan Chakra. Centrifugal force, centripetal force. These are very abstract forces. Even people who teach do not understand them, right? It's through playing with small toys like this that gives you some insights into this. And there was a boy in Pune, class 4th, who was inspired by this model, and he made this, and it won a prize. Now, for this 4th standard boy, it was like a satellite. You can see these. What does a satellite do? It goes around the Earth. And these are the solar panels. And so this is like the satellite for this boy. Yes. There's something which I really want to share with you, and which is this model. This comes from the VSO Science Teacher's Handbook. VSO, if you don't know, is the biggest British charity, voluntary services overseas. In the last 40 years, they have sent something like 50,000 British children, 20 years old, 25 years old, into the third world. Go and live in a slum there. See what the conditions are. Try to help them change the condition. These volunteers, they just get their airfare, and they're paid what a teacher would be paid in India. They don't get paid in pounds. 3 of them got together and wrote the VSO Science Teacher's Handbook. This was tried out in 20 poor countries, which somewhat, I was sent by UNICEF to 50 British schools to do workshops, and then VSO invited me to their headquarters. And when they saw all my stuff, they said, oh, go ahead, translate our books into. So I've translated the VSO Science Teachers and the VSO Maths Teachers Handbooks into Hindi. We've got this into Marathi. I think someday some people will do this into Kannada, into Telugu. They've never done. It's not been done. Now, this is a model of a skeleton. You take, this is A4 size paper, just half. You make this size. You fold this into 8 parts. With one part, you make the skull. Second, you make the rib cage. You make the pelvis. You make the arms. You make the hands. You make the legs. Now, it's a very nice scale model of the human skeleton. There are 200 odd bones in a human body, but this is a good representative. So this is as far as the biological model goes, but it can go beyond biology. Ask children, is the skeleton of a man or a woman? Is it a he or a she? Is it Mr. Jain? Is it Mr. Hussain? Is it Mr. Lane? The kind of poison which is being dinned into our children's minds, the kind of communal venom, right? We all have the same skeleton. The Genome Project only demonstrated that 99.99% of all our genes, humanity shares the same genes. So this is a model which goes beyond biology. This is to test our much deeper, deeply ingrained biases. Catch a person because that person believes in a different God. Kill him because he eats different food or he speaks a different language. This is nonsensical, right? That's why it's not. Well, I'm going to come to an end. In the end, I'm going to show you that we, of course, make lots of newspaper. It's the cheapest paper available. So we make close to 20 caps using newspapers. Now, this is like Sachin Tendulkar's cricket cap with half a newspaper. And when one child makes the cap, the whole child, there's a peer pressure. No child wants to be left behind. The whole class wants a cap. So everyone starts folding. And if you fold paper, it's like a geometry laboratory. All the polygons of the angles which you talk in the abstract, you're concretizing that. And at the end, you make a cap which you can actually wear. And it's such a nice cap that you can fold it. And I always carry it in my pocket because I have no hair on my head. And I just keep it in my pocket when I go out in the sun. I put it on. This is a very famous Gandhi cap. Half a newspaper. Very nice. It's a Gandhi cap. In the end, I'm going to tell you, this is a very favorite story. And this is by Lillian Oppenheimer. She set up the New York Origami Center in the 50s, 1950s, 75 years back. And for 50 years, she regaled children with this story. It's called as a captain's hat story. Now, this captain's name was Topi Shankar. He was a captain of a sea-going ship. And you know that people have traveled by train, they've traveled by bus. Very few people have traveled on a ship. So it's a great experience for them. But the first 2 or 3 days, the passengers like the journey very much. It's a unique experience. But after a couple of days, all they see is the wide blue ocean, not a patch of land, not a tree. They become bored, they become seasick. Topi Shankar was a very clever man. The captain invited all the passengers on the deck, and he said, you sing and dance, make merry, enjoy yourself, I'll provide you with good food and drinks. Topi Shankar had a suitcase full of different kinds of caps, and he would join the party every day. On the first day, he would wear a huge umbrella cap. If the captain is standing on the deck, it protects him from the scorching sun, it protects him from the rain. It's an umbrella kind of cap. When the passengers would go to sleep, Topi Shankar would take the same cap and give it one more fold. And the second day, he'd be wearing a new cap. Now you can just see from the side that there is a chute at the back. This is a fire brigade people wear a cap like this. This is very necessary for the nature of their job. Fire brigade man goes into a burning house. Some rubble can fall at the back. So this chute at the back must protect the spinal cord. That's why they wear a cap like this, a designer cap. Second is a fireman's cap. And second night, he would give it one more fold. And third morning, he'd be wearing a shikari cap, an explorer's cap, an adventurer's cap, cap number 3. And third night, he would give it 2 more folds fourth cap. And in Maharashtra, it's a very, very famous cap. You know, Bollywood, Mumbai is 3 hours by bus from Pune. And if you look at any of our Bollywood films, the policeman, the cop, always wears a cap like this. In Maharashtra, it's called as a Pandu cap. It's catapulted to international glory because we make the largest number of films in the world, and all our dance dramas seem to be liked by everyone, right? So 4 huge, one is a huge umbrella cap, second is a fireman's cap, third is a shikari cap, and fourth is this Pandu cap. And we must not forget that Gopi Shankar, after all, was the captain of a ship. So this was a ship, and everyone was enjoying the journey very much. And suddenly, Kali Badli chha jati. The black clouds, it starts, there is lightning, and it starts to pour cats and dogs. There is a storm in the sea. And what can a small ship do in a storm? It is rocking and pitching with the waves. And then a huge wave comes and slaps the aft of the ship and knocks it. All the passengers are terrified. We had come for a picnic, but our ship is broken into two. सबके चेहरे पे हवाइयां उड़ने लगती हैं, पसीने छूटने लगते हैं. एक और लहर आती है और पिछले हिस्से को ऐसा थपेड़ा मारती है, knocks it down. अब जहाज के 3 टुकड़े हो गए और जहाज तेजी से समंदर की गर्त में डूब रहा है. It's sinking to the center of the ocean. Now there is a saying in Urdu, बला अकेले नहीं आती, मुसीबत अकेले नहीं आती. छप्पर फाड़ के आती है. And a third huge wave comes and slaps the bridge. The triangular portion of the ship is called as a bridge and knocks it down. Up. Now, Topi Shankar's ship is broken into smithereens. The ship sinks, and of course, the captain has lost everything. All his caps. He loses everything. All that remains is a life jacket. So this is an amazing story which Lillian Oppenheimer told to children for 40 years and regaled them. With this, I would end my lecture. Thank you so much for listening to me. Goodbye. I can see my friend Shastri ji. So nice to see you, sir.
Thank you very much, Arvind sir, for this simply fantastic show, and the way, I mean, it's an online session, but I feel that it, it touched upon our souls also, not only our bodies. Thank you so much, sir, for this wonderful session, and I hope that the simple ways of doing science, how big and deeper impact such science shows can, science probes can have on our science shows. I hope we'll all take a leaf out of today's presentation. Now the floor is open for the questions. If it could be a question, or it could be some of the experience that any one of our participants would like to share. Yes.
Sir, I'm Binoj from I'm a Binoj Education Officer from Kerala. Actually, some of the items you showed here, I was following 10 years back itself. Whenever teachers from Kerala ask me about websites, I always used to say toys from trash. So that tumbling capsule, then magnetic levitation, etc., we used to show to students in Kerala also. Thank you, sir.
Wonderful. Wonderful.
Sir, as my colleague, Mr. Binoj just mentioned, yes, that is for sure that each one of us have got not only a glimpse of it, we have put our hands on many of the toys that, taking reference from Arvind Gupta Toys website. And that's how, that was the first and very, introductory, experience of each one of us towards getting a nuisance or the whole basic understanding of how should we engage the students for doing science, and it has always been a very great guiding force for all of us. I also request those who have joined us online, if they would like to share their experience or they have some questions, please, you can unmute yourself and speak. You may raise your hand also in that, and we'll unmute you. Shastri sir, I can see you from the beginning of the session.
Yes, madam. It is always a pleasure, to listen to Arvind Gupta ji, and he is a pioneer, and he has shown, the way, to reach children. And I think your participants, should ask, more questions, and also get clarifications.
Yes, sir. That is sure. That is for sure. So, but I hope that we all enjoyed it, no doubt about it, and we are all going to implement a number of these, very simple to implement toys in our practices of science communication. So, with this, I would give this mic to my colleague, Ms. Abhunati, to present the vote.
Thank you very much, sir, for the profound session which left us all in awe. So this is what we call making learning joyful for children and bringing science and maths to life, right? So which is also the very purpose of the Science Show Conclave. Thank you very much, sir. I also thank all the people who have joined online for this wonderful session. Thank you all. Thank you, sir.
Thank you. Thank you.
So our next session our next session by Dr. Pavitra on interdisciplinary approach in science communication will happen in the third floor link block. We'll all move there and I'll introduce her there.
Yeah. We can inculcate other disciplines, especially into science, because you all are all science educators, right? So, Kali Nali, or the play and learn, what we just came across Arvind Gupta sir's concept of activity based. So yes, of course we appreciate it. Maximum a science teacher, what she can do, or as a science educator what you can do, you can bring models, you can make the children play with the models and make models and interesting and experiments. Yes, all that is there. But today I am here to tell another interdisciplinary approach by using our own physical body in order to become those objects. For example, our educational system today, not only today, from the day until today, it's become more like teaching on blackboard, right? We are learning how to cycle on the blackboard, correct? They are drawing the cycle on the board. They are telling this is the cycle, this is the chain, you have to settle here, you have to hold the pedal, you have to pedal the cycle, then the cycle moves, right? This is our education system which has become like that. But actually, when you have to go into the field, will that help you? Will that blackboard teaching help you? No. They should have taken us to the ground and given us the real cycle. That is what was happened that is what I heard in the morning session now. Arvind Gupta sir's session was, give the objects to the kids, let them play with the objects. My concept is, who is going to play with it? The kids are going to play with it. So once you learn physically, how many of you all can swim? How many of you all know swimming? Okay. Night 12 o'clock, you all are in deep sleep. I take you and put you into the pool. Will you swim and come out? Or will you tell, no, I need to practice swimming, or I need to recall my swimming skills? No, because when the body learns it, it will never forget it. When your body physical learns, it will never forget. But when your mental learns, it is very easy to forget. That's why today, so many classes we don't remember because we would have mugged up those classes for our exams. For example, even the poetry what we had in our 10th standard, we would have just by-hearted the poetry in order to just put it out in their exams. So this is the concept of our education system itself is like that in order to judge you on the final exam marks or on marks. But the interdisciplinary approach, what I will be talking here today is not about the final marks, but with the process of how you are going to do to go to that final marks. That is more important. For me, what our science dramas, national centers which are doing science competitions and dramas, this is not what I will be going to, I'm not going to talk about that, because that is the end product. They all come up, you all give them a topic, they practice for that topic, they put up a drama and they come and perform a drama on that concept. But the process in which the drama is performed, that we are not seeing. As judges, we are sitting there and giving them marks for the outcome. But what is the process is what I am be talking today, that how as an educator or as a science educator, we need to make it more interesting in order to the students or in order to your clients or whoever it is, in order to for them to get into the concept of understanding it better, getting into the concept of knowing it better. So today when I asked you all told sports ground, you all told school dance, you told the sport what you won, the tiffin box what we ate. So all these are called extracurricular activities, right? That annual day. We do a dance on an annual day and we still remember that, oh, 10th standard I did this dance. If you hear that song, you will tell, that you still remember the steps of the dance. If you on the tape recorder today, you will dance the same steps what you did in your 10th standard, right? Because you would have practiced for it, because your body has practiced for it. But if I ask you the 11th standard poetry what you did, you need time to go through it. Yes, you remember, but not maybe the whole gist of it. You will again go through it, you will buy her, because it has come from your mind, you have to recall it. But your body need not recall it. Your body need not. That's why I told, once you learn something through your body, it always remains, it always stays with us. So theatre or whatever concept I will be talking today relates to how physically you can involve yourself in order to make it more interesting, right? So we will play a very small game. It's a very small game played in kindergarten, but yes, I want ourselves to become kids today. This is what is interdisciplinary approach is. We would have forgotten many years back, we would have gone to schools. We all let us become kids today. It's a very simple game. We'll form a circle. And as I was telling, theatre is always group activity, right? Theatre is always group. Solo I can't do. I can't do a one-woman show. I can alone perform the drama. But I need somebody to watch the drama. I need somebody to on the light. I need somebody to, that means it is not a single activity. It is a social activity. It is a social, we are including social sciences here. We are including society here. That means our body or our neighbors, all this is society for us, right? So it is a group activity. So now relax. So this game we usually play with the kindergarten students. So need not laugh, we'll all become students now, we'll all become kids now. One opportunity to play a game that we hear in this hall. Okay. So this game is called Tom Says. Who's Tom? Tom. Tom and Jerry? Tom? Some Tom, okay. Tom, you should do only if Tom says. Right? Who am I? I am Pavitra. You shouldn't do if Pavitra says. You should do if Tom says. So the game name itself is Tom Says. So Tom, one small, revision type. Tom says, come forward. Go back. Only if Tom says you should go back. So all the ones who went out are out. Understand? So back to circle. Be alert. Back to circle. No. It's not yet started. That was just a trial. Okay, you can come closer. Okay, we'll start. Ready for the game? So the ones who have made mistake will automatically move out of the game. So we'll see who will remain. Tom says left leg front. Tom says right leg front. Right leg back. Yes, whoever put the right leg back, go. Okay, right leg front. Okay, Tom says right leg front. Woo, you should go. Tom says right leg back. Tom says turn right. Tom says turn right. Tom says turn right. Turn left. All those who turn left, please go out. Tom didn't say, sir. Okay, Tom says turn right. Tom says jump forward. Jump back. Like a full back. Out. Yes? Tom says jump forward. Okay, come closer. You're still in the game. You're still in the game. You're still in the game. Okay, Tom says come closer. Tom says right hand up. Tom says left hand up. Both hand down. Tom says both hand down. Both hand up. You're out, sir. You didn't do. Tom says right hand forward. Up. Okay, better. Clap for them. Good. Good. You all were alert. Finish game. Okay, the game is done. Okay, Tom says the game is done. Okay, this is just to break the ice, to just have a fun, nothing with the game. The game also tells us little more conscious, attentive, because we have lost that consciousness of being more attentive. We have lost ourselves being good listeners. We are always in the end of talking. We are always in the end of interfering. We are always in the end of giving our views, but we are not yet ready to receive. So this game, though it is a very simple, very, very, very playful game, very comedy game, but still it gives us a concept of patience to listen to what somebody is telling. So these are some of the preparations before going into some activities of theatre and all those things. So again, coming back to this activity, to tell you all about the concepts of how science can be involved into physical activities when you are doing it with school children and all. One small example I will give you. We know that solid, liquid, gas, the molecules, it's very easy, it's there in the 5th standard or 6th standard syllabus, wherein maximum what a teacher can do, as a science teacher what will you do to show them solid, liquid, gas? You may bring models, right? Or you may bring some things which you can tell that if these are the molecules and if it is tightly packed, these are the features or the qualities of matter of solid, features of liquid and features of gas. This is what maximum a teacher does. Maximum nowadays, because of the invention of AI and all those things, we have smart boards in our classrooms. So not much work for the teachers, like how in our days when we were students, our teachers would literally bring things and like how sir was showing, make us do activities, but these days everything is there in the click of button. Today school, not only school, none of the children need teachers. Why do they come to school? Only for attendance, or maybe for the extracurricular activities, or for the discipline, or for the name of the school, or for the certificate what the school is given. Maybe. I'm not telling yes, I am telling maybe again, I want to defend myself. Right? Why do I send my son to a school? I need all this from the school. Otherwise my son is even more brilliant than his teachers. Why? Because everything is there in a click of a button. Just Google one button, everything, the whole syllabus is there, whole lesson is there. He doesn't need anybody to explain. That explains better than me. But why we send them, but why we want them to, that is because of the society, or that is because of the social activities which is done. So you are the ones who framed the word called extracurricular activities, right? What are these extracurricular activities? Dance, drama, music, painting, sketch, making, waste, wealth, out of waste. All these are extracurricular activities according to, you people only gave that name, right? Extracurricular activities. So the one who's going to school normally without all these activities, is an ordinary child, and all who's doing this is extraordinary. Right? A school gives the overall holistic development for the kid. Otherwise the classroom or the book, for that you need so many of our we parents don't send our kids to school because he will learn the lesson properly. We want the overall development what the school is giving. Maybe the school is good at football, so my son, if he joins that, even if you get average marks, it's okay, you get into the football team. I've heard so many parents doing that. In this type of competition, how can your science, or how can we bring our science more interesting, more captivating, just by having a science drama? Will it help? Will it help? Or just by giving them lectures on science, or giving them more videos on science, or giving them more activity based on science? No, not only that, a teacher has to become an actor. A teacher has to become an actor. I want to be a teacher where my student after 10 years will search for me and come tell, ma'am, the lesson what you taught, no ma'am, I remember. Not the teacher like, oh Shia, hey, come here, let's run away from here. We have those two type of teachers, right? We have seen both the type of teachers. One teacher, she's crossing the road, you run away as soon as you see her. One teacher, she's crossing the road, you run to her. Why you run to her? Something has triggered in her classroom. That triggering is what is interdisciplinary. Something she would have done other than the subject, or something she would have done for you to enhance her abilities. That is what is called the interdisciplinary approach to science today. Because we are all of you are scientists, we are talking about science. Otherwise, you can put this to anything, interdisciplinary approach in anything, even in law. It's so tremendous and boring, or maybe so much they have to remember. Even in history, we have to remember so many dates, who, which war and what war. But nowadays I know that most of the dates are all vanished because the syllabus or the NCERT is developing other type of concepts. But still, as a teacher, how can we become an actor? We have to become an actor. Today all of you are standing like this. Are you all like this when you are alone in your room or alone in your house? Are you all standing like this? Am I dressed like this when I am alone at home? No. Today you all have come with all tucked shoes and perfume and get ready. Right? That means you have prepared for some performance. Performance is not only on stage, in our day-to-day life. The way we ask money from our father. I am going back to our days when we were kids. I know all of us are not so old. Right? So going back to our old days, 100 rupees was big for us. When we were going to school, 100 rupees means like, my God, right? So the way you ask money from your mother, very, very close to your mother. So the way you ask money, what tone? I use Kannada, others want other languages, we can plan. Like for example, if I have to ask money from my mother, 100 rupees. Ma, 100 rupai kodama. School go back 100 rupai kodama. That tone, right? Very casually, the way you ask from your parents money. But the same money if you have to ask from your principal, school principal, how will you ask? Will you tell, sir, give me 100 rupees, sir? No. How will you do? What will you do? Will you practice? Will you put makeup? No. Did you practice for it? No. You just behaved it. You just go there and tell, sir, I lost my purse, sir. Can I borrow 100 rupees from you? Tomorrow I will return it back, sir. Right? This tone, this dialogue, this expression, this body language, did anybody come and teach us how to act? Did you get trained? Oh, I should go and act. It is natural. That means each and every individual when you are born, you are actor. You are an actor. Believe it or no. Maybe we are artists because we are performing on stage. We put makeup and do drama on stage. All of us are doing drama in our real life. You don't like this session, you have to be here. You are doing drama. Correct what sir told. I am doing drama. My mind is something else. Somewhere else it is running. I have jet lag. For me now it is midnight, 3 o'clock. 3 o'clock midnight means we will feel sleepy, no? That time feeling. But still I have to be here fresh because I am talking to you all about theatre. Right? That means I am performing. How a science teacher has to become a good actor. What she can do. So I was giving you an example of that solid liquid gas, right? Solid liquid gas. So maximum what we can do as if it is in a theatrical form. We can have the whole class in a room like this. That's why I told we are going to break barriers. We are not going to sit there in front of the PPT. We are going to come to some hall. Give me some hall, ma'am, I asked her. It's okay if you stand for 5-10 minutes, no issues. But still, the activity which, if it is physical, we have to involve ourselves physically. So that is the reason. So, first thing is break the barrier between the teacher and student benches. Take them under some tree. Take them under some ground. Take them into some hall. Take them into some canteen which is empty. or some auditorium which is empty. It may be your maths teacher somebody asked me, you're teaching maths and you took them under the tree. I told, so what's there? We are playing with maths. Where do you play? In the ground only you play. Where do you play? In the hall only you play. You can't play in between the benches. Right? So the next level of what Arvind Gupta sir told, that is about using materials, physical also, more than materials. Even without materials, your body can become physical. Right? Your body, for example, he was telling about the right angle, obtuse angle, acute angle. It's very easy. 180 degree. Then you can show the right angle, acute angle, obtuse angle. You can do a dance with it. So your body is doing, when the kid is doing with its body, when he is writing, that is why we are evaluating them through their exams. When he is writing, he will recall acute angle. Acute angle means he will do like this. This is acute angle. So his physical already knows, and I told you once if your body learns, it will never forget. So this is what is the concept of what we were talking. So I was talking about the matter concept again, coming back to it. So 20 of the students are there in this hall, and we all stand. I make my students stand tightly in a square shape. So all of them are tight. So what happens? I ask the students. The students tell, ma'am, we can't move. Ma'am, we can't breathe. Ma'am, we can't take out a hand. And we can't, it's very rigid, it's very stiff, it's very strong. It is one shape is there. So these are the features of solid. So the next thing I will ask them all to hold their hands and run in the room. They are all holding hands and running. What will happen? They are flowing like water or they are flowing like some liquid. That is the features of, I will ask them, how are you all feeling? I tell, ma'am, she's pulling and I'm running with her. Ma'am, I can't go the other direction. Ma'am, we are going in some zigzag way. That means we are flowing. So these are the features of or the qualities of liquid. The next one I'll tell, leave all your hands and simply run in the room. Tell me what you feel. They'll tell, ma'am, we are so free, ma'am. Anywhere I can run. Anything I can do. So you all are the molecules, and this is what happens when you're in solid, liquid and gas. So the student finished. The class is done. 1 week a teacher takes to explain solid, liquid, gas, but in 10 minutes we did one activity and finished the syllabus. So this is what a teacher has to do, especially a science teacher has to do. Tomorrow when you all go back to your centers and when you get an opportunity to educate the science teachers, school science teachers, this is what you'll have to tell them. This is what you'll have to guide them, that you people become the objects, you people become the physical matter of, see, not all science concepts teachers, and who are the ones who is going to do this activity? Because I know theatre I will be doing. But all science teachers are not background, they don't have the background of theatre. But I'll tell you today, the kids are better than sometimes teachers when you ask them to improvise activities. Make them into groups. Give that concept. Tell them it's about, okay, motion, law of motion. Send them home. Tomorrow you see they will do wonder. They will come up and put up a 2-minute skit on that motion. You need not write the drama. You don't want script. You are not going to stitch costumes. You are not going to spend money to put a show on the stage. See, our intention here is not putting a drama show. Our intention is how the kid is learning that concept, which they find complex. So you all can identify as science teachers in your classrooms or in your school classrooms, which concepts are more complex for kids, and those concepts can be dramatized. Like maybe like one concept what Vaishnavi ma'am was telling about storytelling. One concept like how sir was telling about using materials, and one concept like how I am telling like using our own body and performing. So all these are interdisciplinary approach to science, which people think that okay, science, hey, drama and science, what are you going to do here? Drama and MBA, what are you going to do drama with MBA? Then when we go to do something with interdisciplinary, this is what questions come. But I'll tell you drama, that's the reason I told we are all good actors, we are all good at doing drama. Drama is there everywhere. A kid is born, the kid is crying. You go to the house and tell, auntie, kid is crying, I think it's hungry. But the auntie will tell, the mother of the kid will tell, no ma, stomach pain, it is crying. Did the kid tell stomach pain? Did the kid cry for stomach pain? We don't know. But the mother understood because the baby is communicating in that tone to the mother that it's stomach paining, not hungry. So the mother knows. So who you have to communicate, they should be communicated. They will understand. That That is the power of theatre. That is the power of, see, when I keep using the word theatre, theatre here is dance, drama, music, all these things come into theatre. Sketching, painting, activities, all these are theatre. Drama means, the word drama means the performance part. The word theatre means all this including drama is theatre. So we are doing theatre, we are using everything, maybe a sheet of paper also is performing there. So like this, how you can make the complex subjects into more activity based, into more effective based is what you all have to go back to your places and tell the educators or the schools. So there are a number of institutions, like if you all are from North, you have NSD, you have Pune Institute of Performing Arts, so many things are there in all centers are actually should be associated with some schools which are related to activity based or theatrical based. You all can call experts from those fields to train your school teachers or to give them a gist of how they can go about the lessons and all those things. With this, I just want to tell one small story that when I used to do my PhD research, to tell you all how it can be so effective. When I used to do my PhD research, that was the initial stages when the midday meal in Karnataka was introduced. Midday meal was given, like afternoons, free lunch was given to kids in government schools. So I went to a very rural government school, and when I went there, I asked the headmaster of the school that, sir, I am doing my PhD, and I showed them the letter and all, and I told I need 20 high school kids for my experiments. They told, you take, madam, but come tomorrow morning 11 o'clock, they told. I told, sir, I can't come in the morning because morning I am already associated with some other school. I will come in the afternoon 2 o'clock. They told, afternoon 2 o'clock, bandre yaru makliralla, they only come for lunch, after lunch everyone will go off. That was happening in so many schools, so many government schools, even till today. They only come till the afternoon lunch. After afternoon lunch, none of the kids are there. Even the teachers are not bothered, they are getting their samla. I am not blaming the teachers, I am blaming the system how it is. So the kids are not interested, they don't come, they come to, most of the very, very rural kids come to school for the lunch what they giving, ya papa. So after lunch nobody is staying back. So he told, if you come at 2 o'clock, no students will be there, madam, you come in the morning. I told, okay, today, that day was 11 o'clock. I told, today can I meet some students? He told, okay, meet. I met the students, I made them play some games, about the solar eclipse, because the next day was solar eclipse day. So I asked them what is solar eclipse, they were confused. What comes between what, even today I will be confused. Whether the moon comes in between the sun or the sun comes in between the earth, I don't know. Today also I should go back and revise. Correct, right? We are all confused. Solar eclipse, lunar eclipse, not you sir, lay person, I am an artist, I should be confused. So it was like, even the kids, as school kids, they were like, illa madam, Surya bartane, Chandra irtane. So I made them play the game. I made a sun out of one student. Then one student was moon, one student was the earth, and the others were stars, and we built up some time. And in that hall, I made them some play. They all understood the concept of solar eclipse. So tomorrow in the answer, they will write, Shilpa, Surya agidlu tane, Surya il nintirtane. They started writing the answer also. So they became very interested, and then I told, okay, today I am leaving you all. Tomorrow I will come. They told, okay, madam. I told, see, tomorrow I will come at 2 o'clock. If you all are there, I will make you play. Otherwise, I am not going to. Then I told, 2 o'clock, madam, now uta madi, nobody will be there, madam, they told the kids. I told, see, I am coming at 2. If you all want to play, you stay back. Otherwise, it's your wish. And I went off home. The next day, I come at 2 to the school. All those 20 kids, none of them have gone back after lunch. The headmaster is surprised. Madam, what you did yesterday with the kids? Obru mane hogilla, madam. After lunch, they are staying back. I told, this is what your teachers had to do. In order to see that there was a time where in order to retain the students in class, we had to do something for them. So this type of activity based or this type of theatrical based, performance based, physical based, who doesn't like playing? If our kids are like telling that, hey, the whole day it is game period, they are also happy to go to school. But if you tell tomorrow is internals, tomorrow is maths assignment, science assignment, who wants to go? Right? So this is what our educators have to do to make it more interesting, to retain our kids. Most of our kids are not going to these type of schools. I know that because we are all sending them to whatever schools and they have born to go with those big bags. They come back home and we do the homeworks. We write their assignments. We draw. Even that amoeba they can't draw. You have to show them in the internet. This is amoeba. Draw. Notepad bari. On the internet, Google, they will see the amoeba. And today's state has become like that, right? So how do you expect your kid to become brilliant here? My grandmother used to tell to my son, when they were changing channels and all, no, my son would help my grandmother. My grandmother would say, Udiya TV. And my son, hey, Kodma, what you're searching? See, tuck, he would put, small kid he was. My grandmother would tell, he's born not out of her, out of computer he's born. She would tell, computer maga idu. Computer maga idu. She had named him as computer maga. Because just owning the TV, that means our kids are so, what to say, advanced, or maybe their IQ levels are so much. When we were kids, somebody asked our names, we were like, my name, that uncle is asking my name. Today the kid will go, hey uncle, what is your name? My name is so and so. See that much of equipped they are already. For them, doing a science drama activity in class is nothing. They will laugh at you. If they play this Tom and Tom says, what for? That's true. That's why should I tell my name? Immediately GPS will go there. They will come and arrest you. The teacher asked my name. Parents will come give one complaint, right? Today's state has become like that. In this arena or in this state, how can you still encourage your science concepts? How can you still keep up with the science? How can you still keep up with talking about all these coastal things and whatever is put up today? How can you give them more interesting? All this is not required here on boards, ma'am. Everything is there in the click of a button today. But in spite of that, you will have put all these colorful things here. When the kids come here, something is colorful, something is captivating. So all these are the extra or the interdisciplinary approaches how we can approach and give it more interest. Okay, we have 5 more minutes, ma'am. So we'll play one game. So all of you are like, yeah, just before going to the game, I'm very proud mother. I have a son of my height. He's 14 years old. He's in a Gurukula studying Vedas. He's not going to a regular school. He was interested in physics. So he's side by side doing astrophysics and Veda. So he's doing Yajurveda and astrophysics research. But there is a lot of time for his research. Otherwise, he's interested in physics because I'm proud to say that I'm like zero in physics. I was fascinated that I have a kid who's like, he talks so much about physics and all. It's nice to share with people who are associated with science and physics and all. So he's doing Vedas in a Gurukula, proper Gurukula in the forest. So I'm proud to say that. With that, we'll go back to the concepts. Why I wanted to mention this is, see the whatever the education system, it is not hard and fast rule to follow it. People can do beyond it. People can do something out of the whatever boundaried system we are in. So to tell that, to encourage if you have kids who want to do something, pursue something else, even flutist, if he wants to play flute, if he wants to play tabla, there are PhDs. I am doing drama, yeah. My dad, I studied in Mount Carmel College, BCom. My dad was a car driver in Vidhan Sauda, a government car driver. My dad's boss's daughter didn't get seat in Mount Carmel because of the low score. The driver's daughter got seat in Mount Carmel. So the boss was always like that, sarcastically, Shankar, Magalen Martidale, Shankar, Magalen Martidale, what is your daughter doing? Like that sarcastic way, he would always ask my dad. So after my BCom, when I took drama, my dad is like, Shankar, nin Magalen Martidale andre, drama Martidale, sir, ante hini hellamma, you do something else. So my dad didn't know that there is something to do with master degree in drama. There is something to do PhD in drama. But today if I am a Central University professor, it is because of the subject or because of the line which I chose to become an artist and theatre, teaching in theatre. So, and my grandmother also, she used to tell, Natka gitka ella maadbardu, Natka gitka madadre, you won't get married, people will talk ill about you, you have to touch boys. So all these things were there, no, right, no? So it is the interest of the kid and the parents' encouragement how it goes. So you can achieve anything. Today if I am, my BCom graduates, classmates, none of them are professors or none of them are, I'm not telling they may be better than me, but none of them are into whatever they like. They were forcefully, they got into the subjects forcefully and they are forcefully earning somewhere. I am not like that. My passion is theatre. I am doing drama. I am earning. I am teaching drama, and I am also, my career also is theatre. So this is why I wanted to tell that how interdisciplinary approaches applied to anywhere is a success. Okay, so we'll play a game. I just want you to count 1, 2, 1, 2, 1, 2. 2.
2.
Okay. All the ones in one line, all the twos in one line. One. Anywhere, you all decide. One. Straight line. Opposite, facing opposite. This is what? One, no? 1, 2. Okay. Yes, ma'am. You all can hold hands in a straight line. Count 1, 2, 3, 4. ಎಷ್ಟು ಜನ ಇದ್ದೀರಾ ಅಂತ? 1. No. 1, 2, 3, 4. Count, sir. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2 of you all can come this side. Any 2 can come here. So now how many? Okay, I want one volunteer. Somebody here can volunteer? You can volunteer instead of playing. How many are there here? 10 here. 6, 7, 8, 9, 10, 11, 12, 13. Why then 2 went that side? Somebody told that. Now it is correct. Why? Out here. 12. This side. 12. One of you come out, sir. You be the umpire. Now 11. Then you can join. If she is joining, you can join. Okay. So this game is called, I know all of you all in physics. How many of you all have got current shock? Have experienced current shock? Sabko, guarantee if you all are in science, you should. Should means don't go and put your finger into the thing. Okay. So current shock. This game is called current shock. Okay, so we all are going to get current shock now. I'm not going to bring any materials for the shock. We are going to act that we have got shock. Okay, so for this game, I want you all to hold hands, each one's hands. Not your own hand, yeah. Nobody is here with me, that's why I hold my hand. Single is better to mingle. Okay, yes, don't cross it like this, not cross, hold it like this. Okay, and stand in a straight line, come closer. And I don't want you all to cross this line, come here. This, if you cross this line, -1. Camera come here. Come here. This line. Yes. Okay. So this game is called, that's all. Current shock. So you all can give your team's names, maybe A, B or some names you all want to give. This is one team. Look at each other's faces. Get to know people. Who is there in your team anta. Okay. So this is activity based game. And this is also, I told you, theatre is group activity. It is not individual. Maybe your experiments in science is individual. But when you add interdisciplinary to it, when you add something to it, it becomes group. So only if you play or only if you work in group, better outcomes are there. And especially when it comes to theatre, it is a group activity. So to see which group is more stronger, see when we are acting or when drama or whatever experiments you are doing, one will be slow, one will be very, very fast, one will be super fast, one will be average. You can't expect all 5 fingers to be same. But when you hold a mushti, what you will do? You will make that everything is same. When you hold like this, who knows which one is big, which one is small. So that is the game to tell that how powerful we are as a team. So a team game with current shock. Okay? I need, whose bag is this? Something breakable in the bag? No breaking thing in this bag? So I'll keep one here and please come, please be our umpire. So this bag is there. This is your target. Okay, it will be here. It's equally in the between. You stand here and see if they are who's picking first. Keep your phone. Not required. Phone is not. So I'll explain the game. The game is played just for 5 minutes. I'll explain the game. Listen properly. All are holding hands. I will give a shock here. What will happen if the current? If you get a shock, if you are holding hands, what will happen? It will pass. So if I give the shock, what will she do? She will pass the shock. Don't pass all so much. Take the shock, give the shock. Okay, so if I do this, what will happen? You will give it to her. It will pass, 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 pass. Whoever gets it first will pick up the bag and 1 point for their team. Understood? Understood? So once I will give it together, I will be giving the shock together to both of them, and they will pass the current, and the one, whoever gets the current, as soon as you get the current, you should pick up the bag. It is not required they have to pick it up. Even if they touch, whoever touches first will get 1 point to that group. Come a little more this side. This, okay, done? Understood? Here one thing is there about this game. One more interesting fact about this game is, we are all closing our eyes. Okay, but, listen, but we are all closing our eyes. You will be closing your eyes. But after you pass, sir, after you pass the current, you can open the eyes and cheer your team. But till you get the current and pass it, you are not supposed to open the eyes. And I will know, chumma somebody will press in between and go. -1, negative marking. Correct? Okay, done? Simply, if you, that's why now only press and feel it off. Now only press and feel it off. Somebody will simply press in between. They will go and they will pick up the bag. -1 for that group. Okay? So now, no, let them be proper. You should make it proper. If they cross the line, -1. Cross the line, equal. Now it is equal. No, it equal. Perfect. No issues. And please, you all have to be so alert that as soon as you get the shock, she will press. You should give it back. Understand? So one trial we will play. One trial. No marks for this. Close your eyes. Close your eyes. Eyes closed. Open your eyes once you give the shock. Yes. Got it? Got it? See, I tell you, they were fast, but he didn't pick. Listen. Listen, everyone will get chance. Now don't change because it's okay, now you have changed. But everyone will get chance to pick the bag, everyone will get chance to get the shock. Everyone will get chance. Okay? Okay, now the game begins. Close. Once you, listen, once you give the shock, once you pass, open and cheer for your team. Oh, like that. Kuch bhi karo, mera ho gaya kaam. No. Team spirit here, team game. You won't get opportunity to play this game again. Close your eyes. So nice to wait for the shock. Close your eyes. Amma, akka. Wait, not in the race. Close your eyes. All ready. Okay. Eyes closed. I am waiting to give current shock. Yes. Come on. Come, both of you here. Next will move. So, umpire, you must tell the score. Team A, Team B, score. 1-0. Come on. Encourage, yeah. What happened to this group? Okay. Oh. -1. Close your eyes. -1. I didn't give asking. -1. -1. Both -1, -0. -1. You have to pick the bag. You picked the up. You all are -1. They are -0. Now if you get point also, no point for you. 0 and -1. Oh, okay. 0 and -1. Close your eyes. That's why I told be alert. You are -1. Come on, encourage. Open your eyes and encourage. What is it? Sir is not giving. Sir, you must give. 1. 1 and -1. Come, hold your hands. Close your eyes. Close your eyes. You all must grab the bag, yeah? You all are waiting for Aarti. Come on, come on, come on. Come on, encourage your team people. Come, sir. Come, sir. 2 and -1. Come on, team B. What happened? Cheer up, team B. I'll tell you what is happening. This part is delaying. Fast you'll have to be, ma'am. Here somebody is user. You're wasting time. Idella beda dance. Just give, that's all. Okay, close your eyes. Come on, team B. I want you all to win now. Come on, take. Oh my God. That's all, that encouragement, yeah. What you are simply doing? Why? No, sir is like waiting for orders from ma'am. Pick karo. Okay. Come on. Come on. Yes. Come on. Team B. 3-1. Taking the one. Come on, team B. What happened? I'm encouraging you all, yeah. Close your eyes. Don't hesitate to pick the bag. Somebody's bag, it's okay. Eyes. It only went here. Listen. Come. Shot. Yes. 3-0. Come on. That's why I told wait for the shock. Be alert. High voltage. Short circuit and high voltage. Here high voltage, here short circuit. Yeah. Abhi aap stop karna. Hold hands. Yes, 4-0. Come on, yeah. What happened? Team B. Come on, you'll have to be fast. The team, something is missing in team B. Yes, come on. Yes, good game. No, I gave, but it's okay, I gave. No, I gave off the shock. But I gave the shock. So, yeah, I understood. It's okay, one mistake by me. 4-1. Come on, team B. Close your eyes. Namaskaram, Mari will go. Sir, नहीं, आपको पहले मिला था. Okay, I will not take now. Come on was for you people. Okay, done. Only give shock. Eyes closed. I didn't say anything now. You all have to open your eyes and encourage them. 6-1. no score. Come on, yeah, these people have to do something. Good, 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 good. Good, good, good. Hey, this team is coming closer, go. Yes, eyes closed. Y'all were very good. Very good. Equal it was. He hesitated to fall, you didn't fall. Just go fall on the back. Y'all can interchange your places and cheer up. Except ma'am, the others can change your places in case if you have doubt on anybody, like if you are slow or something. Y'all can decide. Team, whatever it is, team. Okay, eyes. Sir! Yeah, I know, they will -1 then. Okay, eyes closed. Good, ma'am. Put the bag. Okay. How many scores? Okay. 8? Okay, we are done because we are done with everyone. So, team A wins. Team A wins. So, when we were playing the game, I was observing that you all were talking about the short circuit, you all were talking about the high voltage, the slow voltage and all those things. This is how a kid learns. So for me as a layperson, I don't know about those. Oh, today when I saw the game or when I was playing with you all, I understood that okay, if the current passes like this, it is called like this. See, so every game or every physical activities what we do in our classes gives scope for better understanding of the concepts. Whether we are of school or whether we are in our old age, whatever it is, science is always fun. We always call science is fun. There is one caption somewhere, science is fun. Always fun, but that's what I told you in the initial session, that they have the myth, science, understood that word? Afterwards you can give whatever suffix for it, science, that means, that is all, I don't know about what, why. That if we have to go, we have to science, same science only. Correct? We have to make it from science science That is what is our duty. How we can inculcate some dance into it, some drama into it, some physical activity into it. So this is, see, we 15 of us are there, we understood. We can't go to whole over India and teach in all the schools, do this. But why we are selected people standing here is, tomorrow you have that responsibility to talk to the teachers of different schools in your areas, in your region. When you get this opportunity, when you give that science drama thing, whatever it is, these are the points what you have to curate to those teachers. You have to communicate to those whatever teachers or schools or centers. This is what our center has to do. You all have all the equipments. You all have everything now. One button you click, everything you will show the whole Bhumandala for us. All that is there. But as a human being, as a socialist, as a social worker, as a social human being, through our body what we can do is this is what we can do. So this is how we have to inculcate activities based or story based, drama based, dance based, so many things. You need not become a dancer. Everyone can sing today. Maybe you are a bathroom singer or a jogging singer or some singer. You would have sung, even mind singers are also there today. The mind only will sing off. All of us will sing, right? We all have rhythm sense. We all have all these things, and I told you, like nobody has come and trained us. Drama schools and training institutions, for what it is. It is not to teach drama. Nobody can teach drama to anybody. Nobody in the world can teach drama. All are actors. We go to institutions to polish acting, that's all. Those institutions, universities or NSD, National School of Drama, this, all these things institutions are, we are all actors. But We are performing on stage, we need more polish. We are not performing on stage, we don't need polish. That's why we are doing this. But we are performing. So today what I'm standing like this, I'm dressed up like this, I'm talking like this, all this is acting. We have that misconception, acting means, hey, she's acting, she's cheating. No, acting is not cheating. Acting is behaving at that place. Presenting ourselves in that place. So with you people, I have to talk like this and I have to perform like this. But when I go to a nursery kid, I can't speak like these words and like this. I have to be with her in her tone, I have to talk. So this is what is acting is, this is what inculcating interdisciplinary activities into maybe today is science, tomorrow it may be maths, day after tomorrow it may be physics, whatever it is. So this is what we have to go back to our centers, go back to our regions and tell the teachers, do something like this, the students will be more interesting. Do something like this, the students will be more capacity building. You need not give them money. For this, there is no concept of finance only in this. You need not buy materials and give to the school and tell do activity. You have to just put this into their brain, their bodies will do it. This is the simplest thing we as scientists can do to our future kids. Otherwise, they are all fixed with computer, they are all fixed with laptops. They don't need teachers. But teacher is required for this. For physical, teachers are required. Not for mentally. For their concepts, everything is there. But physically, a teacher should be present. She should be presentable. He should be presentable. He should be an actor. Every day that means it doesn't have to wear clown shape and come and dance in front of the students. But the activities, what he is doing, should be more activity based, more physical based. The kids should learn the concepts physically and they will retain it. That was a traditional way. Our Gurukula system or our Raja, Maharaja Kala and all, how schools used to be. The teacher would, Dronacharya would stand and Villu Vidye, Gada Vidye, whatever Vidyas. The teacher would perform with the kid physically, right? Vedas were there for chanting, that was different. But all the Vidyas, all the 66 Vidyas were all physical. Today we have forgotten it. Everything is in a click of a button, so teachers are not considered as the real what the teacher has to do. So this is what you all have to go back to your centers. My humble request. This is a very simple thing we can give it to schools, that how they can use their physical only and just play games and learn the concepts. Okay. So thank you for giving me this opportunity. And you all can take my number from ma'am. When you all go back to your places, if you all need any queries or if you all need workshops or if you all need something to do with your schools there, if they have any doubts, you all can give my number to your schools also. And they can contact me. I can help them with how to frame the syllabus for, not syllabus, but how to frame activities for science concepts. I can help them through over phone or online or whatever it is. So thank you for the opportunity.
Thank you, Dr. Pavitra Madam, for bringing various aspects of interdisciplinary approaches. I think interdisciplinary is something we all speak about in the current day of AI, right? It is very important to be interdisciplinary as much as possible. And so yeah, thanks for giving us so many pointers on this. So thanks a lot. And
anybody has any queries?
Just I want to add something.
Yes.
That day before yesterday there was a science meeting outside, and we tried to implement the things we do. Just myself with my body and with little number of props.
Very good.
And with a little bit of acting.
Absolutely.
And we have observed it in our area.
Okay.
And earlier we performed with science activities, with science shows like liquid nitrogen show and fantastic animals. Many number of schools copied that. But we have successfully performed this show in more than 50 schools. Because it is a little bit difficult to copy acting. And it will take a lot of time if they will perform.
So the intention here is again, you need not put up a diet like what was amazing. Otherwise, you need not take time to do a drama and take it and show, not required. Our intention here is not putting up a stage show, not going to a competition. Our intention is how the concept is learned in the classroom. Breaking the barrier of those benches and tables and blackboard and system and computer and everything, and moving to a ground, no space, no hall like this. There are trees outside your classrooms, take them under the tree. They will feel more fresh, they will feel more open, they will recall it, they will remember it. So that is what is our intention. What was that? There are many people who are doing this. Again, this inside the classroom to make it more interesting. Thank you.
yeah, thank you. now okay. So post the photo, we will have a lunch break till we'll get 2 times. So just a point that after this we'll go for lunch and we'll be back in the auditorium by 2:15 sharp because we'll start the session at 2:15 sharp.
See that your faces are somehow managed to show your face.
Hello, 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 hello. Hello, hello, hello.
Can I see the schedule?
Yeah.
Good afternoon, everyone, and I welcome you all once again for the final session of the presentations, which are aligned, and we do have at the moment maximum 1.5 hours.
Within that time, we have at least 5 presentations. So I request all those who are aligned for the presentations to please keep your presentation time within 20 minutes. We will, as usual, just like yesterday, there will be a small buzzer pressed at 15th minute. So for you to now wrap up, you need to move fast forward. Within next 5 minutes, you have to wrap it up, because otherwise we will have to stop you, which is not the right thing. We don't want to do that. So please align your whole presentation within 20 minutes. We want not to miss out any one of you. That's the whole intent. As we also have after that Mr. Manas Bagchi's presentation, followed by the brainstorming session. We will also have exchange of our common, exchange of what we learned, what were the aspects which we need to ponder upon, which we feel that these were not the right things. We can be critical at that time. So I requested you all not to be too critical for the past 2 days, but yes, today, during the last 1 hour session, which is aligned between 5 to 6, yes, we can be critical, right? So I request once again all of you to be here, be present, not move much, during this whole session, not to distract all the presenters, and enjoy the show and learn. Thank you very much. We'll start with the first show that will be presented is from Mr. Sitaram, who is a curator at National Council of Science Museum headquarters. And the demonstration theme is Shape Memory Materials. welcome Mr. Sitaram. So one more request to all of you, that please focus on the experiments. We do know that you might have a lot to say, but the focus today is first what you have brought us on the table for each one of us to experience, and then you speak about it, but limit the theoretical part to the which is focused to the activity. Thank you.
PPT is there. Oh, bag mein. Good afternoon to all of you. I'm going to give you a small demo and some knowledge about the shape memory materials today. Next. What are the shape memory materials? Anybody heard about it or have some knowledge about it? Yes. So they are nothing but those metals or materials or alloys which can change their retain their shape after heating or pressure or charge, something like that. So they will be reverted to their original shape to under certain conditions. Different types of shape memory alloys were here given. The metals and their alloys, ceramics and glass, and polymers, composites. Out of these, sure were three classes of them were memory to exhibit shape memory function. They were alloys, polymers, and composite materials. Next, I will show you a demo. On a paper clip. This is a paper clip shape. So I am destroying its shape. Okay. So if it is kept under some 80 or 70 degrees temperature, it will retain its shape. You can see. Heat come nahi. temperature may not be sufficient enough. पकड़ने को कुछ है पटकर पकड़ने के लिए कुछ है you can see it, it is retaining its shape. Okay, almost. Next slide. So, Dr. William J. Buller, who is working on special types of alloys, has suddenly noticed that nithinol wire possesses a peculiar response to the temperature and stress. The most common shape memory material is the alloy of nickel and titanium. That is called nithinol. The particular alloy has very good electrical and mechanical properties, long fatigue life and high corrosion resistance. Nithinol is an actuator and heater all in one material. Next slide. So the term nithinol is given by its composition and place of discovery. It is nickel titanium naval ordnance factory or naval ordnance laboratory in Maryland. Typically nithinol's composition varies from 55 to 56 to 45 to 65 range. So basing on the ratio of this combination, the metal's properties vary abruptly. So we can set the desired properties by changing this composition of nickel and titanium. Now I want to show you one word. It is, you can see here, hot. So I am deforming it and keeping in water. If not possible, we will use that one. The temperature was not sufficient enough. Another letter has got down. Cannot see it. O and T have come, H has not retained its shape. Because of the red hot, it has changed, I think. Next slide. Next slide. So how the crystal structure changes, this video shows. Video chalaiye. So this is the austenate state, which is at higher temperature, and when we apply heat, when we cool it down, it is at higher temperature. When we cool it down, it will come to martensite state of the material. So this is martensite at room temperature. It will be the state of the alloy. And when we heat the material to certain temperature, it will come to its own alignment, retaining its shape. That is how the crystal lattice of the metal changes. Okay, next slide. Here we are going to show the letters NCSM. These will deform and heat to certain temperature. Let us see here. Here one letter was filled down. You can see the shape retaining here. letters. నవరం కింద ఎమ్మున్నాయో చూడు నాకు కనిపించట్లేదు ఇక్కడ పడింది కొంచెం అవతల చూడు ఎం లెటర్ next slide please. So you can very clearly see here how the two-unit states will show up at room temperature. The metal structure varies and these states are called two-unit states. Depending upon the alloy and composition, they will form different shapes. This is not that one. Not this one. M shape. M shape. Here you can see CS. So here you can see the different two-unit states of the crystal structure. So at room temperature, they will be in stable state. At a higher temperature, they will be at a stable state. At room temperature, they will be in two-unit states. The two-unit states you have seen how they vary from composition of the material. Next slide. So I will show you another object, which is a spring. So you can see how it is retaining its shape on heating. Next slide. So I will show an interesting experiment with this spring. You can watch. Okay, when a spring is extended and heated, it will gradually goes up by retaining its shape. So the heat sets it martensite, state of the metal. And here is a prop we wanted to make, but time constraint didn't permit it. This is how this works. You can watch. Two springs were set extended and given a train shape, moving here and there. So when it is heated and pull to one side, you can see how the spring tries to go up to retain its shape, and as a result it goes down, and again it goes up and turns to left. So in that way, it will completely take it back to its original spring shape to show. Next slide. Next slide. Hello. Next. So there are some special types of shape memory, ceramics and polymers. I will show you a special polymer. You can see how it sets to its own position to the body temperature itself after its full extension. Another 1 minute. You can see it. Next slide. Next slide. There's next slide. Fast forward. Next slide. Some applications of this one is airplane wings. They are used. So to temperature stimuli, they will change their shape. And medical applications were there. Use medical applications. In stents we use this one. Ethanol stent is made, and when it is inserted in the body, due to body's temperature it expands. Next, this is another big application of space memory materials. One tire made of ethanol wire is used in Mars rover. There is a big resource database of shape memory materials. Those who want to gain more knowledge and those who want to do R&D, you can utilize this website. Next. So it is a very vast database. For that 10 seconds video, you can see just how to utilize the resources. Thank you.
Thank you, Sitaram sir, for your session on shape, memory and materials. For our next session, we have Mr. Premadhar Das, who's an education officer, National Science Center, Guwahati. His topic would be on wings of flight. Looking forward, sir. Welcome, sir.
Hello. Yes. রাখি দিন পরে দেখা দিব So good afternoon, dear colleague, respected director, ex-director sir Manoj Bakshi sir, CRTL, and respected Jyoti madam, and also Pavitra madam also dear. So I am very privileged for me that I can participate in this science conclave conducted by VITM Bangalore. So my topic is wings of flight, and I am background in actually biology. Anyhow, I am trying to show something. And before, as the wings of flight, that's involved with the mechanical and physics related formula. And for that, last started with one formula that's behind this our Mendel's law. Just for 1 minute. After this, let me cover this my today's topic. I request one of my colleagues, please, immediately. Yes, I'll ask you. Take this. Yes. So be there. Just choose one which is longer one, please. Here is shorter one and longer one. Tall one, this is. Choose one from and collect here. Okay, and then you collect one short one. It's representing the P plan. So our great scientist Gregor Johann Mendel tried with this P plan about the monohybrid crosses, where we'll get some formula mathematics. So you just give is capital T. Yes. Yes, capital T. Mark as capital T. Okay, this small t. Okay, then it's represent pure tall, it represent pure dwarf. And now you have to cross with this and you will get this result. So what will be the hybrid? Yes, just capital T and small t both. Not equal to, just mark is T, small t. Okay, then you collect. First here, you will keep one here, one here, one here. Okay, not required other. But you mark, actually, that's progeny. That's, let me cover it. So first is capital T, here is capital T. Small t, sorry. Small t and small t. And what's other left? That is capital T from here, small t. One more left, that is capital T and capital T. So you just mark TT, TT, so at exactly which Punnett square also you can express. So this one, first pure, tall pure dot will get hybrid, where genetic material will be the T and T. And after cross this next generation, you will get one hybrid T, another hybrid T, and another hybrid T, dot one, and lastly this one, that is 3 tall, physically 3 tall, and 1 is dot, that is 3:1 ratio. This is the monohybrid cross of Mendel's law. Okay, let us, thank you so much. So let us start with our wings of flight. Again, I request one of my colleagues, please, Hari. Just bird flying, that's in the school level, that one famous sentence, if I were a bird, I could have fly in the sky. But we are unable to fly in the sky. Why? Just you do like this. Yes, but for some time also you can do, but not for many time. But birds can do. Why? Just you see, observe. Why birds can do this? They have powerful muscle. They have powerful muscle, suprachiasmatic and pectoralis muscle. These two powerful muscle help these birds to flip their wing. So here it is, I am unable to show the muscle actually, but these two structures represent such type of condition. So this is the one important advantages of the birds that, thank you so much, that can birds fly for many times with the help of the wing. With the help of this suprachiasmatic and pectoralis muscle. Moreover, because their 5 to 6% of the total body weight is bone, but our human 10 to 15% of the body weight. So this is the disadvantage of human and advantage of the birds that can carry their body easily. So one more. So this very light weight of the birds that already I mentioned, like the bone, their feather weight also almost similar, 6 to 10% of the total body weight. So these two important advantages help to birds to fly. One more important thing is that you see, when we are coming from Guwahati to Bangalore, and some other colleagues also coming from Delhi or other places, maybe avoid flight, but on the atmosphere, and we did not feel suffocation because we get oxygen that is actually available, that is preserved in this aircraft. But nature created birds like that, they have this system. They can long distance, they can cover even sea, albatross or other birds. They can move very far distance without run out of air. How it is possible? We have lung, birds also lung. Moreover, the lungs of the birds, they have such air sacs, about 5 posterior, anterior, abdominal, different air sacs is there, so that they contain much more air, so that during their flight, during their migration to another country or another state, they did not feel the air suffocation. This is one very important advantages of the birds during their flight. And so already I mentioned that as I am not belongs from a physics background, so anyhow, let me try with this. So many of you already know about this. Ultimately, what is principle? That is, low pressure zone is created upper part of the birds when they are flying. That day, Balakrishnan sir, one of the pioneer and retired principal of this area, he also demonstrated and he advised to some which animation. That's why I prepared this one to show the animation to attract the children during demonstration of such type of project. So this upper part indicating the blue color, low pressure zone during flight, and this is the high pressure. So that's why it is bound to lift up the birds. So otherwise, that's already all the things are magnetic, this Mendel's law, and these are background why I will keep on that. This is the magnetic board. That's the staff member of this FITM helped me to prepare here because it is unable to carry from Guwahati to Bangalore. So many, many thanks to them. So this I prepare. So moreover, the birds, interesting phenomena with the insect life. So don't forget about the insect life because maximum principle, maximum ideology we are collect from the nature, including birds, including other animal. We are collecting different interesting phenomena, including our social behavior of the honeybee, social behavior of the insect, different phenomena is there where different ideologies is there to promote our culture or system, including demonstration. So now, see, the dragonfly is very interesting in this case. Not only dragonfly, squirrel, bat, mammals, some lizard also glide. They have the capability, may not be long distance, but if short distance they can glide or fly. But some interesting thing, not only that, they have important character. They have backside movement, forward movement, side movement, different movement they can show. And when they are going to laying egg, generally they lay egg on the water actually, supported by aquatic plant. And they are hovering on the surface of the water, and they may glide, stay in same places. So this the four-stroke character is developed in this dragonfly. So I cannot carry towards you because it is connected with power board, but here I can show. If I am lifting, so this is one. He can stay like this. If I keep it down, stay like this. So different movement, you can see this. So insects show very interesting and important mechanical function they can show. That's why it is 1941 to 44, Havlon Aircraft Company, America, named some aircraft as Dragonfly, Dragon Rapide. Also, they name again some moth. Moth and butterfly is almost similar, but they have distinguished character also. So they name, because of their important character, they appreciate or they came up this dragonfly in our human behavior. So human, so one more. So actually it was first I should show anyhow. So everything, the evolution of flight, evolution of birds, come see this. 160 billion years ago it started. It is theory proof and lasted to 65 to 5 million years ago. That's the prevailed this dinosaur, and some scientists actually think that this is the primitive of our present birds. So, however, their distinguished character is there is a teethed mouth, and here is also nail is there on the wing. So, scaly wing is there. So, different character is there in this dinosaur. So, this way our development comes to wings of flight. So, it is signal to me that's a time-bounded demonstration. Yes, madam. So, this dragonfly, and I have no any kids for butterfly actually, but they have interesting, as madam allow for 2 minutes, they have interesting character, as like dragonfly. They have interesting character. They form a H shape. When they have also four wing butterfly, they make a H shape. One push forward, next will come again forwards. So this way, but it is minutely observed that how butterfly fly. So again, it is very interesting. So different insects have the different mode of fly, and however, our birds, generally we are observing our birds, exceptionally rattles. That's the emu, ostrich, but other birds can fly in the sky. So this muscle help, bone help birds, air sac help birds, and ultimately they have, the other insect have 4-stroke or 2-stroke system to fly in the sky, to migrate or safe from predator, or they may move for different their purpose, hovering in the plant or hovering on the surface of the water. Not only that, you will find the sea, that is the flying fish. 200 meter they can cross, flying fish. It is recorded, 200 meter they cross. They have also flying. They to avoid enemy, the carnivorous fishes, to avoid carnivorous fishes, they just come up the water and fly. Many, many thanks to organizer, and I wish the grand success of the Diamond Jubilee of VITM. Thank you so much.
Thank you very much, sir, for the very nice presentation. Next session, we have Ms. Aditi Ghosh, who's an education officer at VITM Kolkata. She'll be presenting on codes of life, molecular biology. Welcome, ma'am.
Hello. Thank you. How do I change the slide?
This you keep it in your this thing.
Ma'am, Ji. Over there. Okay, then I'll move in this one. We ready? Can we start? All right. So, good afternoon, everyone. Welcome to the Codes of Life. But just before we go into that, one small question. What is life? What is life? Is it growth? It is growth, right? So, can you please zoom inside the container, this one? If you look at there, what I have inside here is a solution of tin chloride, acidified solution of tin chloride, and into that what I'm inserting is a piece of zinc. So if you can zoom in further into this zinc piece, if it's not too difficult, you'll see some bubbles are gradually forming around it. And what is happening over here is a displacement reaction. So ultimately, after say 5-10 minutes, you'll see a growth inside this. Yeah. So give it a little bit of time and you'll see the growth is happening over here. If you want, you can just come up also. The needles of tin are getting deposited on the zinc piece because it's the displacement reaction that's happening. So growth, life, is it response to stimuli? Yeah? Grow, life, response to stimuli? Yes. Response to stimuli. So, what does stimuli have to do with Eno tablets? Let's see. The color. So if you can zoom inside, or I'll pick it up. Gradually you'll see what we have. I know this has been repeated in this session also. What we have down below is a layer of water, and once the coating on that Eno tablet dissolves, you'll see the inorganic acids that are inside and the bicarbonate that's inside that reacts with the water, and you'll see the bubbles of water that are coming up through the layer of oil over here, because that will be rising, and that's again a response to stimuli. But clearly none of these two are alive, and yet by the definition of life this would have worked. So what is actually life? What is it governed with? What is it governed by actually? What do you suggest? So next one, please. Next one. So in the 1 second that it took me, or even sir, to bring up this slide, 1 million cells in our bodies died. Some of them was because of programmed death, apoptosis. Some of them died because our body had to prevent itself from viral invaders. And some of them, they underwent necrosis because of aging, because of other factors. And we know 1 million other ways in which cells can kill themselves to keep the body healthy. And yet, knowing that mechanism, how to cells keep alive or maybe to make them dead, can make a whole world of difference to a sick person, right? And in spite of all the ways in which we know we can die, we still live. So what is this basic difference? Life, death, what governs it? Is it this spiral? How many of you believe it's the spiral itself that governs it? Yeah. Can we go to the next slide, please? There's a video, please play it. Now this is go to the previous one, click previous one, click on the where do we come line. That right up, text, click on the text. There's a sound, please. It's not coming on the projector. And the sound, please. So what we have, I'll tell you in a gist. Just keep listening to the sound. These are photographs from a personal album, and they show the journey of two individuals across time. We've just reversed the timeline. We start off somewhere around when they are 19 years of age, and we come moving back. They are growing together. They come from the same place. They are brothers and sisters. And yet they are growing apart over time. But if we reverse that, where do we ultimately end up? Keep listening to the music because that's also important. So where do we ultimately come from? Where do we start off? So if you're reversing your journey, if you're reversing my journey, we all begin from the same place, from a single cell. You're listening to the music, I hope? Yeah. The music is important because that's your DNA code playing. That's of the immunoglobulin protein that has been encoded into music, and it's not anything new. It's from the 1980s. So because we know that sequences repeat over time, DNA, and music notations, they repeat over time, they work with repetitions, and that is why it's now normal to encode DNA proteins into music. And what we are coming up over here ultimately is the cell. So it's a cell that's housing your DNA and telling you who you are and how you'll be different from the other person, right? But how different are you actually from your other person? Any idea how much difference? I know, last session at least it came up 99.99%. But how much is that? All right. We need to know how much that is. So for that, if you had to take a human being, the information that it takes to make a human being, and information I know, when I downloaded this presentation over here, I gave it to sir in the form of a pen drive, right? So how many of such pen drives do you think will be enough to fabricate the information of a human, that you can constitute a human being out of it? Information, pieces of information. If you're thinking about your body as cells and atoms and molecules, information, how many? How many of such pen drives? I'll give you a ballpark figure. Consider the Titanic, not less than that. How many Titanics? An entire Titanic filled with pen drives containing the information for making a human. How many of such Titanics? 2,000 of those. 2,000 of those. We all know how big the Titanic was and how big a hit the film was. Take the highest one. Take the highest one. Right. So that information by evolution has been encoded in our DNA crystals, these ladders. So how much of what is the scale of our genome, if I might ask you? Anyways, we didn't know what this DNA looked unless and until we had a woman look at it. Any idea who was it? Rosalind Franklin. She took a picture of it. She looked at it, a woman scientist. But then again, it took us 40 more years to actually take out a DNA crystal and open it up and read it, what it actually is. And when we read it, those were the ATGC that we have, adenine, thymine, guanine, we all know about that. So that ATGC, if you consider those as alphabets and you printed it on these A4 sheets like that, I think adeno is too resistant to the water. Anyways, we know the experiment, so someone will help me afterwards, I'm sure. So if you can, we have this unopened ream of paper over here. How many sheets? 500? 2 of these, how many pages? 1,000. You need 262 of those to write out the entire ATGCs. 262,000 pages. And how much of it makes you, you and me? Only this one, 500 pages. That's the difference that makes you and me. Yes, so 99.99% boils down to this. So out of 262 of this is what is making you unique, right? All right, that's okay, we gauge it. So from this book, if this was the book of genomes and this was chromosome 14, I read out a sequence to you that's ATT, CTT, GATT. What I just read out to you is of a very lucky human. Maybe it can be you, it can be me, Because if I miss out on 2 letters in this position, chromosome 14, that person will be affected with cystic fibrosis. We still don't know the cure for it. So 2 letters out of this entire gamut which we call a human being. Just a difference of 2 letters and you're sick, very sick. Rest of it, we are good to go. Next slide, please. Yeah. So, small maths puzzle. We have how many amino acids in our body naturally? 21. Yeah. So we have only 8 ATGC, 4 letters to work with. So 4 letters cannot make all the 16. How many do we need? Maybe another sequence of 4. But even that is 4 to the power of 2, that is 16. Will not work, not good enough. So we need 3 of them to read at a time. So what I mean is when I'm reading the code ATGC, I need to read them 3 at a time, and that is what codon actually is. So out of that codon, you see I have marked out 3 circles containing that AT and GC, and that's repeating over time. So over here, if I ask you to find out what cat will encode, cat as in C-A-T, I'm not sure if you can I use a laser? Yes, absolutely right. So if you start off with C over here, go to an A and find out a T here, it encodes for this H, histidine. So like that, you take 3 at a time, you're reading the codons, and with the function finder, you can find out. But you'll see that many of the codons are common, like any other combination G, C, and out of any of the AT and GC, it will ultimately land up you in A. Why not something else? I mean, 64 was the original answer you gave me, that because yes, 64 is possible over here because 4 to the power of 3. We don't make 63. Evolution chose only 21 of us for us. What about the alternative pathways? Can we explore them? Can we go to the next slide, please? That's what he does. ChatGPT for genomes, because we are all done with analogies of alphabets and words and letters for DNA codes of encoding humans as words. But sentences don't form with words alone, they carry meaning. Similarly, ATGC, they just don't encode for proteins. We have a lot of information in our cells which we don't know what that is, right? And that is the function of large language models dedicated to genomes. So this person over here, I'll just get my figures right. He's made a ChatGPT for DNA that's called EVO. This person, he heads the Laboratory of Evolutionary Design at Stanford University, Brian He. And this large language model, this genomic large language model was trained on just like ChatGPT is trained on large volumes of written English. It then creates an algorithm from it, learns patterns, and read and write original sentences. We know what ChatGPT does. But EVO was trained on large volumes of DNA, 300 billion base pairs from 2.7 million bacterial, archaeal, and viral genomes to glean functional information from stretches of DNA that a user inputs as prompts. A more complete understanding of the code of life, this also gives us the evolutionary alternatives that nature did not select for us, but maybe sometime in the future, maybe for a future disease or for a future cure, those alternative pathways can be extracted from such genomic large language models. But when you have DNA and it's copied, you tend to have mutations, right? So if I tell you that you're a mutant, will you be angry with me? Yeah? No, because we all are. So don't take it otherwise, you're a mutant. Can we have a small game, please? Can I have 8 or 10 of you up over here? Yeah, just up over here. Maybe on stage. Maybe on stage. 8 of you in a single line. little bit separate from each other. Come in front, you're getting the light. Four of you there. Read this and you whisper it into his ear. Whisper. Once, just once. Whatever you've heard. Next one. Slowly. I can hear it from here. But whatever you heard. Next one, person. No, no, no. You still need to go. What did you say? His.
The lab was his, what I hear from Lane, sir. So whereas here they written the lab P was the key.
Yeah, okay. So we survived the lab. The other part got deleted in mutation. Right, thank you so very much. I'll still need one of you to stay back. Here, please. All right. So mutations are difficult when you have things like that. Lab becomes his, where it was only a lab key that was the P, or the other one. Anyways. But it's also important in certain other cases. Can we just focus on this one? Crystals. Or do I put it down with the white background? You see the growth has happened? Ma'am, life has come? Yeah, the needles have come. You can come closer, it will be more prominent. Okay, but mutations are important not only for this kind of evolutionary processes to take place, it can go the other way also. So consider this to be a healthy cell, okay, pink of health, that's why we chose pink, and we had this in major amount, so yeah. My job will be what I always do, play the spoil sport. These are some diseased genes. I'll be putting this at a steady rate inside, and sir, your job will be to, you are cell P53, you're a control protein. Your job will be to keep the organism healthy and remove the green ones. You need a place to remove it. Do we have, yep, something so that this does not fall. We can use this one also, no problem. You can keep it here, okay? So I'll be putting it at a steady rate. Your job will be not to touch the pink ones because those are healthy cells. You are cell P53, so you would need to cleanse the body of these diseased cells one by one, okay? So the rate I put it in, you will try to match that up. So I'll be putting it in, and your job will be to remove it, okay? So after 5 or 6 beads, he's doing a pretty good job. Cell P53, my cell is still pink and healthy, and almost no green. Almost no green. Okay, that's enough. But now what I'll do is, because I love creating difficulties, I'll give him a mutation. His mutation is his fingers are going to be taped. And this time, it will be a very strategic taping. I'll need 3 of your fingers together. Yeah. Close the 3 fingers together so that you can't grip it. You can't keep that space. Close, yeah. He's trying to adapt to my mutation, not allowed. Okay, close, tight enough? Yes. Right. I'll give you one more mutation because I know you're trying to adapt the other two fingers also. Arey. That's a 15-minute, right? 20, finished? I'm also finished. Just 2 minutes. Okay, now, same job. I'll put it in. I can use this. Yeah. I'll put it in. Your job will be to remove it. Yeah, it's clear now. Okay, I put it in. See, I'm giving you time. Don't take away healthy cells. See, I'm putting it. Yeah, whatever you're getting. He's removed a healthy cell, no problem. Put it in. His job is to remove. He can use any fingers if he wants. As long as he's removing, I'm fine. Is he removing? Is he? He's removing. He's removed 1 green and 3 pink. Oh, 2 more pink are sticking. And my body, the pink has been contrasted with the green, cancerous. Okay, thank you so much. I'll help you get rid of your mutations. Thank you. Okay, so that's also one kind of a mutation, not healthy perhaps, but yeah, that happens. Next slide, please. Look at this picture. This is from World War II situation where the planes which have been hit by bullets are coming back, and the engineers there are analyzing which parts of the plane they need to give more protection the next time they are sending the planes in. So this is a collection of all the places where the bullets have hit the plane. If you had been that engineer, where would you provide the extra cladding? Which areas? The red dot marks or the clean ones? Jyoti, yes. Yes, red marks are the clean ones. Come on, which one? Which one gets the vote? Red ones, clean ones? How many say red? How many say clean? You see the red ones, those are areas where the plane had suffered bullet injury and has still come back to base. The planes that did not return are the ones which do not have that mark over here. They did not come back to base to me. And the clean marks, if you notice properly, that's the cockpit, that's the fuselage on the wings, that's the armory. So those are the areas where you need to give more protection to actually have any practical implication of that cladding. But if you had depended only on the red marks, that these are the areas where the plane is getting hit, so I clad it even more, you are now suffering from survivorship bias. You are only taking into account the survivors, the planes which come back. What about the planes which do not come home? What about the gene areas we do not know about, their functions, the proteins? The Human Genome Project, that has decoded the entire thing for us, but how do we use it? Not all of it encodes for protein. We don't know what the other parts, what the punctuation parts do for us. So it's how we get rid of survivorship bias. It's how we get used to these kinds of cell proliferations, maybe the concept of life, death, the cell itself, the amount of information that is provided to us through the cells, how we use it, that will take us to the next stage in molecular biology, right? So a very crude example of how we might approach the difficult topics which are related to molecular biology. A big shout out to the entire VITM team here for arranging all of this, for this regal arrangement for us. I came here bare-handed. Thank you for providing all of this for me. Thank you so much.
For our next and Lakshmi R, who are the junior mentors at Innovation Hub Idea Lab VITM. They'll be presenting all about waves. Welcome.
Probes. Yeah, go up. Sound good. You did well. Sir. Yeah. Can you give an extension? Extension. Hi.
Good evening, everyone. So I am Lakshmi
And Lateralson, yeah. So we are junior members at Idea Lab, as Abhinati introduced us. So today we will be having a small demo session about waves.
So as you know that all the information around us, it reaches us through the form of waves. Be it like what we see, it is light waves, or be it what we hear, it is sound waves. Even in our devices, our mobile phones, there are electromagnetic waves. And even on a cosmic level, some of you might have heard of gravitational waves.
And
Yeah.
And in biological systems, you also have waves. Like as a sample organism, I have taken slime molds. So they grow in a pulsating way, and the whole way, the way they process the information from the environment depends upon how those waves interpose. Today we won't be talking about slime molds. So today we'll be sticking to physics experiments.
There are multitudes of different kinds of waves around us, but we'll be focusing on mainly sound waves and light waves.
Yeah.
So before we get into that, we'll
That's yeah. So yeah. So okay. So yeah, before we move into standing waves, we have to talk about what are the main different types of waves there are. So what are the two main types of waves that you have?
Like broadly classified,
broadly
if anyone can say. So So based on their direction of propagation, they are broadly classified into two. So can anyone tell us that?
Yeah.
Yeah, that is correct.
Yeah. So that is based on how they propagate, right? So we'll have a simple demonstration of that.
Yeah, so I hope everyone can see this linking. Yeah.
So in the case of longitudinal waves, the displacement is in the direction of propagation of the wave, right? So in this case, you can see there are regions of compression and expansion, right?
So basically the oscillations will be in the same direction as the wave is moving.
Yeah.
So one example of longitudinal wave is your sound wave.
And the next type is transverse wave, right? Like, so in this case, the displacement is in the direction perpendicular to the direction of propagation of the wave. So this is like a simple example of like how a transverse wave will look like. So from this, we will moving towards like something called as standing waves. So these waves, like the sound waves, light, and so on, they are moving, right? Those are traveling waves, right? So next we will be talking about standing waves. So what do you think are standing waves? Like, you must be familiar with it. Yeah.
Yeah, there another name is stationary wave.
Yeah.
But basically, if like the movement of So I will show you a small. So you might have it is not something foreign to us. Like even just tugging on your clothes line, or you are hanging your clothes, will give these kind of waves.
Yeah.
But if you just simply tuck on it, we'll see what happens. Yeah. So you see the wave coming here and bouncing back and forth. So this is an example of a traveling wave. Now standing wave happens when imagine a wave is coming from there and it is bouncing back and it is tracing itself and going back and forth. So what will it look like? It will look like it is standing in one place. So that's where the stationary wave or standing wave comes from.
Yeah. So before we go more deeper into standing waves, we have to understand one of the fundamental. So what are the fundamental properties of waves that you are familiar with? Like, what do you measure? So let's say when you take a color of light, right? What would you say? Like when you buy a laser, what is the specification that you usually give? Like other than the power, wavelength, right? Those are the two properties, wavelength and frequency.
Frequency is there.
And there is one more property called phase, right? So what is phase? Like phase of a wave.
Anyone?
So let's say you have two waves. So they could be exactly alike. So they can start from. So here you can see the blue wave and the green wave, right? So when
there are high points and low points. Just notice that.
Yeah, initially they were aligned together, right? At that point of time, their phase difference was 0. So they were in phase.
So their high points and low points were almost exact. They were on top of each other.
Yeah.
But when there is a slight phase difference, their high points and low points are not aligned at all.
So this comes into play
when two waves interact. There is a slight misarrangement in the slides. Sorry for that. Yeah. So these are the longitudinal waves that we demonstrated before, and those are the transverse waves. So a simple example is like when you play guitar, right? So when you pluck a string, you can actually there are two types of waves propagated: the longitudinal waves and the transverse waves also. Really sorry, the slides are not coming in order. Yeah. So now we are talking about what happens when two waves interact. Now you already know what is phase, what is phase difference.
So when two waves are in phase, these two waves add up to each other, and you get a much higher amplitude wave, right? That is called as constructive interference. And the opposite happens when when they are out of phase. Like let's say there is a phase difference of 180 degrees between these two waves. What you end up getting is basically nothing. Like so, yeah. So
now can anyone tell, like in the case of standing wave, what is happening? Is it in the light of interference that you just learned? What is happening in the case of standing waves? Is it constructive interference or is it destructive interference? So it is it is constructive.
So so what happens is that, so in this case, so we have made something called as a string machine, where the two ends of the string will be rotated by motors. So what happens here is, power on.
Can someone turn on the power, please? Okay, yeah. So now, if we
Yeah. So currently you can see 3 peaks, right? So what is happening here is that, like, so when you take a wave, how much of a wave is here? Like when you talk about one full wavelength, right? How much of this would be considered? Like,
so from where to where is one wave is our question. Yeah, is it here to here? Okay.
oh, okay. This is white. Black.
Black. Okay.
Yeah, okay.
Yeah, now our question is, how much of this is a wave? Is it here to here? Can anyone tell me? From here to where? Here. Yes. So that is one wave.
So yeah, so this is what is called as the third harmonic, right? So if you play it,
yeah. So now this what you're seeing here is the second harmonics of this particular string.
and if you, and this is the first fundamental harmonic, right?
So what we mean by that is when, like, so this is the case of where two ends of the waves are restricted, right? Now here this particular string will prefer a certain frequency, certain type of waves. So the biggest wave that can have that the string can have is the fundamental
first fundamental. Yeah, so this is basically half the wavelength.
First harmonic.
Yeah. So now we basically have a situation where the two ends are constrained, right? Like you impose a constraint on this particular situation. The two ends are can't displace too much, right, compared to other parts. So you have another situation. Let's take a tube. Okay.
So now you might be thinking, like, you know, it might be getting too technical, but if you think about it, you might have definitely have encountered this in daily life. All the musical instruments, say for flute, how do they play the flute? They have a multiple holes in the flute and they take their fingers on and off, right? So basically what they're doing is, you know, if it's the case of the string, they are changing the length of that particular pipe, say, and they are producing their preferred frequency. So that is what is happening in your musical instruments. So now we'll see the case of, so this is both ends restricted, as Vitalson said. Now we'll see the case of only one end restricted.
So we are taking a tube and we will use an external sound, like, so we'll use a tuning fork to introduce a sound into it. So basically what will happen is that, so we are submerging one part of this tube into the water. So one end is closed, right? So you have one node and one end, something called as an antinode. So in this case, these are the nodes and this is the antinode. So in the case of a wave, if you have to calculate its speed, how would you do that? Like, what is the formula for calculating speed of a wave? Usually.
So the basic, what is speed? Displacement by time. Right. So now if we take the case of wavelength in place of displacement, what will be the formula?
So what is frequency? Yeah, so frequency is basically how many oscillations you are having per second, right? So if you want to find the speed of a wave, what you have to do is multiply the wavelength by the frequency. So in this case, we have a tuning fork which has a particular frequency. In this case, it's 512, and so we have a tube, and we are basically
going to produce that frequency on top of the tube. So now what will happen is the air column inside the pipe that will vibrate, and we'll see when we get
the loudest sound. So yeah. So before that, like any one of you know what is a rough estimate of speed of sound?
Can anyone tell us the speed of sound? Yes,
okay.
That is correct.
That is correct. So now we know the formula for the speed of sound, right? Like the speed of sound is equal to frequency multiplied by wavelength. So we want to know at what length
of the tube are we gonna get that loudest sound.
So
from that,
so before all of that, we are supposed to talk about something called as resonance. So all of you must be familiar with resonance, right? What is resonance? Yeah. Yes. So all objects
have a natural frequency.
And now the tuning fork is acting as an external driver, right? So when the frequency of the tuning fork matches with the frequency of the object that we are using, in this case this tube, like if you adjust the height in a up to the right length, you will be getting you will be hearing a loud sound. So basically that's what we are going to try, and from that we will try to estimate what is the speed of sound. So speed of sound can change, right? It depends upon what's the temperature, what is the altitude that you are in, and yeah, and other things. Like yeah. So yeah. So you told me that the speed of sound is 343 meter per second, right? So we know that frequency is 512. So what would be the approximate length at which this should resonate? Like what would be the wavelength? Could anyone hear it?
Could anyone hear that slight rotation sound?
Yeah.
So we're going to mark that length.
Yeah. Oh yeah. Yeah. No, it's can't. Tube, right?
Yeah.
Yeah, you could hear the sound increasing, right? So
we'll mark that length, and we're going to measure it.
So he said the speed of sound was 343, and we know the frequency of the tuning fork is around 512. So if you divide the speed of sound by the frequency, you will get this around 0.6 meters. So the wavelength should be around 60 centimeters, right?
So what we've got here is 15. Can you zoom in? It's around 15 centimeters, 15.5 approximately.
Yeah. So this tube will be the fundamental frequency of this tube is around. Yeah, in this case, what do you say? What would be a better way? So basically, it can support a quarter of a wavelength, right? So it would be a quarter of 60, that is 50. So basically, from the demonstration, we found that
it is
around that range. Yeah. So
can you move to the
yeah.
wave slide? Yeah. No. So even though when we were talking about sound wave, we were talking about wave like a transverse wave, like all that is what we all had in mind. Just keep in mind that this is how a sound wave actually travels. If it will travel through air, there will be regions of high pressure and there will be regions of rarefaction. So now, like we just calculated the speed of sound, but unlike light, it's like anything visual, like it's very impressive to us. But sound, like we can perceive it, but have you ever wondered what a sound wave would look like? So that is what we are going to see next. So what we have taken here is just a pipe, and we have stretched a membrane over it, and what we see here is just a mirror. Okay, so now what we're going to do is we are going to provide some signal to it, amplify it, and we're going to put the laser at the tip of this mirror, and according to the vibrations of the membrane, you'll see what happens. I want to take this as steps.
Do you put this next slide?
Now we'll see what happens. I'm slowly increasing the frequency here. So now it's at 10 hertz. It's 20, 30, 40, I'll just decrease the frequency again, and just notice what happens when I go around 130. So this is 110, this is 120, this is 130. Okay. So notice that 120, so this is 120, this is 130, 140. So 130 is one place where you get kind of the elongated pattern. Okay. So after 130 we have 140, and then 150 again you have that elongated pattern. So what is happening here, I'll just show you one more frequency. So now it's at 180, 190, yeah, 190. So 190 is another place where we have another elongated pattern.
Yeah. So what is happening here is that similar to the case of the tube, this like I told you that each object has its own natural frequency, right? Similar to that, the membrane also has a natural frequency. So it has what is called as fundamental modes of vibration. So what you observed when Lakshmi showed, there were like elongated lines, right? So those were
like a very big ellipse.
Yeah. So yeah, we ran out of time. So yeah.
We will just do one fun thing before. Yeah. So we have this pipe where one end is free. Any one of you are free to make some noise into it, and we'll see what that looks like on the screen. Anyone would like to come? It's going to be fun. Anyone can come?
Yeah. Okay. So what you have to do is you have to hold this. Oh wait, once give the sunglasses.
Yeah, we'll just.
You can put this on. Just yeah. So let's see. Yeah. Could you come up? Like that would.
Okay, it's over there. Yeah.
Hello.
Sir, you have to keep your mouth a little closer.
Hello. Yeah. Hello. Hello. Yeah. Try. You hold.
We can have the other laser.
That laser. That laser. എവിടെ? Hello. Hello, 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 hello. Okay.
Going on.
Try this. So, can wear this.
What for business?
Like, not to get the. Hello. Hello.
देखो रे नयन मेले
Yeah, okay. Yeah. So, yeah. Thanks for sitting through our presentation.
Yeah.
Yeah.
So there are many more things that you could do with waves, like so there are even gravitational waves or
Earlier, ma'am talked about Rosalind Franklin's pattern, right? She was talking about the diffraction pattern that was produced by DNA.
so that phenomenon is also has to do with the combination of
waves. So yeah, we were going to get into something called as diffraction. So what happens is what happens when you have superimposition of waves of different phases and you get this diffraction pattern. I hope all of you are familiar with that, right? So Rosalind Franklin used the X-ray diffraction to study the structure of DNA, which is an aperiodic crystal, and the structure you might remember
that was gotten from that
help prove that DNA has a double helix structure, and
that pattern looked like some kind of a cross.
Yeah,
So
we were able to replicate that, but we are kind of short of time. Should we show that?
If you could just show one slide of
Okay. Okay. Yeah.
And in the meantime, you make it ready.
Yeah. So basically, we tried to recreate that
Thank
quarter
you all,
51.
again, we were short on time.
Yeah. Okay. Thank you. Thank you for giving us the opportunity to speak today.
Thank you, Lakshmi. Thank you, Litral Singh, for the wonderful presentation on waves. Thanks a lot. Now we'll disperse for the short tea break of 10 minutes. We'll get back in 10 minutes. That is 4:30-ish.
Check. Hello. 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 Where is that one cover? Hello, hello. Check, check, check. Hello, hello. Hello, mic testing. Hello, hello, hello. Ah, okay, good. ಇದು ನಮ್ಮ ಹುಡುಗರೆಲ್ಲ ಎಲ್ಲಿರ್ತಾರೆ? ಇದು ಒಂದು ಡೆಮೋ ಆನ ಮೇಲೆ ಹೌದು ಈ ಕಡೆ ಬನ್ನಿ. ಹಾಂ ಎಸ್ ಎರಡು ಜನ ಬಂದು ಇದು ವೇಗಮ ತೊಗೊಂಡು ಅಲ್ಲಿ ಇಡಬೇಕು. ಓಕೆ ಸರ್. ಇದು ಇದು ಅಲ್ಲಿ ಇಡಿ, ಅದು ಒಳಗಡೆ ಇದು ಇಡಬೇಕು. ಇಲ್ಲ ಇದು ಬೇಡ, ಅದು ಆಲ್ರೆಡಿ ಮಿಕ್ಸ್ ಮಾಡಿದ್ದೀನಿ.
Are we all back yet? Can everyone be back at the auditorium, please?
Yeah. Hello, hello.
Shall we all get back here, please?
In Hindi, I know only that word, acha. When I come to
Let's quickly
Mumbai,
get back to the session.
ಇಲ್ಲ ಅವರೆಲ್ಲ ಬರಬೇಕಿಲ್ಲ ಒಂದ್ಸರಿ coordinator this all shall start.
Can we all get back to the auditorium for our last science demonstration? Okay.
Definitely. Huh? Thank you very much. We will look like Einstein.
Okay.
Yes.
So we've had it 3 long days of demonstrations, lectures, everything, and here we are at towards the end of the science demonstrations, and our Baradan sir, who's an education officer at VITM Bengaluru, will be concluding or will be giving the concluding show for the day, that is on amazing world of smart materials. Welcome, sir.
No. Next, our former. Okay, good evening, all my dear friends and respected former director, CRTL. No, that is former. And really, I am very happy to stand in front of you. For that, I convey my sincere. Oh yes, our engineer. So, no, executive engineer. Oh, pass, okay. Really, I feel very happy to stand in front of you. For that, I have to thank my director, because he visualized during our Diamond Jubilee year, he visualized and then he has given this wonderful opportunity to all of us. Because of this conclave, everyone, we came with some ideas. So that is the way everybody, you came with some new ideas. Same way, here I kept some of the materials. Materials in the sense, ordinary material only, but that will do the things extraordinarily. Like some people. Some people will be there, when you tell something, then they will do extraordinary things. Who are all they? Smart people. So here, these materials are called smart materials just by the external stimuli. On its own, it will execute the things, it will execute the extraordinary things. From lotus leaf to pine cone and then mangroves. Mangroves also, it is a very unimaginable thing actually. Salt water that will be there in intertidal zones. Plant never grow in salt water, but it took adaptation over the period of time. Everything will happen in air. Respiration will happen in air, germination will happen in air, like that it evolved. So just like that, here let me start our journey to understand. Let us dive into the some different world, and really I got excited. Definitely I believe that everyone you will get excitement. And let me start the journey. And here, if you can see there one plant, lotus plant. So it is having this is also, if you can see this plant, I brought the pot, it is a muddy water. Condition is actually dirtful condition. But if you can see this plant, over the period, it took adaptation, and it can live in that water 24 hours, And there is some wonderful development on the leaf. Water, it won't stick on that leaf. That is the way it evolved. And we understood that. Then we developed many chemicals, polyurethane, Teflon. After seeing that, then they developed, and then nano coating. Yes, many of our friends, they have explained these factors. This nano, so I can actually give the demonstration, and when I do, some of the 3 or 4, you can also come and have a experiencing this material. Who wanted to have a experiencing? Who wanted to? Any of the volunteers, please rush up, whoever you come. All young people, please come. Oh, youngest. No, I need 2 to 3 volunteers. Youngest among the group, please come, please come. Yeah, another 1 more volunteer, because another 1 more leaf I am having. Yes, you can have this. You can have this. And let us actually take some color water you can take. And only thing is, actually we have to, when you do that, I will come near to collect the water, because here that should not spill out. And this one, let me just first, I will do this with the white water. You can just see here, I am just yes, that everyone, you can just, there will be a spray, you can rotate. You just see here, water, it won't stick on that. Even if I collect, I think camera, if you can help me, and I can show that bead up and then rolls off, how beautifully. Is it possible to just, my hand, is it possible to focus this one, this leaf? Is it possible? Very good, very nice, very nice. Very nice. You see there, water is not sticking. I am just collecting now. Can you see there? No. I will do like that. Then everyone, you can have the visibility. Can you see there? Yes. Can you see that? No. Because I want to, can you see that it is actually simply rolling, and then you can one by one, you can just, very good. He also did. You can just see here, then you please, you can pass it. Fast, because I don't have time. Then within one experiment, they will press the. Yes, you can do that. Now, any color water, dirt water, if you can do this, and this won't stick on that, you can do that. Even if it is there, any dirt particles. Yes. Can you see there? Yes. Because of the dry, then it is okay. Sir, you can do that. Where is your leaf? Yes, you can do this. You can directly, you can check with this. Directly you can take that one. Yes. Here. No. This is water. This is polyurethane liquid. You should not. I have given this. Okay. Sometime experiments demonstrated to be very careful. Yes. Yes. Okay. You can just take this water. This already you tried, you know. Yes. You see that? Can you look at this?
Yes, I can show them.
Yes, you can show to them. And same one, we just mimic, and then we developed here. This is nano coated film. They usually stick on the. This is actually rear mirror. They will stick. Rear mirror, they will stick these films. And then this is also that coated film polyurethane nano liquid, this liquid, it is actually, I will give the demonstration. This is that liquid, polyurethane liquid. When you spray on your car, yes, very nice, very nice. Oh, very good, very good. You see there, you see there. Oh, wonderful, wonderful. It shows the property. Okay, thank you very much. And here, this application part, I will just to show you. If I spray the water here, then water it won't stick on that. Just it will roll down. Normal one, if you spray, you see there, you can, these droplets, it will give the clear image. Even in the car, when we use, if it is there smog condition or rainy condition, it will just roll down, and the rest of the places you can get the clear vision. So that is the way this film is very useful. And then here, this polyurethane, I am just spraying the polyurethane. You just see here. I am just cleaning this one. For now, it is having that thin film coating, nano coating, and then when I spray water, then this also, here also, water, it will, oh no, here it is not actually happening. Some tissue paper, can you just, anyone can you help me? Tissue paper. I kept one roll, our people they have taken and used. Okay, then I will do this. And other items, volunteers, please give me. Then you can remove other items. Because in this polyurethane, they actually suspended using the carrier fluid, and then because of that, when you spray, very easily it can spread. Then whatever result I expected, I am not getting. This should be looking like a droplet. You can remove this. So here another material during 1960. Then I will explain about this surface of the lotus leaf, lotus effect. Then I will move to the, what is, how much time, madam? No. First experiment, how much time it over? Oh, 10 minutes. Okay. Then that surface is having the nano surface. That is why we had that properties. And here I kept the another liquid. During 1960, this liquid was developed by Dr. Steve, a NASA engineer, because he had a problem. He wanted to develop some non-Newtonian liquid, because in the space condition, we have to control the fluid. And here, for that, he developed one material, liquid magnets. So this liquid magnet is called the ferrofluid. And when I just bring the magnet near, and then you can see the, I can just increase the viscosity of the ferrofluid, Now I kept the magnet, but you can explain the magnetic field. Magnetic force will be only in the at extreme ends, and at the center nothing. And here I will give you some pieces. What you can do that you can just have the, you can just give to them, let them just have the magnet. This is fluid and nanofluid. And then you can just see the field pumps up. Then I want to show you the another wonder material. Here I have taken the plates. This is already my Mumbai colleague, he showed this paper. This paper also you can just distribute to everyone. This is actually thermochromic paper. Just by hand, if you can just press it, you can get the changes. Generally, they usually use the spiropyrene, that chemical they usually use. And here so this one is the liquid crystal display. So liquid crystal display will have the material, they kept it inside, liquid and then solid. It is a very big molecule. At the center, biphenyl benzene, that is the solid molecule, and both the ends, one end cyano and acetate group will be there, two polar group. Another one is the alkyl group. So this alkyl group tail, it will act as a tail, and then another side is actually two polar. Then by giving the external heat or current, so we can change the direction, that positions of the crystals, then accordingly you can see the color. Just if you can give a fingerprint, then you can see the colors. And even you can here, just we kept inside. By just moving this, you can see the beautiful colors. Can you see that? You can just see that. Yes. Back side, if you have to just move like that, then according to the heat, here you can see the, can you see the patterns? Yes. Oh, yeah. Okay. So thermochromic paper, thermo means temperature, chromic is a color. Okay, you can take this. This one is the gelatin, and gelatin we have just taken gelatin. I think everyone, that is actually prepared from the collage. That one is the inner membranes of this skin, and then muscles, and then they have prepared this one. And it is having wonderful property. Here if I cut the knife, then immediately it will join. You can, so if I take this one, after some time, it will, because of that intermolecular attraction, it will just have a, it will join. You can just give to them, don't have time. Let them just have a experiencing. Pashupati, this also you can just show to them, let them have the. This one is actually another material, quartz. So here in the small plate, quartz is actually sandwiched. Quartz material is sandwiched in the plate, and then when you tap, you can see the So for this actually I made a one with the help of our electrical section. So I have to connect negative to negative, positive to positive. Can you see there? I am just tapping here. I think some volunteers can just, you please come. You can just tap it. You can just, you tap it, tap it, tap it, tap it, tap it. No, this side is crystal is there. Yes. You can keep it and then you tap it. Now you tap it. So crystal, anybody know that the name of that chemical actually? Crystal? The piezoelectric material, what chemical actually they use, what crystal they used? Silica, yes, silicon oxide only. Silicon oxide, that is in a pure crystalline form, that is called the quartz. And here, when you just give a pressure, all these materials, we have to give a pressure or temperature or heat, and then accordingly it will just sense that one, and finally it will have that simulation, and then it will work. When you tap here, he is giving the pressure. When you give the pressure, and then coordination 4, it will just change to the coordination 6. So during that time, and these electrons will be generated. That's what here we are seeing. Okay, that one you can just take it and put it there. Here I am just to check the 2 minutes. Okay. I am just adding water. Okay, I will conclude this one. I am just moving. In which bottle I just add the water? The center one. Not water. I took this sodium polyacrylate, that is super absorbent. That is super absorbent. 1960, American the agriculture department of the agriculture department in America, they developed this one for their agriculture purposes in a mass scale. And okay, I will just conclude with this. Thank you very much for this wonderful opportunity. And thank you all, my dear colleagues. Thank you one and all. Thank you very much.
Thank you, Bardhan sir, for the wonderful session on amazing world of smart materials. Now, we have Mr. Manish Bagchi sir, who is a consultant, Science Museum Projects and former director, CRTL Kolkata. His session would be on Wired to Behave, a neural narrative of human behavior. Welcome, sir.
Take it, no problem. Give it.
ಬಂತು ಬಿಡಿ
पावर कट चाहिए पावर कट मेरे बैग के अंदर ही है Hello. Done. Sound नहीं चाहिए ठीक है ना Okay. Thank you. Well, good evening all. And to begin with, an apology on 3 counts. Number 1, being an old man, I can't remember everything anymore. So I'll take the help of my notings that I have created for this particular session. And in most of the cases, I'll read, because the Rajamandri program and for other programs, I could not really work on these. And if you at all believe that I have any right to speak about the methods of science shows and mechanisms, I'll say never go to the stage without practicing it at least 50 times. I always try to do so. But today I'm breaking my own rule because I was compelled to. So when I'm on stage, I need to speak naturally. I expect everyone to speak naturally. The words should flow normally, but that may not happen. That will not happen today. But even then, whatever I thought that this would probably be my last presentation in front of you. And that is why I did not want to lose a single word what I thought about. So I had created a detailed note on it. That's the second apology. And the third apology is it can be a little longer. So I'll expect your tolerance and the gravity to keep you at your set. And in case you go out of concentration, you just please tell me enough is enough. I'll stop therein. Well, I wanted to talk about a neural narrative of the human behavior, and I called it wired to believe, because we all are internally wired to become not only human but a particular type of person. Our persona is defined by our internal wired structure. That is what I tried to show. And why so? Why this subject? Because normally, whatever we had discussed, I was not there for other sessions, but today I found that people think that science show means you rotate something, you mix something, you do something, you need a prop, you need to play with it, and that is science show. Now here, I don't believe in this idea. Actually, here I stand as the antithesis of what Mr. Arvind Gupta was trying to tell, as the antithesis of many other persons who believe that there is a very, very deep and important way of doing science just by practicing with a few tidbits. I don't believe in that. Why? I'll tell you. In the 1960s, when these people and another group of people started working on all such sorts of presentations, the world was a different one. How many people used to know then what is Newton's law? The percentage. You go to any school, I'm not talking about the so-called elite schools, which I don't believe in, but in other schools which are even remote, they might be speaking in their vernacular, but the students still in the villages would be able to tell you what is Newton's law. They exactly are going through the CBSE systems or the NCERT books, and there are all such tidbits are already included. So you are not doing anything extra when you are telling them you can join two sticks and dance them in a rotation. You can be happy that we are doing great job, but actually probably we are not. And that is why I think this so-called show, who is the greatest showman to us? Who is the greatest showman? One of the greatest showmen you can think of? Raj Kapoor, Charlie Chaplin, Shah Rukh Khan. Do they need props? No. They act with their face. They act with their body. They speak with their emotions. So actually playing with the emotion is the real thing that should take the subject and content over to you, not your props. If the props become important, then you have failed. That is what my belief is. It might be very important, or it might be self-indulging to think that these sort of presentations are doing good job and they are challenging NCSM in its forms of presentations. I challenge them to prove that over last 60, 70 years, they are also practicing it. What new they have done? Have there been any of the Nobel laureates coming out from their forms of education? No. On the other hand, on the contrary, you go to NCSM and you go through the lists of NCSM people and the people who benefited from the council, you will find there are several important scientists who sincerely feel that this council has contributed in their career. And there is another practice. Many a times we say, we undermine, we talk about this school teaching and we say, faltu. And I was listening to the afternoon presentation. What do you remember? The tiffin, the gong, this, that, and that. But don't you remember what you learned there? Don't you remember your teacher giving you an interesting question and you thinking over it and pondering over it for hours? That is the carry out. This teaching system has produced Saha. This teaching system has produced Raman. This teaching system has produced Rabindranath Tagore. This has produced many other stalwarts. So please don't discard the school education and college education just so easily by saying that it is all blackboard and chalk and talk and nothing else. The thinking, the teaching still has to go in your mind. You are playing with your mind. And your props may help. I'm not discarding it. I will definitely request people to explore that line as well, because indeed, when you work with your hand, you also think about it. That's very, very important. But the problem is, if you think that only making some stupid prompt is going to get you through with your content and getting it over to the people, my caveat is, please don't think so. It will not work. And why it will not work, I will try to present, because there are many misconceptions among this sort of presentations. We were talking about muscle memory and body memory and all that. Do you find any memory in your muscle and body? It's a nonsense. It's an epithet. People think that you do the parade, you move, and you regularly know what is the rhythm. Where do you know? Not in your legs, but in your head. Once again, the pattern is stored here. Once again, the sensation, the movement, the pattern really is created here as a molecular thing. And if you think of knowing something and not knowing something is actually a structural change in configuration all here. So what you have to address is the brain and not the legs and bodies and all that. They are mediums. I'm not discarding them. I'm not saying that you don't dance. I'm not saying that you don't try. I'm not saying that you don't practice the drills. You do. But please don't think that a stupid drill will make you learn anything. This is my request. I'm maybe a little more emphatic, but that is not because I was very, very shocked when there was a steamroller going on, the philosophy of this council. When a steamroller was going on repeatedly, it was being mentioned that big museums, big ideas, big acres, big money, that is not doing anything. If that is so, then we all are useless. And I don't think it is true. You have done tremendous jobs. And when people come there, they interact with our things, they work with our systems, they go through it, they have a continuing relationship with us. I can find these sparkles in their eyes. He might say that when they just do one thing within a room, that's a great thing. It's a great thing. I have no objections to argue, but it is one of the great things. Please don't undermine the other options and other way outs and think that what you are doing, you are actually doing an advertising of a particular philosophy that you follow. Well, might be that became a little bit hot an introduction, but anyway, that was not the introduction. What I wanted to talk about is this. I'll come to the basis of what my points were. You know, we breathe and we see our chest rise and fall. We walk in hot weather and we sweat. We move our arms and legs and we see the muscles contracting below our skin. We become excited when we approach someone we love or we have a crush on, and we feel our heart rate increase. We can remember the smell of our grandmother's basement, the father's attic, your feel of your favorite shoes. And when we do that, who is at work? It's a very small organ within our body, and that is you know what is this? This is the sign language of B, R, A, I, and N. It's the brain. But why did I use it? Is it a gimmick? I know sign language, you know, so I showed it. It's not that. I showed the sign language just to tell you that many people in this world doesn't have the gift of sight. But that doesn't mean that they are any linguistically weak, because loads of research has gone on over the last 150 years, and we know all the same areas that work in the brain when we speak, when we hear, when we listen, when we talk. It is the Broca's area and the Wernicke's area. It is the same area that is also excited when we see the sign language. Not in us, because it is not the training. We are gifted with the sense of sight. And that is why for us, those organs exactly do not work the same way. But if you really practice it, and if you start at the beginning, for the people who doesn't have the sense of sight, they will really excite the same regions. I'm going to tell you an interesting story from our lives. We have a friend, many of us, you know, he's there in Seattle. I'll not take his name because it's a medical condition that I have to talk about. This person generated certain nodules in his spinal cord. Just 4 months back, that was operated. One of the nodules was quite big, and that was removed. And when that was removed, a part of the neural section in the spinal cord had to be removed as well because it got coalesced. What was the result? Immediately after this operation, his legs were not working. He lost control over his legs. He used to walk like this. And he had lost control over his urine. He had lost control over his bowel because it's the lower part of the spinal cord that was not working. And we all were very, very concerned. We went to the doctor and we asked, why so? Why is it happening? And the doctor said, don't worry. The neural network that was created in the body over practice, the practice over several years, that is gone. That neural network is now broken, it's disjointed, but it will form again. We need to give an aided movement. We need to do physiotherapy. We need to give some drugs and medicines to facilitate the systems. It will revert. It will return. New neural network paths will form. It was done. After 4 months, the same person is now driving the car again. He's coming to office regularly. He's working with us once again. And it is the miracle of this small organ that we have in our body. The question is, I showed it to you, the patterns, how it works. The point is, brain as an organ is a very interesting creature. It is because, you see, it is the same organ. Normally your heart functions for one particular objective. Your lung works for one particular objective. Your guts work for one particular objective. But your brain, it remembers, controls, feels, manages, and it also consumes 20% of the total energy expenditure of our body. So even when we are sleeping, the brain is working. And that is why it's a multifaceted organ with multifarious activities. So what is the basis? That is a very important clue about what sort of organ it is. The tissues in brain, they are not static like other tissues or other organs. The kidney is meant for a particular function and the tissues are in evolutionary way formed exactly for that purpose. But brain is not like that. It is dynamic because it was seeing at this moment, at the same time it is listening, it is at the same time feeling, it is at the same time emoting. So it is like a multi-purpose computer. That is why we call the brain a computer. Because a computer can be used for writing, computer can be used for processing, computer can be used for controlling, computer can be used for many things. Why so? It is because the programs in it dynamically keeps changing. So in the brain, the neurons also actually are dynamically setting their relationships among themselves. And that is why so many, unlike other subjects, and that creates another new thing in the subject itself of neurology. Other subjects, the biology, physics, chemistry, whatever, geology you think of, they have a definite domain. But neurology is a subject in which physics works, chemistry works, computer science works, and many other subjects get merged into this particular subject. So the experts who work on brains, they are not taken from a single field. Even psychologists and artists, they also work on neurology of brains. Now, this one brain and many functions, this is possible because of the neural networks that I have already told you. And you are practicing something in the afternoon. You all stood in a queue and someone was giving a shock and the shock was getting past. And what did you do with that? There lies the difference of the science show and a general show, so to say. And other people do not understand why we need to do certain special things. I was also thinking of doing that demonstration, but now I will not do. I will not include any demonstration. I will just go through. You will have the idea what the demonstrations could be. Suppose we are all standing in a line and you are getting the shock. What you are doing? You are transferring the shock. It is exactly like the neuron. The neuron getting the signal and passing it over to the next neuron. But if you want to demonstrate the form as well, you can include one motion which was not there, what she was doing. You can do the action potential kink. It goes up and goes down. Once again, it goes up and goes down. So it takes some time for the neuron to process the signal as well and pass it over to the next neuron. And when that goes, ultimately the signal reaches its end. Now, here the important thing is, if you make it a game, what happens? You just snatch a bag and everybody, come on, and all that happens. But that's not the end of it. Practice it, keep the people in a row, practice the same thing, maybe with the action kink, action potential kink, but do it 30 times and each time measure the speed that you are generating. You'll find that initially you are probably taking 2 to 3 seconds, but slowly the time will reduce. And when it will reduce, you know the neural network has set in. Now the neuron network, they know that this is a job that they have to do repeatedly. So what we are doing, we are learning. And that is the physical basis of learning. My neurons know it is bound to happen. Now this happens in 2 ways. Brain is a very energy intensive and energy optimizing device. Brain is not a thinking device. We think we are thinking. Actually, the brain is not thinking at all. I suggest you to go by a very recent book that is a fantastic book. It's called 7.5 Lessons on the Brain. The 7.5 lessons in the brain say that brain is actual. Not only it says, there are many current books. This is a very accessible book, so that is why I give this name. That says that it is an energy optimizing device. How? How so? The first point, when we receive some action or receive some stimulus, we try to understand, do we have a neural network for that? If the neural network exists for that particular stimulus, just that network fires. So it's existing, it's minimal energy path. But if it is not, then you have to practice it time and again. You are doing it, missing it, doing it, missing it, doing it, forgetting it. And after some time, perhaps the brain will think that, "Arey bhai, ye bahut badmash aadmi hai, ye chhod nahi raha hai, बार-बार एक ही चीज करे जा रहा है." Probably it is important, so brain will retain that. So either you can learn by rotting. बहुत हमारे अंदर बहुत इंटेलिजेंट लोग हैं, मैं ऐसा नहीं हूँ, मुझे बहुत बार पढ़ना पड़ता है एक ही चीज सीखने के लिए. लेकिन क्या होता है, पीपल से कि अरे वो तो मेमोराइज करता है, कुछ भी करके दिखाओ मेमोराइज. आसान नहीं है. Memorization is also learning. If you are memorizing without understanding the meaning, then you will not be able to fire new neural networks out of it. But even learning a single network path is not an easy task. And that is why Sachin Tendulkar is Sachin Tendulkar, because he practices cover drives perhaps 500 times a day. He practices one particular form of defense probably 1,000 times a day. So his neural networks exactly know what to do on that particular condition. The others have to work on new neural networks, but it is already formed in him. So he will get shed more time than others to negotiate this situation. That's why quite commonly the commentators often comment that he gets more time for offering the shot. He gets more time because he practices more, because he thinks about it more. And it is not that all the time you have to practice it physically. Sometimes even by thinking and contemplating you can learn one thing, and your thinking, your fantasy can be a reality. The example is Sergei Bubka, one who broke his own record 11 times, world record 11 times. And when he was asked how you do that, he explained, I jump 1,000 times in my mind. And when I jump, I make it so accurate that I get this smell of my sweat. So I know what is happening. I can hear the sound of the people around me. So by that, he exactly makes it real. His neural networks start working for real, and it actually forms. Well, based on this, one Japanese scientist developed something that is very, very interesting. He thought that if this is the case, we are being activated in our brain, certain stimulus is received, a neural network is formed, the synapses are charged, and the network is already in place. Then can we devise something which is called a perceptron, in which one signal will go, and that signal will be given a certain weightage, maybe 10%, another will be given 20%, 30%, and like that 100%, and depending upon all of them, when I get 100%, I fire this network. And this is an algorithm he created that is called perceptron algorithm. And today, whosoever is working on AI actually is working on this perceptron algorithm. This perceptron algorithm used in series and multiple of them, and multiple of these layers actually is the CNN logic or CNN algorithm that is called convoluted neural network, and it creates the basis of all AI. You can call it an artificial brain. It doesn't exactly form the same way the biological network does, but this artificial brain is also now created, and we were talking about the LLM, the large language model. How is it so that I tell the large language model to write a letter for me, giving a fake explanation for taking a CL tomorrow so that it will be convincing to the director, and it writes a beautiful letter in that purpose? How is that possible? It is just because at multiple levels of this perceptron neural network, it checks it. It creates a logic and rechecks it. It comes back, it rechecks it. Since it is a computer, it does it very fast. And finally, all the accuracy levels are crossed, and I get my final product, and that is called large language model. Test one thing in large language model. Tell the ChatGPT by giving one particular Indian raga to find out which raga is it. Tell it. Sagama Padhanisa Sanipa Nipagamagasa. And what is that? The ChatGPT will not be able to tell that. I tested. It doesn't. Why so? It is because it doesn't have the data for that class of raga. But you give it, and immediately it will tell, this is jazz, this is that, this is that, and this is this. So all those will come. So it's the data and the perceptron logic that will work, and that actually is also the functioning of the brain. Now it's a very interesting thing that it is such an important and such an exquisite organ. How big is that? It's very simple. This is your brain size. You just make a fist and take both of your fists and you get your brain. That is the brain size. It's very simple. And it is also the shape of the brain because there are wrinkles over it. I'll come to the wrinkles immediately. They are very important observations. And that is why I am saying, look at this shape, and you know that this is your brain. It's a small device. It's a small device. For a human being, it's about 1300 grams, 1.3 kg. Now, is that important? What is the weight? The weight would be equivalent to about 11 bananas. And that is another prop you could use perhaps, but I have no intention to use props today, so I'm not doing. I'm saying you can imagine what it is, 11 bananas. You can take it to one hand and move around, or throw it to somebody he will catch. So, about, it's an average, it might be 12. Well, if it is bigger bananas, then there can be another weight as well. More or less, it's on the average side, it's 11 bananas that it weighs to. But does it relate to the intelligence? The weight and the volume? Actually, it is very tempting to correlate that way, and we feel that it might be true, but it is not. Why so? Because the elephant or the sperm whale will have much, much larger brain size and brain weight, but they are not more intelligent to us. Very interestingly, if you take the ratios of their body weight and their brain weight, you will find that human beings stand at the top. For human being, it is almost 461. But for others, hippo or the elephant or the sperm whale, it comes to around 450, 444, even below, but never it goes beyond it. So, is it important that the body volume, body size and the brain weight is actually related to the intelligence? Not exactly. The correlation is still not very clear, but one thing is very definite. We had got fossils of dinosaurs which showed that dinosaurs had a brain right at the top of their head. So if a dinosaur meets with some accident because of the imbalance and the dinosaur falls, the information of the fall will reach the head very, very late. So most of the dinosaurs used to die because of this falling problem. They used to fall, they used to have huge injuries, and broken bones show that in most of the dinosaur fossils. So it's very clear, and that is why if you read the latest book, we are very, very ill-informed about dinosaurs. We think they were stupid animals. We think they were all extinct because of their callousness and all, or the world became hostile and all. But that is not true. Dinosaurs lived much, much longer than us. We are probably not going to last that long. At least Trump will ensure that. So it is not a case. It is not a case. They are pretty, pretty intelligent animals at their standard, at their time. And some of the dinosaurs had another secondary nerve ganglia at the position of their hips and waist because their stability of the legs had to be controlled. Reference, please read Robert Bock about the new knowledge about the dinosaurs. Our knowledge of dinosaurs is at the level of kid books. We only know big Tyrannosaurus will come and eat us all. That is not true. That is not true. There were ranges of dinosaurs at every level, and they had an excellent neural patterns there. The point is, if you go further, you will find, let us get a little more technical, and you will find out that the primates here, if it's you take a scatter plot of all the body weight and the brain weights, the primates, they form an island which is surprisingly above everybody else. What is the reason? The reason will come clear if we go to this one. I was talking about the wrinkles on our hands, and these are the wrinkles. And you find you are going down and down and down and down, and you are getting smoother brains, no cleavages. So why these cleavages are important? The cleavages are important. It is because within the same volume, if you are going to pack in more number of neurons, then these cleavages are masked. So that is why, compared to other animals, you see, African bush elephant has bush elephant has got a weight of this much, but compared to that, it has got 5.59 billion neurons in its cerebral cortex. But a human being at the same time has 16.3 in 1232. Okay? So this number of neurons, the possibility of having more and more lasting neural networks, that is the reason of intelligence, nothing else. It is nothing miracle. It is just a structural problem that needs to be studied. And I feel that any science show actually should be targeted not to make someone interested to read the physics book of class 8. That anyway one has to do because of the syllabus and because of the 100% literacy target that we already have. But we need to make students interested in studying science to go further. The class 8 or 10 level science will not take you anywhere else. This country will be stalled into the primitive era that it was 50 years back. So please go beyond this era of rotate a ball and erect a stick, cut a piece of paper and paste it over your forehead. It is not going to help any further. Think beyond. Think new subjects. Give the challenges to the students so that they get enthused when my blood boils to know whether it is really so. Then only your work is done. Then only you are working for the country. Otherwise, you are working for your B's and C's and D's and E's and F's and G's, and that is not going to help anything at all. If you have to work for the country, you have to think in different way. And now, because of the structural problems, there was a very, very strong epithet going on among the people that, you know, human brain is such a strong organ, it has got so much of strength, we only use 10% of it. It's a very persistent myth that we human beings use only 10% processing ability of our brains. I can refer you to n number of papers which shows that ये खोखलापन दिखाया, इसीलिए मैं ये फोटो लिया कि only 10%, बाकी सब खाली है, कुछ नहीं हो रहा है. And if you represent it graphically, is it the thing that we are going to have? Wait a bit. Let us go to the recent MIT publication, and they have shown this image. They have created this about the activity of brain over the whole day. And it shows 100% of the brain is being 100% used almost over the whole day. It never waits. It never takes any rest. It is not like us, कि बहुत हो गया काम, अभी तो थोड़ा बैठ लेते हैं. And this paper goes even further. Beyond this simple show of, see, it is vibrating. It is not that simple. Science is not done that way. See, this is rotating. Science doesn't work that way. We need to explain why, how, and in what case it will not. And if it does, then how we can use it for further things. In fact, this is a very, very interesting paper in that it is shown, you were talking about the resonance, and it showed that every brain has a resonance pattern. It has an oscillating pattern. And if one particular new stimulus creates a resonating vibration in the brain once again, if they go in unison, you can once again understand the energy transfer is maximum, and that's why there is maximum chance of retentivity of that particular idea. So there is a new series of books on the cards now. It is called Brain First series. The Brain First Physics, the Brain First Python, the Brain First C#, you will get all that. And they, on their front page, show something very interesting. They say, one I mentioned, rotting actually tells your brain this is important, carry it, or otherwise there can be another way, a tiger jumping in your front, and immediately you are shocked, and you know that this is important. I will not forget this experience. So either a shock or a retention, this is the real reason why brain carries information, why it cares to take a stock of it, And the 10% myth is challenged by many other things. I'm skiing, I'm actually using the cerebellum. I'm sleeping, I'm using the brain stem. I'm jumping, bungee jumping, my cerebrum is working. So many other parts of the brain are activated by many things. Brain is not a simple linear device. It's a very highly nonlinear device, and that is why nonlinear physics people are working very strongly on the problems of the brain from the computer science itself. So my urge is, in every science show, we need to show a path that go for this new area of study. Go for this new idea to develop. And we need not develop anymore. Now we have about 70-75% of basic literacy. We have people who mostly 60 to 65% or even more who are passing at the class 10 level or class 12 level. Even in the villages, it is exactly like that. But वो जो बोलते हैं ना, that's a 70s model. एक दलित बच्चे को कह अरे दलित बच्चा अलग है क्या? नहीं है. Give them the opportunity. Make them enable. आप दलित करके उसको मैच बॉक्स ही हाथ में देके रखोगे तो वो साइक्लोट्रॉन कब सीखेगा? लेके आओ, सिखाओ उसको साइक्लोट्रॉन. Come out of this matchbox era. The matchbox can be an initiator, but we need to give them the path to go forward and climb the mountain ultimately. So my urge to all of you, think of new areas. Think of new ideas. Think of new techniques. Think of new subjects. And one can say, I am a student of biology. How can I talk about physics? There's no point in it. Schrödinger, as a physicist, created the idea of DNA in his book, What is Life? And when other subjects also gets merged and people come from various other things, I have heard E.O. Wilson's lecture, who said that at the age of 37, I learned calculus because I understood without learning calculus. Without learning, somebody was showing here the salmonella vibration. They told it is a wave. It is not. It is actually an oscillation. It is an oscillation of the kind of Lotka-Volterra oscillation. Now, Lotka-Volterra oscillation is the oscillation of the population. Any population, because of the persistent force on that population, grows and shrinks, grows and shrinks, grows and shrinks, and that becomes an oscillator. So different sort of biological oscillators exist, and when you analyze those oscillators exactly from the point of view of physics, you get to know situations, you get to know exact equations by which you can control the population size of that community. So that is not true. But one point is the brain power always equal? Is it so? Are we not aging? We are. And how do we know we are aging? I once again thought of a demonstration, but I will not do it because of the time. There's a very simple way. There are 100 other ways of doing it. I urge people to explore neurology. It has been such a fascinating area of study of late. What is that new idea? Whether you are aging properly or not can be very easily tested. Stand with your eyes closed, stand on the non-dominant leg, and try to hold your position and see how long you can. If you are able to hold it more than 30 seconds, you are good and healthy. But with age, you will find out it is not possible. Probably within 10 seconds, you will be swaying quite a lot in your body. If you can stand stably and steadily, then it's a good sign of your health. But once again, if you think, भाई मैं तो 2 सेकंड में गिर गया, तब तो मेरा गया, मैं तो कल या परसों मर जाएंगे, उसके बाद क्या होगा? कुछ नहीं होगा, practice. कुछ नहीं होगा. Improve your health factors. Let me tell you, very recently, last year, I will not claim him to be but he is of Indian origin. Professor Venkataraman Ramakrishnan has written a book. It's called Why We Die and Why We Don't Have to. And if you read that book, you'll find out he is talking about a fact that 120 would be the new age 80. So the people will live up to 120 as they do today up to 80 very easily. And it is happening because genomics-based drugs are now being administered. Now we know that every disease has got a genomic basis. Thoda pani mil sakta hai? So based on that, oh, okay, done, I got it. So what is happening is, earlier we knew that medicine is only therapeutic. I have a problem, I go to the doctor and have a therapy. But now the doctor can tell me it is not just symptomatic. It can be of some definite genomic origin, and that genomic origin can be treated. Once we do that, we have a better probability of sustenance. And this curve is very interesting. This has also been published in Nature very recently. And it gives us certain amount of thinking and certain amount of solace. There are two exact age in the life of a human being where one gets a huge change at the molecular constructions and molecular patterns in one's body. That happens at 44, and that also happens at 60. And these two are the peaks. Here you see in 44 and then at 60, and after that these disruptions get slower and slower. So if at this age you are more or less healthy, there are chances that if you are not tampering with it otherwise, you can get on healthy for quite some time. There are several other books which actually discusses this thing in quite a detailed position. And now I can go on and on about every part of the brain. Every part of the brain is like a book. So you can discuss that. But one thing I can tell you, that even if nothing else is there, you only have the brain stem, you can still live. Because all the basic functionalities will still work, but probably you will not have the sense of sight. You will not have the sense of sound. And that would be pretty much fearsome life. But the problem is then you may not feel the fear at all. And interestingly, there is one animal which exactly does that way. And that is why that animal has sustained the longest change over evolution, the cockroach. It's a ganglia. So it is the basic brainstem almost like that. I'm not saying our brainstem is much more complex than that, but even with that, the basic functionalities can be over. And you can know how it is working. It is such a wonderful thing, but I call it the observations we don't process. Now a simple observation is I'm looking at this camera and I'm changing my head, I'm moving. Surprisingly, the camera remains in one position. The whole environment changes its position. But if I focus, the camera remains there itself. You do it with a movie camera and you will know how jerky it is. Only some people with extremely stable hands can do it by a long practice. But your eye does it. Your brain does it. They know how to keep the particular object in focus stable. And when you are doing that, you know that your midbrain is perfectly healthy. It is actually being able to do that. So in several cases, in another experiment, it's called Luria test. It's very simple. You can all try that. The test is you have to function three things all together. Firstly, fist, strike it, then the side, and this, and then increase the speed. Three times. Can you continue 3 times without any break? You'll see you will break it. It is very difficult to do it 3 times consecutively and increase the speed to that level. It is because your midbrain is not conditioned to do such things. So these are simple neurological tests with which you can check the functionalities of your brain in various regions and in various places. It is possible. And when we do that, we know what a wonderful device it is. Now, if it is such a wonderful device, it also needs to be protected very strongly. And here, I could have another demonstration, but once again, since Jyoti said that without props it will not be allowed, I made it a point that I will come without props. So, what you could do is, your brain is like an egg. Put it in a jar, give it a jerk, and wow, the brain is gone. It's smashed. But to protect that, what do? We actually pour some water inside the jar. And now you shake it. It will not be broken. It is exactly like that. The cranium holds the cerebrospinal fluid that keeps the brain in place and gives it the cushioning. Very interestingly, if you observe, suppose it works for us, but have you seen the woodpecker? Continuously it is going on, and so strongly. So there must be a huge jerk in the brain. How is it prevented? How does it manage to sustain that? And that is very interesting. Evolution can do many wonders, and this is the fact. Number one, its tongue is very interesting. Its tongue goes around its cranium and ends it here, almost protecting the brain. And not only that, over it there is a hyoid bone. For us it's a strong cranium, but for them it's a spongy bone. So that protects the bone that way. Now, we may also think that this is some intelligent design. Somebody designed it like that. Is that true? It is not. Actually, what happened is, it's a variation. She showed that even in copying by 7 persons, the message has changed. So similarly, genes change, mutations occur. And by mutation, different patterns emerge, different designs emerge. And those ones which are not successful will die out. The environment will not allow them to live. So which will live are only those which can sustain in that environment. So it may appear like an intelligent design, but it is not a design. It's a fact that is happening by the selection of nature that Darwin predicted long back. So there can be several other tastes. This is called Ponzo illusion, and you all know it's very simple. You can all tell actually the both yellow lines are same. But that you are saying from your spinal cord, because being in the science center, you know it is always the case to be. But show it to a normal man, and if the person says that no, the upper one is bigger, then actually his or her midbrain is properly functioning. The illusion is the proper thing there. We are conditioned to think otherwise because our brain has formed a different neural network because of our science center. Okay, so it is not the exact thing. Anyway, now I'll come to one more interesting point. If all of you are told that you have to forego all your senses, but you can keep only one, which one would you like to preserve? Sight, 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 hearing, smell, and that prompts. Well, we don't consider touch as our first option. But Vladimir Nabokov has written a fantastic line. It is strange that the tactile sense, which is so infinitely less precious to men than sight, becomes at critical moments our main, if not only, handle to reality. There is a reason for that. The eye sees, the ear listens, the nose smells, but the skin feels. And that is multifarious. Without contribution from two or multiple agents, the touch cannot happen. So skin is a social sense. Sighting is personal. Hearing is personal. When you lose them, you definitely become lonely. But if you lose touch, you almost lose the life. If you study our linguistics, that is where I was trying to come next. I had a long note on that. I'll leave that note with Jyoti. So if you at all like, you can read it further. When we speak, we say, I'm touched by your behavior. I feel that you are very good. You know, you are so rough. And somebody is so prickly. We are all talking about the tactile senses. The tactile sense is the only social sense that we work with, where involvement of multiple people, multiple agents are extremely important. That the tactile, I'll come to the close very soon. I'm closing. Don't worry. The tactile senses can be tested very well in thousands of ways, but I will talk about only two of them. One is the Aristotle's illusion. You just cross your finger, and with that crossed finger, if you touch anything that is spherical or even your nose, you will feel like you are touching actually two things. But why so? It is called a perceptual disjointing. Because normally our fingers are not practiced to touch like this. We are practiced to touch like this. And when we touch like this, we feel it's one. But when we touch like this, we feel we are touching two things. So the disjoint can happen. There is another test that is very simple. I made a kit of it, but I could not bring it because I had to go to Rajahmundry. You make a partition, put your hands on both the sides, and here you keep a rubber hand. It's called rubber hand illusion, that was created by one of a very, very fantastic neurological scientists in India. He is Dr. V.S. Ramchandran, not our former director. So Dr. V.S. Ramchandran created it, that keep it here, two hands, real hands, and one false hand. And you just, with the help of one feather, give sensation to both the false hand and the real hand continuously. Let your eyes see that the sensation is going on. And then all on a sudden take a hammer and hit the false hand very strongly. You'll find the person will withdraw his own hands. Why so? It is because actually tactile sense is not also an individual sense. It is being supported by other senses. So the neural networks of your sight is also exciting the sense of tactile feeling. So it's a complex thing, very complex thing. When you are testing some fruit, you just close your eyes and close your nose and test the fruit. You will not be able to differentiate between the apple and the pear. I thought that I will show these demonstrations, but I didn't have time, or I could not make the props. So if you wish, you can do it and test it, and I can assure that it works. This is the rubber hand illusion, and it all happens because if we map our body in our cerebral cortex, that is called proprioception. In our cerebral cortex, we have a map of all our individual sense organs, and you will find out that certain organs are more sensitive to others. They are given lower positions. These are the maximum sensitive things of our body. In lessening order of sensation, it goes up like that. And with 2-point sensations, you can test that where you have maximum sensation. If you touch with both fingers the back of your hand, you will see that finding 2 points is less sensitive. Do it on your lips. You will immediately identify that 2 points are very, very different and very, very distant from each other. So there are hundreds of such demonstrations, hundreds of such presentations that can work with. I'll just end up with one final image that has come out on 10th June, and it has been created by the MIT researchers with a paper that will come out in Nature in another month or so. And the image I'm going to use it actually was a representation of that research that came out in Quantum magazine. What they say is we are harrying the artificial brain. We are harrying it very strongly. I find and I know our curators who has been tasked with making a new gallery from an old one. He's pointing towards the new old one and shifting it and giving it to the ChatGPT and telling, give me the new image, and the new design is given, and that is being processed. We are writing a subject and telling, give me 25 exhibits on such and such with interactivity and a little bit of kiosk and that. And that is happening. And when that is happening, MIT says that with most intelligent people they tracked in MIT who has got very, very high records of good results, it is found that when they are not using ChatGPT, their brain activity is all comprehensive. While they are using ChatGPT, it is getting squeezed up to a lonely corner of the brain. So it is your choice to decide whether you will actually ignore such a fantastic device or not. But I will end up with one more thing. It is happening. We know in all possible cases, we are ignoring our real brain, we are ignoring our creativity, we are creating 1,000 things but ignoring many others. And I would like to just remind you one thing. We have a very common logic that when we deliver cheap things, people are talking about that बच्चे ये पसंद करते हैं ना, कूदना, खेलना, दौड़ना, कलर करना, पेंट करना. भाई बच्चे कैसे बनेंगे बड़े वो हमारे ऊपर है. We need to give them the bottle to grow up. We cannot become these kids just to tell them what to be. Yes, give them independence. Yes, give them scopes. Yes, help them. But at the same time, create a pathway for their growth and development as well. If we can't, then we are bad parents. We are actually failing as guardians. And that is why I believe कि ये हमारे लोग पसंद नहीं करते, ये बहुत complex है. Can that be a solution? And I will refer to two big statements. One is Satyajit Ray said, I never treated, he was a fantastic child filmmaker, children's filmmaker, and he said, I never treat the children as stupid children and stupid agents. I always treat them as adults. And that made Satyajit Ray what he was, and that made his film so famous for the children as well. And Feynman, you know what Feynman said? The Feynman always used to say that if you cannot explain any complex idea in 2 minutes to anybody, then you have not understood it. So ये logic भाई फेंको बाहर, बहुत हो गया. हमारे लोग समझते नहीं हैं, हमारे लोग पसंद नहीं करते. Actually, you are not being able to tell the story in proper way. So my urge is, think twice. Think again, study. My days are numbered. I'd like to leave this stage with one single comment. Will you be able to remember what was the most popular Hindi song of last decade? You'll find it difficult, not possible. But you will very easily remember Aaja Re Pardesi. You will remember Majnu Sultanpuri. You will remember Gulzar. You will remember Javed Akhtar. Why so? Because we carry them. We can forget 1,000 things, but we still remember Rabindranath Tagore, who said, Amar raat pohalo sharodo prate, Amar raat pohalo বাঁশি বাঁশি আমি তোমায় দিয়ে যাব কাহার হাতে আমার রাত পোহালো, which translates to, oh my long night is ending, oh my night is ending to the dawn of autumn fading in, oh flute, my dear flute, to whom should I entrust you, to whom should I entrust you? I leave with the hope that I will meet you again, perhaps at the rising of the brain. Thank you very much.
Thank you very much, sir, for your very deep and insightful talk on neural narrative of human behavior. I think talks like this makes us appreciate the brain and its function and the complexities it has, and to see how fantastic it is, right? And it's actually really important to speak about brain. So thank you very much, sir. For our next session on peer review, I invite our director, VITM, Mr. Shri Saju Bhaskaran, sir, to take over.
Good evening, all of you. The first 2 days I couldn't attend, and today also only partly I could attend. The idea of this conclave happened during our discussions on what program we can have during our 60th anniversary, VITM's Diamond Jubilee. So I remembered attending a science show workshop almost 18 years back. It was held in Mumbai when a former Director General I.K. Mukherjee took the lead. So I coordinated the 2 science shows which we developed at VITM, and it was a really interesting thing. But as usual, what happened is after we developed maybe around 10 or 12 science shows, many of them, I think even in VITM we didn't had such shows. We still have only that fun science show and liquid nitrogen show and maybe electricity and magnetism, things like that. So when we thought of, the first thing I told is we had enough of many of physics related science shows. Why don't we have something on biology, chemistry, mathematics, etc. I don't know how many of you brought new subjects. So as Mr. Manesh was telling, let us look for new subjects which we are not touched upon, which we are afraid to touch. So let's, I would like to hear from you, and one more thing, it was maybe bringing a lot of theatrics is not very much required in science show. As always we tell, the content is what is most important, and to make it more engaging, maybe you can have some like a storytelling, you can have props, so all those things. And more than that, what I feel is a passion with which you are doing it. You should first like what you are doing. So I've seen some of our people, even now some of our trainees doing it. So they do it with a lot of passion. There may be mistakes in what they are telling, but even with that, the passion which they present it makes it more interesting to the public, more interesting to the visitors. And I've seen visitors going and congratulating them at the end of the shows. So that is one thing, that visitors should be engaged. And as Manish was telling, there should be something more, which they should take home at the end of the show. So I would like to hear from you how it felt. Your criticisms are more welcome than accolades. Should I call some names? Ashri?
Thank you, sir. Thank you. Sir, first of all, I thank you to give us an opportunity after a long time, in fact. In fact, after 2011, I cannot remember whether this kind of program has been organized. Yeah, it's a big thanks to you and Jyoti madam also for coordinating this program. And we got so many ideas over here. And our last 3 days probably was very engaging and long day. And we concluded with Manas sir's insight. So thanks to all. And thanks to our Delhi colleague and Mumbai newcomers. And they really, I appreciate their energy over here. But this program has so many new ideas, I think. I think apart from this physics and day-to-day science that we come across, we had some new ideas, like Aditi has given an idea, and that nanotechnology, he is from Tirupati, he has given some, today Baradan sir has shown some smart materials like that. This kind of things we'll try to incorporate in our science center, of course, this idea. And moreover, there's resource person. I must tell you, in choosing this resource person, you was really nice. It is fantastic. Just we need some more workshop like that. Thank you. Thanks to all.
So actually, only the idea was mine. All the things was done by Jyoti and her. No, not the blame is for me. I will take the blames. So because most of the thing was done by Jyoti herself. And I would like to, maybe this is not the end of the workshop. It should continue, and the interaction should continue. Maybe some new demonstrations which are doing, we can share amongst ourselves, and how these scripts can be better. If you can share what you are doing, it will be helpful for others also. Some more comments, Rajesh and Yogesh. So you should not tell it was everything was good. Okay.
No, already.
So hello everyone. So like Rajasri Shah mentioned, that these 3 days were really wonderful. There was a little short of time for our demonstrations, but whatever we got, we given our best. And in every demonstration, there was something to learn for everyone, I feel. Even we do these things at our science center as well, but the way we learned, the person like Tripathi sir explained, the same experiment we do, but the way of doing his way is the part of our adaptation. So that we learned the accent from Tarun sir. It was very engaging show. Sir, I said forget Srinam from Guwahati. Yeah. So this was a unique idea on the wings. So like we have seen the wings, but like how to imagine their functions. So that was like a new learning. And if we say like there were some like negative comments, the positive comments. So all are welcome. And I think that should be the part of such conclaves. We should not be afraid of the negative comments. And I say, because we are the juniors, but we have more seniors with us. So they can guide us and they can observe what was the, like the kami jo hoti hai na, that you can identify and you can guide us. So that like we really want from the seniors. Thank you.
There are no seniors and juniors because we are in that rut. You are the people not in the rut. So maybe you can give ideas which are which we don't think of. Let them come here.
First of all, I thank you on behalf of KPSC Kurukshetra for such a wonderful experience, for giving us a platform to update ourselves, more interactions among our friends with the same field. What I learned in last 3 days in brief, that we are performing science shows in our centers. But in nutshell, what I am going back with, firstly, some person were with very bulky models, bulky props, some with very little, very nice. Every person did his best. But I thought that 20 minutes, as the ma'am permitted us, that time is an ideal time for a science show. Means it should not go much long. And props may also be less in number, but main thing is the presentation and the scientific idea how we can deliver best. That is main thing. And recently from the Sir Manas Bagchi's lectures, what we can even add, that if we are emotionally directly connected to the audience, that will add fuel to our work. So need not to say that again, stay and food and every arrangement was very nice, and very, very thankful to the VITM team. Thank you, sir.
Anybody else? Aditi?
For me, more than the food and the stay, because I was a latecomer, the live streaming was very helpful. So besides the other duties, I could be following this day and night, and that was most helpful. And that led to a little bit of modifications in my script as well. I got the time advantage. So thank you so much for the entire setup. It was really a learning experience.
And how can we make it better? Maybe, please come. Rakesh.
Thank you, Team VITM. I'm not going to repeat the same thing, which my colleagues already basically made a statement here. Everything is fine. It's nicely arranged. And what we basically take away from here, because new subjects are there, new dynamic members which join the NCSM team here, they are thinking in a different way. And we take the idea, we are performing the experiment, as sir already stated, that we develop new kits. But in our center, we just get emphasized on a fun science and a liquid nitrogen show only because they are very popular. And from this last session by Mr. Bagchi sir, I just think we can develop something very good on neuroscience also. And this is a basically better way. So we are taking one thing, the new subjects, new topic for the demonstration, which we will basically pursue in the future, and we will develop. If we develop, we definitely share it with you, sir. And the second thing, every comment which we are receive here, this is the feedback, and this may be, okay, time over. अच्छा लास्ट 3 दिन से इससे बड़ा डर लग रहा है हमको. Okay. 2 minutes बस. So what we are taking away, a new topic, the feedback, and basically the development of the science show with the practice. So we have to develop the new schismas in our brain so that we can do the better presentation. Always the presentation matter in a science show. This is the main objective. And by presenting in a good way, we can deliver effective science show in a definite duration of 20 to 25 minutes. That is an ideal situation which we have to perform. And we have to select the activities and the basically props in very careful manner to do an effective science demonstration. This is all from my side. It is good. And if we pursue for 1 year, same kind of momentum, definitely we develop with new ideas. Thank you.
So practice matters, as Manesh was telling. So we need not think like Sachin Tendulkar is just gone hitting.
Sir, in connection with the Diamond Jubilee, you have arranged this workshop. But I request you, sir, as you are the authority, one of the authority of NCSM, so along with our respected Bakshi sir also, this in connection with Diamond Jubilee, but after a decade, you restored this workshop actually. Many, many thanks to you, sir. But I request it may not be in a national center. If you arrange in Calicut, if you arrange in Tirupati, any other centers, if you arrange in to stay in our floor actually, then we are not worried about this. But different places we want to see, we want to develop the NCSM units actually. So let us explore this every center. That is one request. And that's Diamond Jubilee. I again welcome for best wishes this year. Thank you so much, sir.
Very good evening. Then, first of all, I thank Director VATM for made a wonderful opportunity for the Science Show Conclave. So I extend my thanks to make me a part of that. So all demonstrations are unique. Okay, we learned a lot of things. For this demonstration, they communicated long back. They asked a topic, then the script, then we did it ourselves and we searched something. We developed the script and everything. One thing, my suggestion is, because after reaching here only, we came to know that the North Zone and West Zone, the afternoon, the second day, South Zone and all. So if you give the timing, the North Zone means this is the timing and he is going to perform, and that timing also will well known about that, then our pressure will be reduced. Okay. So if the particular time is particular person is going to perform and this is the time. Okay, 3 to 3:30 is this is the zone and he is going to perform with the topic means. So he'll be ready and our other will be little less. No, if we know the timings also, no, this is my suggestion, not the, don't take it the other way. So if we individually, if we give, this is, okay, this is the topic in order, this is the time and all. So we'll be prepared one way, then after that, other side, that pressure is flushed out. Okay, that is my only suggestion, other than remaining the transport, accommodation, food, that is excellent. That is a very, very high manner that we can. And
the idea was not to pressurize you, maybe. It was not to pressurize you. Anyhow, actually it was not, basically it was not to check what you have done or find fault with you. It was not the intention of this presentation. Okay. Yes. So, and I hope whatever suggestions was given was not to pull your leg or find fault with you. It was to maybe learn from that and go ahead. Okay. Let's Northeast में.
Hello. Yeah, my suggestion, one thing, actually, as sir mentioned, it happened long back in 2007. But like this, why it took so many years to happen again? My suggestion is to authority that every year this should happen so that we can have more number of science shows. And hello. Yeah, I'm having one observation. You see, since last 20 years I joined, okay, how many science shows we developed? Because when there is a target, we will have that pressure. Just some 10 days, some 10, 15 days before, we are busy with, okay, I think all of you know what work we are doing. We are being education officers, but what work we are doing, we know, all know. No need to tell. Okay. Because that is a fact. Okay. And when we were given the target, sir just told, yeah, sir told, yeah, something you do, whatever you want to do, just within some 10, 15 days. And frankly speaking, not even a single time we have practiced and this thing. And many people you might be thinking, okay, we are given less time, we are given more time, this thing. Before, okay. So what happens for a concise show or something, it is not the from the beginning first, okay, you make some experiment and come immediately, you have to conclude in this. It will never happen. Okay, you will not be knowing the timing and not knowing. So you need minimum at least some 10 shows if you perform, then only conduct, then only you can come to this. And like this, so targets will be given means at least some new shows will come. And this is the basics. The science show is the main thing of a demonstrator or a education officer. But so I urge that the authorities that every year it should happen. It should happen in different zones. We should be given targets so that new science show comes. It will be good for us also. And being the host, then I am yeah. Yeah, self-criticism because madam, I'm telling from one person who is performing first time something, 20 minutes is because we do not know what is the setup and what is to come and what it is not. We no, one no, not more than no. Okay, so and I feel for our shows and this thing, okay, rather than many people from outside or something, that will little reduce and these performances from our participants, time to be given more. And because it was not like, okay, we are performing in front of students or something. We are performing in front of us only or something. Then it was also, and after each show also some discussion. So timing was one factor. I believe that. And so and actually many of my friends, all are my friends, my colleagues, they have many times messaged me, if I have not arranged anything for you or something because of, please forgive me. Thank you.
So anyway, let us try to perfect whatever shows you have done. In another 3 months, perfect the show which you have done here. Huh? Sangeeta? Sitaram? She's taking a longer route after Cape of Good Hope.
I want to say many thanks to Director VITM Sir, Jyoti Madam, and all the other team member of VITM. And it is my request if Director VITM Sir may take the initiative for starting these shows, some of the shows at various science centers, at various units of NCSM, then I think it will be very helpful for all of us and also for audience visitors. So this is my suggestion. Yeah. Yes. Yes, sir. Okay. Okay, ma'am. On behalf of all my colleagues, I think we can send some videos on our shows. I'm telling that. Okay, thank you. Thank you all.
Vinoj, Punarashan. आजा यार कुछ बोलो.
Sir, as many people told, after we joined, actually, once we got an excellence in demonstration program in 2010, after that. Actually, I'm seeing Rakesh Tripathi, Rajashri, etc. now only. So it was very nice that. That is the thing. And so we are so happy that we were able to see the old friends. Then these newly joined people, they are really good. Actually, we got inspired from them. So it's a very good thing. Then, ma'am, I should not go without saying that the stay was very nice, food was very nice, transportation is very easy. So we were kept very comfortable these days, and I will not forget these days in my entire life. So it was very nice.
Special arrangements were made to ensure that the weather was also comfortable.
नमस्कार डायरेक्टर वीआईटीएम और टीम वीआईटीएम को बहुत बहुत धन्यवाद. आपने इस तरह से बहुत ही अच्छे तरीके से इस कार्यक्रम को ऑर्गेनाइज़ किया और इस डायमंड जुबली सेलिब्रेशन के लिए आप सभी को कॉन्ग्रेचुलेशंस. और ये जो परंपरा है आगे चलती रहे, हर साल इस तरह के कार्यक्रम आयोजित होते रहें. और ये बहुत अच्छा मौका था कि हम सभी जो एजुकेशन टीम है पूरे इंडिया के जो NCSM यूनिट्स की, हम एक दूसरे को देख सके. अभी तक केवल नाम से जानते थे या कभी कभार फ़ोन से बातचीत होती थी, लेकिन आज साक्षात लोगों से इंटरेक्शन हुआ और बहुत सा जो सीनियर्स जी दर्शन भी हुए और इंटरेक्शन भी हुआ. और बागची सर का काफ़ी सुझाव जो है वो भी हम लोग अपने ध्यान में रखेंगे और हम लोग नए शो डेवलप करेंगे और ज़्यादातर पब्लिक ताकि इससे लाभान्वित हो. धन्यवाद. और रहने का और आने जाने का, खाने पीने का अरेंजमेंट जो भी था बहुत ही अच्छा था. इसके लिए भी बहुत बहुत धन्यवाद.
योगेश कुछ बोलेंगे?
Thank you so much, sir, for giving this opportunity to us. सर दूसरा भी है, जैसा कि हम सब के डेमोन्स्ट्रेशन देखे हैं, लेकिन अब तक सिंसियर फीडबैक आई थिंक किसी ने दिया नहीं है. तो वो चीज़ कहीं मिसिंग है. और जब ज्योति मैम इन सब स्क्रिप्ट को या फिर हमारे जो बुकलेट्स है जब बनेंगे, तो आई रिक्वेस्ट वन एंड ऑल कि आप अपने फीडबैक्स कि कैसे हम उन चीज़ों को इम्प्रोवाइज़ कर सकते हैं या फिर कौन सी चीज़ हमसे जो मिस हुई है और वो यहाँ पे हो सकती है. इफ़ ऐसा हो तो और अच्छा हम परफॉर्म कर पाएंगे और सुधार हम ला पाएंगे. ओके. और मैं और थैंक कहना चाहूँगा एक इंसान को, जो हमारे उमेश कुमार सर है, डायरेक्टर ऑफ नेहरू साइंस सेंटर मुंबई. एक्चुअली वो हमारे पीछे सर जब पहला मेल आया था तभी से लग चुके थे और ऐसे बंदूक तान के हमारे पीछे खड़े थे. और तो सबसे पहले सर हमने हमारी स्क्रिप्ट बनाई और उसके बाद सबसे पहला जो हमारा प्रेजेंटेशन था, जो साइंस शो था, वो हमने साइंस नेशनल साइंस डे जो हमारा होता है 28 फरवरी को हमने लॉन्च किया था. और उसके बाद भी उन्होंने हमारा पीछा नहीं छोड़ा, 3 बार हमसे प्रैक्टिस करवाई. ओके. और तब जाके हम यहाँ पे प्रेजेंट कर पाए. सो वेरी बिग थैंक्स टू हिम. और उन्होंने बहुत सपोर्ट किया है और किसी चीज़ की कमी नहीं होने दी. थैंक यू सो मच सर.
Yeah, nanotechnology. Yeah, enjoyed what? Enjoyed the climate. Okay.
So good evening, everyone. First of all, I am thanking you all for giving me the opportunity to attend this program. So what I feel is, whenever we are conducting science programs, science shows, we are used to conduct liquid nitrogen shows regularly. So the students regularly participating, they will used to comment, hey, next he going to do this one, next he going to do this one. So we feel definitely we have to change this show. So we are facing the pressure from the public and student side. So what I am feeling is, so they are the ultimate master for us. So whenever we are doing demonstrations and everything, so to satisfy them, so whenever I'm making I also thought making a science show, they should satisfy. So we do the science show, just making a science show and inaugurate and place the science show kept aside, and again doing the liquidation show. It is not a good idea. So I'm thinking about that. At that time, this science conclave came. So it's a good opportunity for us. We learn a lot. And I see each person is having different approach. So we have to allow them to demonstrate their concept. So we should not restrict, this should be like this should be like that. So everyone is unique. We have to give opportunity. So thank you, sir, for giving me the opportunity. We learn a lot from here. One more thing, not only the science conclave. So whenever we are doing program, there is a little bit time only we are getting. I think we need some steel frame like concept. Detailed plan is required, I think so. So whenever program is suggested, sir, we are getting very less time to do the program. So even for this science show, I got around only 25 days to prepare this science show. So whereas remaining all are good. Thank you, sir. Thank you, ma'am, for the opportunity.
Time available is always less, so we have to utilize that. Like Bishal was telling, I know he is overloaded with many other works, but daily at least 1 hour if you utilize for such things also, I think we should be able to bring out some good things. So who else? Pandrashan.
Good evening to all. Very thankful to VITM team. And whatever program, so they were organized, so past 3 days, the sessions and the activities, so it was very useful for us to improve our effective SDL preparations. And it is helpful for us to correct whatever mistakes we have committed. So really in future, we will try to make little more better SDL kits and science show kits. So thank you for arranging wonderful arrangements. So thank you, sir. Thank you so much.
Sitaram. And our science communicators, mentors, anything to add? Adiga? Nothing. So thanks for your feedback. So what resolution will we take at the end of this? These shows, okay? Yeah. Yeah, maybe we can refine the scripts and send us again. And maybe let us hope. Okay. Yeah, okay, so Senior, you have already launched your science shows. So with others, maybe in another 3 months, if you can refine and launch these shows, that'll be a good thing. And maybe in another 1 year, each one of these zones, if they can develop one more science show, that'll be good. On a topic which we are not done at all. Something like that. What is Manish? Anything to add? Abhinadi has gone out. Abhinadi has gone out with him.
Give me a footpath to live on, I'm fine with it. Give me anything, or even without food I can work, no problem at all. So I'm not going into the arrangements are good and this, that and all that. I think that's a nonsense. Give me the scope to come. That probably is the biggest gift that I can have. In fact, I pushed into this program, almost forced myself in, imposed, intruded, whatever you say. I did that, but from my side, I'm a very, very old man and a fading man as well. So I'll suggest only one thing. Whatever you do in life, whatever, just mix 2 spoons of your soul into it. थोड़ा सा आत्मा घोल देना उसमें, महक आता है उसका. मामूली बातें नहीं करना चाहिए. People are tired, sick and tired of Arnab Goswami and all that all the day. They have heard enough of nonsense. So please don't add to this long list of nonsense anymore. If you are not liking anything that you create, you must have a very big waste paper basket. Throw it out. Try again. Now, some people were asking me that how long did you take to prepare it? Frankly speaking, almost 20 days. And Krishandu was asking, how long did you practice? And I was not lying. I tried to practice 50 times before I go on to this stage. This time I could not do that. But even then, it is not less than 20. I try to place each word and then finalize it, whether I should use this word or that, whether this construction should be placed this way or not. When you speak, the people must listen to you. I used to demonstrate Taramandal since my childhood days when I was 21. And I used to tell one thing, Taramandal ke andar sab log jab aa jate hain, people come inside that. I used to say that our Taramandal is not a very comfortable scenario. It's hot, it's small, you have to sit on the ground. But then why should you come to me and not go to a big planetarium? The only reason is, main hu na. Main hu. I was asked in my curatorial training induction program by one of our former director generals. He asked me, in your center, what is the most important object you have? He asked it to all the curators in my batch, in my group, and people said, somebody said the energy balls, somebody said this exhibit, that exhibit. I was in the last bench. I'm an eternal backbencher everywhere, right from the primary school up to the university, and I said it's me. When people interact with me, I am the museum. I am creating the image of it. So if I fail, my museum fails. If I succeed, my museum succeeds. So my only thing is that have a DNA of this council in you and stand up. If somebody says it's of no use, show them why it is. Don't leave anyone. Whosoever, how big and how important, whatever the level of the celebrity. Never care. You may be hard for that. Oh, Amitabh Bachchan का फॉर्मूला है ना, बोला देख कितना इडियट जैसा लगता है, कितना घूसा लगा तेरे को. But then the next dialogue is very important. लेकिन मैंने भी 2 मारा, solid मारा ना. तो solid पलट के मरना चाहिए 2. और जिसको लगेगा यहाँ कैरी करके लेके जाना चाहिए कि हाँ आज लगा कुछ यहाँ पे. ना? So that is the only thing. Science talking can be very, very interesting, and I request all of you to expose yourself to the international level of science presentations. Can you name a few international presenters who present science at the highest level and does it fantastically? Any names you remember? Go and see the World Science Show by Brian Greene, each and every lecture there. Go and see how Ron Hipsman presents these stories. Without this exposure, people learn by mimicking. We learn from our mother how to write the letters. We mimic our father's diction. We mimic our teacher's ideas. We mimic our friends' affections. Mimicking is not bad. If you can make creative copies, that will work. So adopt. That is not called copying, that is adoption. That is adoption of schemes, that is adoption of ideas, that is adoption of styles. In me, I feel I am myself like a very big sponge. I try to suck up all the water that is around me. So that's my request. Listen to music. See the theaters. Watch out the movies. Find out how each dialogue is placed. One of my favorite characters here, some of my friends know, is Himmat Singh. And Himmat Singh has a habit of saying things which are tongue-in-cheek and very, very sharp. And his third version, third series is coming, and the trailer blows me out with a single dialogue. He was trying to do something that his bosses did not allow accordingly, and he could not materialize it properly. So one day he was working and one of his assistants came and he asked, "हम किसके लिए काम करते हैं?" Very seriously, "हम किसके लिए काम करते हैं?" So he said, "We work for the nation, sir. We work for the country." And he said, "नहीं, हम चुतियों के लिए काम करते हैं." And that's the sharpness of this statement. He feels it in his heart. वहाँ पर bloodshed होता है, वो होना चाहिए. वो हो सकता है कि तुम्हारा बॉस हो सकता है कि भारत का प्रधानमंत्री और कोई भी. But if you feel it right, stand by it. Forcefully establish yourself. Underline your presence. Thank you.
Thanks, Manish. Thanks to all of you. What is the next agenda, Jyoti?
Good evening, everyone. So now I hope a lot has been said and a lot needs to be learnt. We are here. Before I do go for the main aspect for which I took this mic, I would like to just add one point here. While we say that it was just the 20 minutes and we really need more time, the whole aspect is it was not that outcome, the 20 minutes, it was the process through which you have really come here with. And we... वो क्या है? नहीं 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 I remembered. I remembered. Oh yes. 35 minutes में. Now I remember. Check day. So yes, so the process is in every work that we do is most important. And yes, we all had our own difficulties, our own thrills, our own challenges that we have gone through. And yes, that makes us living the moments that we lived through. We really today, we feel, okay, we sailed through these 20 minutes. Those of us who really did it, as far as the degree of perfection, that is a very individual aspect. We individually have to introspect as to what went right, what went wrong, and as per that only we can really improve upon it. So yes, going for the practical implication of the whole setting that we did, yes, we have to work on the scripts once again. Like I got to hear from Rajesh and others also now that after listening for these 3 days presentation, we feel we need to rework. And that is the success. It was not only these 3 days. This has to transform us into better communicators. And we all could prove today, each one of us spoke, most of us. So that shows that we have the passion to speak. And once that is there, yes, whatever we like to. So we need to be getting more passionate about the things that are required for the setup that we belong to. So thank you very much for everyone's participation. And I must acknowledge here at this point, it may look like a formality, but that's really not, because I was also not there for quite almost a week, and there were a lot of things we had to do. There were certain things really went well as per me, but I know there were places where things could be much, much better. And yes, that's again a learning point from our side as a coordination point of view. We will also improve the next time we meet, right? But I must convey my heartfelt thanks to our director. In his absence, the faith that he literally, he just, entrusted us with his support that, everything will go on smoothly. You can do it. Each one of us, as the first day we met with some of the colleagues that came from the other centers, there is no coordinator here. We all are here as a team. It's just a matter of fact that I am being posted here. we all can get transferred tomorrow here, or any other unit. We all belong to NCSM. We are part of this science communication organization, and we are all together in this. So each one of us has a role to make any event successful, and we all did it. That is the most successful point of this event overall. So now I would like to invite our colleague Rajarshi and I forgot Prema Dharji to please come here. They want to felicitate our director, our senior most persons who are here, Mr. Saju Bhaskar and Mr. Manas Bagchi, to please come here. They want to felicitate with the...
Sir, we are coming from Assam. Just to remind yourself, sir, as token of appreciation, sir, please accept our felicitation.
So the last announcement for this event, the show is not over yet. Tomorrow is a very, very special visit that we are going to make. We all, as science communicators, have presented the best we could based on the subject we chose. But tomorrow we are going to JNCSR, where there are scientists going to show how do they communicate chemistry majorly, but they have different domains that they are going to, they have curated the whole event for us for 3 hours, right? So I request all of you to please stay excited for tomorrow's visit. There's a lot to learn, okay? And in the process, this is an open offer to all of you. Just beside the JNCSR is a very beautiful lake. If you all are ready to wake up little early and get ready for 7:30 pickup, we must be reaching there by 8:15 or so, and you will have at least 1.5 hour that you can take a stroll of the lake. And if not, yes, we can start by 8:30 as usual, and we can make direct move to the JNCSR. That call you can take among yourself. Let me know within next half an hour or so, and then we will decide accordingly our timings. So with this, we end today's session. No, so no vehicle for the pickup of those who are being put in the accommodation place, that will go directly as usual. So the timing, as I just mentioned, that will decide in some time. For others who are going from, we have already, the education staff are going. For them, Innova is booked. So vehicle will reach here, and we'll let you know the timing for the pickup. And that's way we all will move towards that. And tomorrow our Idea Lab students are also joining in. Almost 14 to 15 students are also. So this becomes a scientific field tour for the Idea Lab students also. So with this, we disperse. Thank you everyone for your cooperation. You all decide among yourself if all want to.
8:30 means program. 7:30 means you can go to the.
So there will be an additional activity.